-6 days from the original 2-week plan. I wish soda pop would solve all my problems, but it can't. It's up to me. I'm gonna try to draw with my left hand. It's probably gonna go really bad. That looks horrible. Really, really bad. I have like a tiny nick on my right hand. It's all red and a finger. I can't find a band-aid. So I'll just draw with my left hand for now until I get a band-aid to cover it up. So hopefully I'm going to go through the JavaScript ECMA 262 standard soon. I'll have a Siri read it or whatever. Today I'm just going to convert things 64-bit. Guarantees are nice because you're guaranteed. So I have like little speed tests, and then I have parts of JavaScript Engine done, but I don't have the entire like standard supported. So like loops, I have function calls, scope and stuff, but I don't have loops set up. And I thought I could like hijack or like patch together a loop to like just run some JavaScript, like convert it over, and then run a test loop like this. Where it does like a million iterations. I wanted to like do that so it could be like I'm guaranteed that when I go through these 800 pages in the standard, I'm guaranteed that if I screw up the code or whatever, I'll still be fine. Everything will work because it's faster when I do this. But I can't even run this test because I don't have full support, and I tried to like hack together and make it run, but I can't. There's no way. I have to actually go through the entire standard to support everything needed to do like this many intensive operations and stuff. So I have no guarantees other than that I have code and stuff that does run faster than current JavaScript implementations, but there's a whole bunch of mechanics and stuff that need to be implemented from the standard whatever before I can like run test loop like this. So I'm going off the fact that I got a bunch of like small tests and stuff that are faster, and as long as the new mechanics that I add to the engine that I have are faster, it will be faster overall. But until I get there, I have no guarantees that that'll be true. So that puts extra pressure and work, because now I'm like, all I have is like these tiny little things to like rely on being true to overall make a total truth when I like go through the entire standard, which is going to take for however long. So I think I might pick through the standard, pick out things like loop scope, variable, like specific things, so I can like try to run this in my engine. But I might need to like go through the standard from top to bottom. I'm not sure yet. All I know is I got a lot to figure out still. But based off like the tiny little things I have figured out whatever, as long as I can like patch them together and stuff, I should be able to mix it all together, get something that's faster than this test or whatever in the browser. It's like, I don't know, there's a ton of stuff to do still. So like I have like knowns and unknowns. It's like the knowns I know, and I have like a list of whatever the unknowns I still have to do, and then they'll be known. But based off the amount of knowns that I have, for sure, I'm confident enough or whatever that I know I can take that, apply the rest of the stuff that I don't know yet when I get to do it. I'll be good at whatever. So like I don't know until I get there, and the only way to get there is to keep going or whatever. So the knowns that I do know is that I can't really pick between the two modes that I'm going to go with, the hash maps or the whatever. I talked about this several times, until I convert this whole thing to 64-bit. The whole thing runs, or the stuff I have right now, as 32-bit. So that's what I know. So I'm going to convert the whole thing to 64-bit now. Just going to finish it. I'm done messing around with like little tests and like trying to figure out beforehand to get some guarantees. The only guarantees I have are the ones that I know, and I can't just throw little tests together to be like, ta-da, and then like know for certain. I literally have to go through the whole mother loving standard to know anything at all for absolute certainty. And the only way to do that is to just go through the whole standard, 800 pages. I really want a guarantee before that, but I can't get that, so I gotta go off the little bits I have and apply everything together into one big mechanical whatever from all the little mechanics that make the total thing. And then I have to like change the way I was doing some things, because I found better ways, more efficient, quicker ways to write code over the last however many years. So I'm like, leave everything that I have as it is. I'll write the new code, and then later on I'll go back through and rewrite parts. I have to take out code that's not being used. So the only files that pop up when I do control F to search are the files that are actually in the build. So first I'm gonna finish converting it to 64-bit, because it's known or whatever. It runs as 32-bit. Running as 64-bit, then I'll have another thing known, and I can do my little speed test that I have. I won't be able to do the whole test I want to do, whatever. But those will still be faster. They should be, because they're faster now, so they're 2-bit. So when 64-bit is converted, they should still be faster. But I don't know, whatever. So now I'll know that it'll all be 64-bit. And then I'll know that when I add these mechanics, as long as the rest of the mechanics that I add are more efficient and faster and implemented better, the whole thing should be faster overall. So I'm going to convert this whole thing, finish up converting it. No more like messing around, throwing things together, trying to know things before I can know them, because I don't know. And even if it did survive a test like this, there's a whole bunch of other tests. I don't know. There's no way to know anything without knowing. If I don't know, whatever. So based on what I know, I'm gonna convert the whole thing 64-bit next couple days. Then I'll know, like, I'm ready to deal with the pickle business. I'll figure out if I'm gonna do just hash maps or hash maps with caching. I'll get rid of the paging and replace paging to use the hash maps. So cache, then use the hash maps, or basically just use the hash maps. If I do just the hash maps, data maps, whatever you want to call them, it's a leafy data structure. I'll have to optimize them more per map or whatever. It'll eat up memory. It'll be like fragmented memory. But if I make like a unified cache and then write back to the hash maps afterwards, the hash maps, the maps, whatever you want to call them, the memory maps, they won't have to be as optimized because there's extra layer of cache before it gets stored to the hash map. So that's like pickle business. I gotta pick one way or the other. I don't know which one's faster, and the only way to know is to test it. But I'm gonna convert the whole thing to 64-bit first, and I'll get to that, whatever. So I get Siri reading the standard stuff, and I'll get to work or whatever.
I know constructor without using new has consequences that depend on the constructor. For example, date produces a string representation of the current date and time rather than an object. Every object created by a constructor has an implicit reference, called the object's prototype, to the value of its constructor's prototype property. Furthermore, a prototype may have a non-null implicit reference to its prototype, and so on. This is called the prototype chain. One reference is made to a property in an object. That references to the property of that name in the first object in the prototype chain that contains a property of that name. In other words, first the object mentioned directly is examined for such a property. If that object contains the named property, that is the property to which the reference refers. If that object does not contain the named property, the prototype for that object is examined next, and so on. Figure 1. Object prototype relationships, CF, prototype P1, P2, implicit prototype link, explicit prototype property, CFP, CFP1, CF1, Q1, Q2, CF2, Q1, Q2, CF3, Q1, Q2, CF4, Q1, Q2, CF5, Q1, Q2. In a class-based object-oriented language, in general, State is carried by instances, methods are carried by classes, and inheritance is only of structure and behavior. In ECMAScript, the state and methods are carried by objects, while structure, behavior, and state are all inherited. All objects that do not directly contain a particular property that their prototype contains share that property and its value. Figure 1 illustrates this. CF is a constructor and also an object. 5 objects have been created by using new expressions: CF1, CF2, CF3, CF4, and CF5. Each of these objects contains properties named Q1 and Q2. The dashed lines represent the implicit prototype relationship. So, for example, CF3's prototype is CFP. The constructor, CF, has 2 properties itself, named P1 and P2, which are not visible to CFP, CF1, CF2, CF3, CF4, or CF5. The property named CFP1 and CFP is shared by CF1, CF2, CF3, CF4, and CF5, but not by CF, as are any properties found in CFP's implicit prototype chain that are not named Q1, Q2, or CFP1. Notice that there is no implicit prototype link between CF and CFP. Unlike most class-based object languages, properties can be added to objects dynamically by assigning values to them. That is, constructors are not required to name or assign values to all or any of the constructed object's properties. In the above diagram, one could add a new shared property for CF1, CF2, CF3, CF4, and CF5 by assigning a new value to the property in CFP. Although ECMAScript objects are not inherently class-based, it is often convenient to define class-like abstractions based upon a common pattern of constructor functions, prototype objects, and methods. The ECMAScript built-in objects themselves follow such a class-like pattern. Beginning with ECMAScript 2015, the ECMAScript language includes syntactic class definitions that permit programmers to concisely define objects that conform to the same class-like abstraction pattern used by the built-in objects. ECMA International 2024 5.4.3 to the strict variant of ECMAScript. The ECMAScript language recognizes the possibility that some users of the language may wish to restrict their usage of some features available in the language. They might do so in the interests of security, to avoid what they consider to be error-prone features, to get enhanced error checking, or for other reasons of their choosing. In support of this possibility, ECMAScript defines a strict variant of the language. The strict variant of the language excludes some specific syntactic and semantic features of the regular ECMAScript language and modifies the detailed semantics of some features. The strict variant also specifies additional error conditions that must be reported by throwing error exceptions in situations that are not specified as errors by the non-strict form of the language. The strict variant of ECMAScript is commonly referred to as the strict mode of the language. Strict mode selection and use of the strict mode syntax and semantics of ECMAScript is explicitly made at the level of individual ECMAScript source text units as described in 1.1.2.2. Because strict mode is selected at the level of a syntactic source text unit, strict mode only imposes restrictions that have local effect within such a source text unit. Strict mode does not restrict or modify any aspect of the ECMAScript semantics that must operate consistently across multiple source text units. A complete ECMAScript program may be composed of both strict mode and non-strict mode ECMAScript source text units. In this case, strict mode only applies when actually executing code that is defined within a strict mode source text unit. In order to conform to this specification, an ECMAScript implementation must implement both the full unrestricted ECMAScript language and the strict variant of the ECMAScript languages defined by the specification. In addition, an implementation must support the combination of unrestricted and strict mode source text units into a single composite program. Point 4 Terms and definitions. For the purposes of this document, the following terms and definitions apply. 4.1 Implementation approximated. An implementation approximated facility is defined in whole or in part by an external source but has a recommended Ideal behavior in this specification, 4.2 implementation defined. An implementation defined facility is defined in whole or in part by an external source to this specification. 3 host defined, same as implementation defined. Note editorially. See clause 4.2, 4.4 type, set of data values as defined in clause 6.4. 5 primitive value, member of one of the types undefined, null, boolean, number, big int, symbol, or string as defined in clause 6. Note a primitive value is a datum that is represented directly at the lowest level of the language implementation. Copyright sign, ECMA International 2024. 6 object, member of the type object. Note an object is a collection of properties and has a single prototype object. The prototype may be null. 7 constructor, function object that creates and initializes objects. 4.8 prototype, object that provides shared properties for other objects. 4.9 ordinary object, object that has the default behavior for the essential internal methods that must be supported by all objects. 4.10 exotic object, object that does not have the default behavior for one or more of the essential internal methods. Note any object that is not an ordinary object is an exotic object. The 4th of April 2011 standard object, object whose semantics are defined by the specification. 4.12 built-in object, object specified and supplied by an ECMAScript implementation. 4.13 undefined value, primitive value used when a variable has not been assigned a value. Note the value of a constructor's prototype property is a prototype object that is used to implement inheritance and shared properties. Note when a constructor creates an object, that object implicitly references the constructor's prototype property for the purpose of resolving property references. The constructor's prototype property can be referenced by the program expression constructor prototype, and properties added to an object's prototype are shared, through inheritance, by all objects sharing the prototype. Alternatively, a new object may be created with an explicitly specified prototype by using the object create built-in function. Note standard built-in objects are defined in this specification. An ECMAScript implementation may specify and supply additional kinds of built-in objects. ECMA International 2024-7. The 4th of April 2014 undefined type, type whose sole value is the undefined value. 4.15 null value, primitive value that represents the intentional absence of any object value. 4.16 null type, type whose sole value is the null value. 4.17 boolean value, member of the boolean type. Note there are only 2 boolean values, true and false. 4.18 boolean type, type consisting of the primitive values true and false. The 4th of April 2019 boolean object, member of the object type that is an instance of the standard built-in boolean constructor. 4.20 string value, primitive value that is a finite ordered sequence of 0 or more 16-bit unsigned integer values. 4.21 string type, set of all possible string values. 4.22 string object, member of the object type that is an instance of the standard built-in string constructor. A Boolean object is created by using the Boolean constructor in a new expression, supplying a note Boolean value as an argument. The resulting object has an internal slot whose value is the Boolean value. A Boolean object can be coerced to a Boolean value. Note a string value is a member of the string type. Each integer value in the sequence U solely represents a single 16-bit unit of UTF-16 text. However, ECMAScript does not place any restrictions or requirements on the values except that they must be 16-bit unsigned integers. A string object is created by using the string constructor in a new expression, supplying a string note value as an argument. The resulting object has an internal slot whose value is the string value. Capital A, string object can be coerced to a string value by calling the string constructor as a function. 22111. Copyright sign, ECMA International 2024. The 4th of April 2023 number value, primitive value corresponding to a double precision 64-bit binary format, i.e. E7542019. Value. Note a number value is a member of the number type and is a direct representation of a number. 4.24 number type, set of all possible number values including the special not a number, nan, value, positive infinity, and negative infinity, 4.25 number object, member of the object type that is an instance of the standard built-in number constructor, 4.26 infinity, number value that is the positive infinite number value, 4.27 nan, number value that is an i.e. EE754 2019, not a number value the 4th of April 2028 begint value, primitive value corresponding to an arbitrary precision integer value the 4th all possible begint values, 4.30 begint object, member of the object type that is an instance of the standard built-in begint constructor the 4th of April 1931 symbol value.
The only possible issue converting to 64-bit is
full type
the file descriptors for like files,
object
because those are still 32-bit.
instance of this.
The only place where maybe
Using the number.
The only file descriptor that's negative or negated is when it's like
Slot whose
not a file descriptor.
equals to
I use -1 to indicate no file descriptor or whatever.
1
And most of the time, or like all the time, whatever,
1934
it tests like a status bit, not the value of the file descriptor, to determine if the file descriptor is valid or not.
constructor.
But there may be some places, because nothing's ever certain, like truly certain,
38
that might, like, as like a second redundancy check where I like check to make sure
4 dot
that it's a -1 before assigning it.
dick of a property
So like those error checks might get screwed up.
contained by
But -1 is -1.
addition to its property
32-bit or 64-bit, it's just sign extended.
and how it behaves.
So I don't think that saving a file descriptor to
Examples of built-in functions
the 64-bit value will mess anything up,
or implementation may.
because the top 32 bits will just get discarded anyways.
Application.
So that's and like when I update it to pass in an address to the hash tree, because I'm going to use a hash map or memory mapping
Application.
instead of file descriptors.
Value may be represented.
When I replace the paging to use memory mapping,
An object.
I'll need 64-bit anyways.
Functions. Note when a function is called as a method of a
So I don't know. I just gotta convert this thing over. There might be some things that don't convert, but I'll deal with that afterwards.
may provide
So I'm gonna focus on just converting it and then figure out from there.
till 2024.
This sucks.
Property. Property of an object that is not a known property but is a property either owned or inherited of the object's prototype. Point 5 Organization of this specification. The remainder of this specification is organized as follows. Clause 5 defines the notational conventions used throughout the specification. Clauses 6 through 10 define the execution environment within which ECMAScript programs operate. Clauses 11 through 17 define the actual ECMAScript programming language, including its syntactic encoding and the execution semantics of all language features. Clauses 18 through 28 define the ECMAScript standard library. They include the definitions of all of the standard objects that are available for use by ECMAScript programs as they execute. Clause 29 describes the memory consistency model of accesses on shared array buffer back memory and methods of the atomics object. Notational conventions. Point 1 Syntactic and lexical grammars 5. 1. 1 context-free grammars. A context-free grammar consists of a number of productions. Each production has an abstract symbol called a non-terminal as its left-hand side, and a sequence of 0 or more non-terminal and terminal symbols as its right-hand side. For each grammar, the terminal symbols are drawn from a specified alphabet. A chain production is a production that has exactly one non-terminal symbol on its right-hand side along with 0 or more terminal symbols, starting from a sentence consisting of a single distinguished non-terminal, called the goal symbol. A given context-free grammar specifies a language, namely, the, perhaps infinite, set of possible sequences of terminal symbols that can result from repeatedly replacing any non-terminal in the sequence with the right-hand side of a production for which the non-terminal is the left-hand side. 1.2 The lexical and regexp grammars. A lexical grammar for ECMAScript is given in clause 12. This grammar has as its terminal symbols Unicode code points that conform to the rules for source character defined in 11.1. It defines a set of productions, starting from the goal symbol input element div, input element template tail, input element regexp, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, or input element hashbang or regexp, that describe how sequences of such code points are translated into a sequence of input elements. Input elements other than white space and comments form the terminal symbols for the syntactic grammar for ECMAScript and are called ECMAScript tokens. These tokens are the reserved words, identifiers, literals, and punctuators of the ECMAScript language. Moreover, line terminators, although not considered to be tokens, also become part of the stream of input elements and guide the process of automatic semicolon insertion. 12.10. Simple white space and single line comments are discarded and do not appear in the stream of input elements for the syntactic grammar. A multi-line comment, that is, a comment of the form comma regardless of whether it spans more than one line, is likewise simply discarded if it contains no line terminator, but if a multi-line comment contains one or more line terminators, then it is replaced by a single line terminator, which becomes part of the stream of input elements for the syntactic grammar. ECMA International 2024-11. A regexp grammar for ECMAScript is given in 2.2.2.1. This grammar also has as its terminal symbols the code points as defined by source character. It defines a set of productions, starting from the goal symbol pattern, that describe how sequences of code points are translated into regular expression patterns. Productions of the lexical and regexp grammars are distinguished by having two colons, a separating punctuation. The lexical and regexp grammars share some productions. 1.3 The numeric string grammar. A numeric string grammar appears in 7.1.4.1. It has as its terminal symbols source character, and is used for translating strings into numeric values starting from the goal symbol string numeric literal, which is similar to but distinct from the lexical grammar for numeric literals. Productions of the numeric string grammar are distinguished by having three colons, as punctuation, and are never used for parsing source text. 1.4 The syntactic grammar. The syntactic grammar for ECMAScript is given in clauses 13 through 16. This grammar has ECMAScript tokens defined by the lexical grammar as its terminal symbols. 5.1.2. It defines a set of productions, starting from two alternative goal symbols script and module, that describe how sequences of tokens form syntactically correct independent components of ECMAScript programs. When a stream of code points is to be parsed as an ECMAScript script or module, it is first converted to a stream of input elements by repeated application of the lexical grammar. This stream of input elements is then parsed by a single application of the syntactic grammar. The input stream is syntactically in error if the tokens in the stream of input elements cannot be parsed as a single instance of the goal non-terminal, script or module, with no tokens left over. When a parse is successful, it constructs a parse tree, a rooted tree structure in which each node is a parse node. Each parse node is an instance of a symbol in the grammar. It represents a span of the source text that can be derived from that symbol. The root node of the parse tree, representing the whole of the source text, is an instance of the parser's goal symbol. When a parse node is an instance of a non-terminal, it is also an instance of some production that has that non-terminal as its left-hand side. Moreover, it has 0 or more children, one for each symbol on the production's right-hand side, Each child is a parse node that is an instance of the corresponding symbol. New parse nodes are instantiated for each invocation of the parser and never reused between parsers even of identical source text. Parse nodes are considered the same parse node if and only if they represent the same span of source text, are instances of the same grammar symbol, and resulted from the same parser invocation. Note 1. Parsing the same string multiple times will lead to different parse nodes. For example, consider let str equals 1 plus 1 eval, str. Each call to eval converts the value of str into ECMAScript source text and performs an independent parse that creates its own separate tree of parse nodes. The trees are distinct even though each parse operates upon a source text that was derived from the same string value. Note 2. Parse nodes are specification artifacts, and implementations are not required to use an analogous data structure. Productions of the syntactic grammar are distinguished by having just one colon as punctuation. 2. Copyright sign, ECMA International 2024. The syntactic grammar as presented in clauses 13 through 16 is not a complete account of which token sequences are accepted as a correct ECMAScript script or module. Certain additional token sequences are also accepted, namely, those that would be described by the grammar if only semicolons were added to the sequence in certain places, such as before line terminator characters. Furthermore, certain token sequences that are described by the grammar are not considered acceptable if a line terminator character appears in certain awkward places. In certain cases, in order to avoid ambiguities, the syntactic grammar uses generalized productions that permit token sequences that do not form a valid ECMAScript script or module. For example, this technique is used for object literals and object destructuring patterns. In such cases, a more restrictive supplemental grammar is provided that further restricts the acceptable token sequences. Typically, an early error rule will then state that, in certain contexts, P must cover an N, where P is a parse node, an instance of the generalized production, and N is a non-terminal from the supplemental grammar. This means the sequence of tokens originally matched by P is parsed again using N as the goal symbol. If N takes grammatical parameters, then they are set to the same values used when P was originally parsed. If the sequence of tokens can be parsed as a single E instance of N, with no tokens left over, then we refer to that instance of N, a parse node, unique for a given P, as the N that is covered by P. All early error rules for N and its derived productions also apply to the N that is covered by P. Otherwise, if the parse fails, it is an early syntax error. 1.5 Grammar notation 5. 1. 5. 1 Terminal symbols. In the ECMAScript grammars, some terminal symbols are shown in fixed width font. These are to appear in a source text exactly as written. All terminal symbol code points specified in this way are to be understood as the appropriate Unicode code points from the basic Latin block, as opposed to any similar-looking code points from other Unicode ranges. A code point in a terminal symbol cannot be expressed by a Unicode escape sequence in grammars whose terminal symbols are individual Unicode code points, that is, the lexical, regexp, and numeric string grammars, a contiguous run of multiple fixed width code points appearing in a production is a simple shorthand for the same sequence of code points, written as standalone terminal symbols. For example, the production hex integer literal 0x hex digits is a shorthand for hex integer literal 0x hex digits. In contrast, in the syntactic grammar, a contiguous run of fixed width code points is a single terminal symbol. Terminal symbols come in two other forms. In the lexical and regexp grammars, Unicode code points without a conventional printed representation are instead shown in the form ABBREV, where ABBREV is an mnemonic for the code point or set of code points. These forms are defined in Unicode format control characters, white space, and line terminators. In the syntactic grammar, certain terminal symbols, for example identifier name and regular expression literal, are shown in italics, as they refer to the non-terminals of the same name in the lexical grammar. ECMA International 2024 13. 5. 1. 5. 2 non-terminal symbols and productions. Non-terminal symbols are shown in italic type. The definition of a non-terminal, also called a production, is introduced by the name of the non-terminal being defined followed by one or more colons. The number of colons indicates to which grammar the production belongs. One or more alternative right-hand sides for the non-terminal then follow on succeeding lines. For example, the syntactic definition while statement while expression statement states that the non-terminal while statement represents the token while, followed by a left parenthesis token, followed by an expression, followed by a right parenthesis token, followed by a statement. The occurrences of expression and statement are themselves non-terminals. As another example, the syntactic definition argument list, assignment expression argument list, assignment expression states that an argument list may represent either a single assignment expression or an argument list, followed by a comma, followed by an assignment expression. This definition of argument list is recursive, that is, it is defined in terms of itself. The result is that an argument list may contain any positive number of arguments, separated by commas, where each argument expression is an assignment expression. Such recursive definitions of non-terminals are common. 1, 5, 3 optional symbols. The subscripted suffix opt, which may appear after a terminal or non-terminal, indicates an optional symbol. The alternative containing the optional symbol actually specifies two right-hand sides, one that omits the optional element and one that includes it. This means that variable declaration binding identifier initializer opt is a convenient abbreviation for variable declaration binding identifier initializer, and that for statement for lexical declaration is a convenient abbreviation for statement for lexical declaration which in turn is an abbreviation for expression statement expression statement expression statement expression statement for ECMA International 2024 for statement for lexical declaration. So, in this example, the non-terminal for statement actually has 4 alternative right-hand sides 5, 1, 5. For grammatical parameters, a production may be parameterized by a subscripted annotation of the form parameters, which may appear as a suffix to the non-terminal symbol defined by the production. Parameters may be either a single name or a comma-separated list of names. A parameterized production is shorthand for a set of productions defining all combinations of the parameter names, preceded by an underscore, appended to the parameterized non-terminal symbol. This means that statement list, return statement, expression statement is a convenient abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, statement list in, return statement, expression statement, statement list return in. Return statement, expression statement. Multiple parameters produce a combinatory number of productions, not all of which are necessarily referenced in a complete grammar. References to non-terminals on the right-hand side of a production can also be parameterized. For example, statement list, return statement, expression statement, plus in ECMA International 2024-15 is equivalent to saying statement list, return statement, expression statement in, and expression statement in is equivalent to statement list, return statement, expression statement, and non-term e. Now reference may have both a parameter list and an opt suffix. For example, variable declaration, binding identifier initializer, plus in opt is an abbreviation for variable declaration, binding identifier initializer in. Prefixing a parameter name with on a right-hand side non-terminal reference makes that parameter value dependent upon the occurrence of the parameter name on the reference to the current production's left-hand side symbol. For example, variable declaration in binding identifier initializer in is an abbreviation for variable declaration, binding identifier initializer, variable declaration in, Binding identifier initializer in. If a right-hand side alternative is prefixed with plus parameter, that alternative is only available if the named parameter was used in referencing the production's non-terminal symbol. If a right-hand side alternative is prefixed with parameter, that alternative is only available if the named parameter was not used in referencing the production's non-terminal symbol. This means that statement list, return plus return statement, expression statement is an abbreviation for statement list, expression statement. 6. ECMA International 2024 statement list, return statement, statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return, expression statement, 1, 5, 1 of. When the words 1 of follow the colon, s, in a grammar definition, they signify that each of the terminal symbols on the following line or lines is an alternative definition. For example, the lexical grammar for ECMAScript contains the production, non-zero digit, 1 of 123,456,789, which is merely a convenient abbreviation for non-zero digit. 1, 3, 4, 5, 6, 7, 8, 9, 1, 5, 6, empty. If the phrase empty appears as the right-hand side of a production, it indicates that the production's right-hand side contains no terminals or non-terminals. 1, 5, 7 look ahead restrictions. If the phrase look ahead equals sec appears in the right-hand side of a production, it indicates that the production may only be used if the token sequence sec is a prefix of the immediately following input token sequence. Similarly, look ahead set, where set is a finite non-empty set of token sequences, indicates that the production may only be used if some element of set is a prefix of the immediately following token sequence. For convenience, the set can also be written as a non-terminal, in which case it represents the set of all token sequences to which that ECMA International 2024-17 non-terminal could expand. It is considered an editorial error if the non-terminal could expand to infinitely many distinct token sequences. These conditions may be negated. Look ahead sec indicates that the containing production may only be used if sec is not a prefix of the immediately following input token sequence, and look ahead set indicates that the production may only be used if no element of set is a prefix of the immediately following token sequence. As an example, given the definitions, decimal digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, decimal digits, decimal digit, decimal digits, decimal digit. The definition, look ahead example, n, look ahead, 1, 3, 5, 7, 9, decimal digits, decimal digit. Look ahead decimal digit matches either the letter n followed by one or more decimal digits, the first of which is even, or a decimal digit not followed by another decimal digit. Note that when these phrases are used in the syntactic grammar, it may not be possible to unambiguously identify the immediately following token sequence because determining later tokens requires knowing which lexical goal symbol to use at later positions. As such, when these are used in the syntactic grammar, it is considered an editorial error for a token sequence sec to appear in a look ahead restriction, including as part of a set of sequences. If the choices of lexical goal symbols to use could change whether or not sec would be a prefix of the resulting token sequence, 1, 5, 8, no line terminator here. If the phrase, no line terminator here, appears in the right-hand side of a production of the syntactic grammar, it indicates that the production is a restricted production. It may not be used if a line terminator occurs in the input stream at the indicated position. For example, the production, throw statement, throw, no line terminator here, expression, indicates that the production may not be used if a line terminator occurs in the script between the throw token and the expression, unless the presence of a line terminator is forbidden by a restricted production. Any number of occurrences of line terminator may appear between any two consecutive tokens in the stream of input elements without affecting the syntactic acceptability of the script, 1, 5, 9 but not The right-hand side of a production may specify that certain expansions are not permitted by using the phrase but not and then indicating the expansions to be excluded. For example, the production identifier name but not reserved word means that the non-terminal identifier may be replaced by any sequence of code points that could replace identifier name provided that the same sequence of code points could not replace reserved word. 8. Copyright sign. ECMA International 2024 5.1.5.10 Descriptive phrases. Finally, a few non-terminal symbols are described by a descriptive phrase and sans serif type in cases where it would be impractical to list all the alternatives. Source character. Any Unicode code point. Point to algorithm conventions. The specification often uses a numbered list to specify steps in an algorithm. These algorithms are used to precisely specify the required semantics of ECMAScript language constructs. The algorithms are not intended to imply use of any specific implementation technique. In practice, there may be more efficient algorithms available to implement a given feature. Algorithms may be explicitly parameterized with an ordered, comma-separated sequence of alias names which may be used within the algorithm steps to reference the argument passed in that position. Optional parameters are denoted with surrounding brackets, name, and are no different from required parameters within algorithm steps. A rest parameter may appear at the end of a parameter list, denoted with leading ellipsis, name. The rest parameter captures all of the arguments provided following the required and optional parameters into a list. If there are no such additional arguments, that list is empty. Algorithm steps may be subdivided into sequential substeps. Substeps are indented and may themselves be further divided into indented substeps. Outline numbering conventions are used to identify substeps with the first level of substeps labeled with lowercase alphabetic characters and the second level of substeps labeled with lowercase Roman numerals. If more than 3 levels are required, these rules repeat with the fourth level using numeric labels. For example, top level step A substep B substep, I substep, substep, a substep, I substep. A step or substep may be written as an if predicate that conditions its substeps. In this case, the substeps are only applied if the predicate is true. If a step or substep begins with the word else, it is a predicate that is the negation of the preceding if predicate step at the same level. A step may specify the iterative application of its substeps. A step that begins with assert asserts an invariant condition of its algorithm. Such assertions are used to make explicit algorithmic invariants that would otherwise be implicit. Such assertions add no additional semantic requirements and hence need not be checked by an implementation. They are used simply to clarify algorithms. Algorithm steps may declare named aliases for any value using the form let x be some value. These aliases are reference-like in that both x and some value refer to the same underlying data and modifications to either are visible to both. Algorithm steps that want to avoid this reference-like behavior should explicitly make a copy of the right-hand side. Let x be a copy of some value creates a shallow copy of some value. Once declared, an alias may be referenced in any subsequent steps and must not be referenced from steps prior to the alias's declaration. Aliases may be modified using the form set x to some other value. 2.1 Abstract operations. In order to facilitate that using multiple parts of this specification, some algorithms, called abstract operations, are named and written in parameterized functional form so that they may be referenced by name from within other algorithms. Abstract operations are typically referenced using a functional application style such ECMA International 2024-19 as operation name, arg1, arg2. Some abstract operations are treated as polymorphically dispatched methods of class-like specification abstractions. Such method-like abstract operations are typically referenced using a method application style such as some value operation name, arg1, arg2, 2. Directed on.
Okay, so now, I'm trying to focus and make some progress. I think I might need
definitions will typically
to write some things in assembly. I don't want to go to assembly language or whatever Because then I gotta like write for like the CPU, and it won't apply to like, it'll apply to like majority.
The last terminal that
I'm just gonna like convert everything over to 64-bit and figure out from there. I don't know. This would be a lot more work than I wanted.
Steps 1, 3, and 4 in the following algorithm. Let status be syntax directed.
If I could like hack together a test to prove that it's faster all the time without doing the full standard, because a couple like tests with like operations and doing this and that doesn't prove overall the whole thing until I do the whole thing. So I just gotta do the whole thing.
Of block. The evaluation operation an algorithm without production. Case. Operation operation includes an
so much work.
Statement list. Return evaluation of statement list 5, 2, 3 runtime semantics. Algorithms which specify semantics that must be called at runtime are called runtime semantics. Runtime semantics are defined by abstract operations or syntax-directed operations. 2, 3, 1 compile T on completion record. The abstract operation completion takes argument completion record, a completion record, and returns a completion record. It is used to emphasize that a completion record is being returned.
I still need to like update the YouTube stuff. I'll just like leave the screen on or whatever. I'll open up tabs first.
Exception. Algorithm.
Or desktops, whatever.
Such as 1. Throw a type error exception. Mean the same.
I'm so annoyed. I wanted to throw together a little test to like be guaranteed anything. And I gotta like, the only thing I'm guaranteed is that
argument to argument.
As long as I write things like the for loop, the while loop, scope, all the other little things in the engine, as long as all those mechanics are faster than JavaScript right now, then I'm good. But that's like a lot more pressure.
Pertaining to return if abrupt. Algorithm steps that say.
Because now I have to like literally make sure all the code I write is optimal in some way.
Argument is not.
Because like the weakest link will be whatever part of the code is not fast. Right now, the little tests I got and stuff, it's all fast because I wrote specifically the operations, specifically this, the parts that were slow in general. But I can't just throw in loop constructs, control flow, and stuff without optimizing it for the operations. Because I tried. Spent like 5-6 days trying to like hack together a demo. There's no way I can hack it together. I gotta do the whole thing from bottom up. The entire freaking 800, maybe I could meet the 200 page standard and then update it to the 800 page standard.
specifications.
I think I might do that. That might be my best choice, my best option. And then I'll have the 200-page standard met. And I'll just go through. I am going to do that. That's what I'm going to do. 800 pages is a lot of fucking pages. The mic just like cut out. That sounded weird.
Step. These cases are when the result of apply.
I think I'm gonna do that. I think it's like 2009, 2008 standard. I don't know. I have an older standard that's smaller. I think I'll meet the smaller standard and I'll update it to the newer standard after that. Because I'm pretty sure they just added stuff to it. So most of it will probably be met when I do the 200-page standard.
Empty.
That makes it seem much more manageable and it's not as overwhelming. And then I'll be able to do a test like this quicker. So if I go through the 800-page standard, it's going to take more time to pick out what I need to do like basic control flow that meets the JavaScript syntax. Whatever how it's set up. If I do a 200-page standard, I'll be able to go through it much quicker and I'll be able to like do this kind of a test or whatever.
Script or module.
So I think we do that.
Additional rules are needed that make
Because 200 pages is a lot more manageable than 800 pages. Like, a lot more manageable.
rules have names and typically are defined using an algorithm. Named static semantic rules are associated with grammar productions, and a production that has multiple alternative definitions will typically have for each alternative a distinct algorithm for each applicable named static semantic rule. A special kind of static semantic rule is an early error rule. Early error rules
So that throws off my whole plan to just go for it, because I can't just go for it. That'd be crazy.
error rules are
That'd be too crazy. I'm gonna have to like take baby steps.
prior to the
I don't want to like get pigeonholed or totally screwed. So I'll go like little bit by little bit. Kind of like
numeric values.
what was it? One small step for man, if you believe in the moon landing. Because why would you doubt that they went to the moon? I mean, there's no reason for any doubt.
Values begins representing a one-to-one
Facts.
Numerical values are distinguished among different numeric kinds using subscript suffixes. The subscript refers to numbers, and the subscript Z refers to big-ints. Numeric values without a subscript refer to mathematical values. Numeric operators such as plus, equals.
So I'm changing up my plans here. I have to like keep things more realistic. I can't hack together code to like just run a test to prove whatever without implementing the whole thing.
Applied to number 75420.
I doubt I'd be able to go through 800 pages without losing all kinds of hope, because that's such a long, it's 800 pages.
Such as in the phrase.
I'm gonna have to do something smaller, like 200 pages.
Specifying a numeric kind. The phrase
So like add that to my notes here.
as such. For example, the number value for the number of code points in, or the big int value for numeric operators applied to mixed-type operands, such as a number and a mathematical value, are not defined and should be considered.
What do they call it? Chapter A and Chapter B? I don't know.
Base 10.
I don't want to give it numbers.
Or AF as base 16 values. When the term integer is used in this specification, it refers to a mathematical value which is in the set of integers.
I want to put the man shrug emoji, but I can't. I'm not connected to the internet. I don't know what the shortcut is to pull up emojis. It's not worth Googling.
Number is denoted as the number value for x or x, and is defined in 6, 1, 6, 1. A conversion from an integer x to a big int is denoted.
So the smallest standard that I found that doesn't have the word leak is the newer standard has the word leak in it. I don't know. I won't go through that again.
Mathematical value of +0 and -0 is the mathematical value 0. The mathematical value of non-finite values is not defined. The extended mathematical value of x is the mathematical value of x for finite values, and is plus and for plus and, respectively. It is not defined for NaN, ECMA intern, National 2024-20.
So 2009 standard is the
absolute value of x, which is x of x, 0 and otherwise is x itself. The mathematical function min, x1.
It's only 200.
The mathematical function max, x1, x2.
The last page is a page. Stack, cover, whatever.
The domain and range of these mathematical functions.
So the 2009 standard is only 241 pages.
Finite and non-zero.
And the 2024
K, abs, y, and x.
Yeah, 2024 standard is
Clamping x between lower and upper, where x is an extended mathematical value and lower and upper mathematical values such that lower upper produces lower if x, lower produces
804 pages. So my new plan is to do
equals x modulo 1. The mathematical function truncate x removes the fractional part.
I'm gonna meet the 2009 standard first for the sake of how many pages less it is.
X, abs, floor, and truncate are not defined for numbers and big ints, and any usage of those methods that have non-mathematical value arguments would be an editorial error in this specification. An interval from lower bounded to upper.
Because it's gonna be easier to meet the 241 page standard. And then most of this will apply to the new standard. It'll just be stuff that's added on. So that's my new plan. Since I can't get a speed test that I wanted to do, I'm gonna meet this standard first, and I'll be able to run that test first, whatever. And I might not meet the standard 100%. I might like cherry pick like the main fundamentals, and like keep in mind that I'm gonna have to like expand on that when I get to the 800 page standard. But that way this is a more compact, I don't know. This makes sense to me. I'm gonna do that. So I'm gonna do this first, 2009 standard, then I'll do the 2024 standard.
For example, the interval from 1, inclusive, to 2, exclusive, consists of all mathematical values between 1 and 2, including 1 and not including 2. For the purpose of defining intervals, -0, +0. So, for example, an inclusive interval with a lower bound of +0 includes +0 but not -0.
So we got chapter A, chapter B.
ECMAScript language values are displayed in bold. Examples include null, true, or hello. These are distinguished from ECMAScript source texts such as function prototype apply all at n equals 42, 2.7 identity. In this specification, both specification values and ECMAScript language values are compared for equality. When comparing for equality, values fall into one of two categories. Values without identity are equal to other values without identity if all of their innate characteristics are the same. Characteristics such as the magnitude of an integer or the length of a sequence. Values without identity may be manifest without prior reference by fully describing their characteristics. In contrast, each value with identity is unique and therefore only equal to itself. Values with identity.
Okay, so this seems more like a realistic approach. Doing the 200 page standard and then going from there to 800.
References to these values must be explicitly passed from one place to another. Some values with identity are mutable and therefore can have their characteristics except their 24. Copyright sign, ECMA International 2024. Identity, changed in place, causing all...
I gotta go think some more. I'll be or be. I have to take a whole bunch of new things into account. I don't know. This is real-time coding. Things are gonna change in real time at any time. There are no guarantees of anything until it's guaranteed, but until then it's not. I don't know what I'm saying. I gotta think things through really quick. But I think this is a better way to handle this instead of just jumping into an 800 page standard, because that could easily become overwhelming.
Abstract operations, including syntax-directed operations, host hooks, etc. Specification values with specification identity include sets and relations, abstract closures, data blocks.
So, I don't know. I'll do two standards then. The first one, 2009, is smaller than the 800 page 2024 standard. And if they happen to make a 2025 standard release, hopefully it's before I go in to 24 standard, and it happens, and that could just change this to 2025. I really hope a new standard isn't released as I'm going through the 2024 standard, because if it is, then I have to add another chapter and go through 2025. It'd probably be 900 pages. They probably add a whole bunch of stuff. So I really hope that will probably happen with my luck. But assuming that doesn't happen and there is no 2025 standard release update, I think this is the way to go with approaching this whole thing. So I'll here be.
Script language types are undefined: null, boolean, string, symbol, number, big int, and object. An ECMAScript language value is a value that is characterized by an ECMAScript language type, 1.1 the undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined, 1.2 the null type. The null type has exactly one value, called null6, 1. 3 the boolean type. The boolean type represents a logical entity having two values, called true and false. ECMA International 2024-25. 6. 1. For the string type. The string type is the set of all ordered sequences of 0 or more 16-bit unsigned integer values. Elements. Up to a maximum length of 253 elements. The string type is generally used to represent textual data in a running ECMAScript program, in which case each element in the string is treated as a UTF-16 code unit value. Each element is regarded as occupying a position within the sequence. These positions are indexed with non-negative integers. The first element, if any, is at index 0, the next element, if any, at index 1, and so on. The length of a string is the number of elements, that is, 16-bit values within it. The empty string has length 0 and therefore contains no elements. ECMAScript operations that do not interpret string contents apply no further semantics. Operations that do interpret string values treat each element as a single UTF-16 code unit. However, ECMAScript does not restrict the value of or relationships between these code units, so operations that further interpret string contents as sequences of Unicode code points encoded in UTF-16 must account for ill-formed subsequences. Such operations apply special treatment to every code unit with a numeric value in the inclusive interval from 0xD800 to 0xDBFF, defined by the Unicode standard as a leading surrogate, or more formally as a high surrogate code unit. And every code unit with a numeric value in the inclusive interval from 0xDC00 to 0xDFFF, defined as a trailing surrogate, or more formally as a low surrogate code unit. Using the following rules, a code unit that is not a leading surrogate and not a trailing surrogate is interpreted as a code point with the same value. A sequence of two code units, whether first code unit C1 is a leading surrogate and the second code unit C2 a trailing surrogate, is a surrogate pair and is interpreted as a code point with the value C1 0xD800, 0 times 400 plus C2 0xDC00 plus 0 times 10,000, C1 1, 1, 3. A code unit that is a leading surrogate or trailing surrogate, but is not part of a surrogate pair, is interpreted as a code point with the same value. The function string prototype normalize, C22, 1, 3, 1, 5, can be used to explicitly normalize a string value. String prototype locale compare, C22, 1, 3, 1, 2, internally normalizes string values, but no other operations implicitly normalize the strings upon which they operate. Operation results in not language and or locale sensitive unless stated otherwise. In this specification, the phrase the string concatenation of A, B, where each argument is a string value, a code unit, or a sequence of code units, denotes the string value whose sequence of code units is the concatenation of the code units. In order of each of the arguments, in order, the phrase the substring of S from inclusive start to exclusive end, where S is a string value or a sequence of code units and inclusive start and exclusive end are integers, denotes the string value consisting of the consecu type code units of S beginning at index inclusive start and ending immediately before index exclusive end, which is the empty string when inclusive start equals exclusive end. If the to suffix is omitted, the length of S is used as the value of exclusive end. The phrase the ASCII word characters denotes the following string value, which consists solely of every letter and number in the Unicode basic Latin block along with U plus 005F. Low line. Abokdefkijekmnopkristavwexes abokdefkijekmnopkristavwexes 012345678 For historical reasons, it has significance to various algorithms. 1, 4, 1 string index of string search value from index. The abstract operation string index of takes argument string, a string, search value, a string, and from index, a non-negative integer, and returns an integer. It performs the following steps when called. Let len be the length of string. If search value is the empty string and from index len, return from index. Let search len be the length of search value. Note the rationale behind this design was to keep the implementation of strings as simple and high-performing as possible. If ECMAScript source text is in normalized form C, string literals are guaranteed to also be normalized, as long as they do not contain any Unicode escape sequences. 6. ECMA International 2024. 4. For each integer I such that from index I len, search a len, in ascending order. Do a let candidate be the substring of string from I to I plus search len. B if candidate is search value, return I, return -1. Note 2 this algorithm always returns -1 if from index plus the length of search value, the length of string, 1.5 the symbol type. The symbol type is the set of all non-string values that may be used as the key of an object property. 6. 1. 7. Each possible symbol value is unique and immutable. Each symbol value immutably holds an associated value called that is either undefined or a string value. 1. 5. 1. Well-known symbols. Well-known symbols are built-in symbol values that are explicitly referenced by algorithms of this specification. They are typically used as the keys of properties whose values serve as extension points of a specification algorithm. Unless otherwise specified, well-known symbols values are shared by all realms. 9.3. Within this specification a well-known symbol is referred to by using a notation of the format @name, where name is one of the values listed in Table 1. Table 1. Well-known symbols. Note 1 if search value is the empty string and from index the length of string, this algorithm returns from index. The empty string is effectively found at every position within a string, including after the last code unit. Specification name, description, value and purpose. @async iterator, symbol async iterator, a method that returns the default async iterator for an object. Called by the semantics of the for await of statement @hasInstance, symbol hasInstance, a method that determines if a constructor object recognizes an object as one of the constructor's instances. Called by the semantics of the instantiaf operator @is concat spreadable, symbol is concat spreadable, a Boolean valued property that if true indicates that an object should be flattened to its array elements by array prototype concat @iterator, symbol iterator, a method that returns the default iterator for an object. Called by the semantics of the for of statement @match, symbol match, a regular expression method that matches the regular expression against a string. Called by the string prototype match method. Copyright sign, ECMA International 2024. 7. Table 1. Well-known symbols. Continued. Specification name, description, value and purpose. @match all, symbol match all, a regular expression method that returns an iterator that yields matches of the regular expression against a string. Called by the string prototype match all method. @replace, symbol replace, a regular expression method that replaces matched substrings of a string. Called by the string prototype replace method. @search, symbol search, a regular expression method that returns the index within a string that matches the regular expression. Called by the string prototype search method. @species, symbol species, a function valued property that is the constructor function that is used to create derived objects. @split, symbol split, a regular expression method that splits a string at the indices that match the regular expression. Called by the string prototype split method. @toPrimitive, symbol to primitive, a method that converts an object to a corresponding primitive value. Called by the toPrimitive abstract operate ion. @toString tag, symbol to string tag, a string valued property that is used in the creation of the default string description of an object. Accessed by the built-in method object prototype to string. @unscopables, symbol unscopables, an object valued property whose own and inherited property names are property names that are excluded from the with environment bindings of the associated object. 6. 1. 6 numeric types. ECMAScript has 2 built-in numeric types, number and bigint. The following abstract operations are defined over these numeric types. The result column shows the return type, along with an indication of it is possible for some invocations of the operation to return an abrupt completion. Table 2. Numeric type operations. Operation. Example source. Invoked by the evaluation semantics of result. Number. Unary minus x. Unary. Operator. Number. Bigint. Unary minus bigint. Number. Bitwise not x. Bitwise not operator. Number. Bigint. Bitwise not bigint. Number. Exponentiate xy. Exponentiation operator and mathpal. Base. Exponent. Number. 28. ECMA International 2024. Table 2. Numeric type operations. continued operation. Example source, invoked by the evaluation semantics of result, big int, exponentiate, either a normal completion containing a big int or a throw completion. Number, multiply, xy, multiplicative operators. Number, big int, multiply, big int. Number, divide, xy, multiplicative operators. Number, big int, divide, either a normal completion containing a big int or a throw completion. Number, remainder, x% y, multiplicative operators. Number, big int, remainder, either a normal completion containing a big int or a throw completion. Number, add, x plus x plus y, postfix increment operator, prefix increment operator, and the addition operator, plus, number, big int, add, big int, number, subtract, xy, postfix decrement operator, prefix decrement operator, and the subtraction operator. Number, big int, subtract, big int, number, left shift, x, y.
Okay, so, I don't know. I'm gonna get to converting the rest of it. 64-bit. And that's, thing for now.
Int, number, unsigned right shift, x, y, the unsigned right shift operator. Number, big int, unsigned right shift, a throw.
I gotta take this whole thing in, like, smaller chunks or whatever. I can't just hack it all together, so doing the 200 page standard than the 800 newer page standard. That's a good way to handle it. And after I convert this thing 64-bit, I'm gonna also, like I said with the file descriptors, they're 32-bit, storing them as 64-bit, passing them around as 64-bit. I'll have more stuff, whatever, after I convert it. I'll do with it when I get to it.
Via same value, x, y, to test exact value equality, boolean, number, same value 0, x includes, y, array, map, and set methods. Via same value 0, x, y, to test value equality, ignoring the difference between +0 and -0, boolean, number, bitwise and x and y, binary bitwise operator.
So instead of trying to, like, plan ahead, it's really not possible, I'm gonna focus on this and get to working now, converting it, the rest of the program. I have to make defines for the literals and stuff. I still have to finish tagging types. I'm done trying to, like, hack stuff together and run, like, a simple test, not simple, and run a test that won't really, that's not testable until I actually meet the full standard. I thought I could, like, hack together the stuff that I have that works to a full demo, but I can't. I have to literally have an entire demo ready, all the logic, the whole thing has to be prepared and ready to run and set up. I'm gonna need a parser. I can't just convert things by hand. It takes way too long. So instead of bothering, that's what I was trying to do up here, whatever, I'm gonna just finish converting it to 64-bit. Stuff's gonna come up after this I have to fix or account for that doesn't work between 32-bit and 64-bit, so I'll do that. I'm not gonna think ahead. First I'm just gonna get this done, then this stuff, that whatever happens. I'm not gonna bother.
Could lose precision or truncate. These legacy implicit conversions are maintained for backward compatibility, but not provided for big int in order to minimize opportunity for.
And then picking if I'm gonna use hash maps or caching with hash maps, I'll think about that later. That's a whole other thing. But then after that, I'm going to go through 200, create standard, then 800, create standard, and then the epilogue. I'm going to finalize the engine and then adjust and add browser support for like other features or whatever. So I'm doing this for now. I'm going to start doing this. I'm going to stop talking now. And I don't know. I think this is a better approach based on the current like real life variables I have to work with and the conditions that have to be met to meet other conditions to complete whatever. So I don't know. I'm gonna get to programming now. Stop talking.
Is an integer in the interval from 252, inclusive, to 253, exclusive, and e is an integer in the inclusive interval from -1074 to 971. The remaining 9, 007, 199, 254, 740, 990, that is, 253 values are denormalized, having the form SM2e, where s is 1 or -1, m is an integer in the interval from 0, exclusive, to 252, exclusive, and e is -1074. Note that all the positive and negative integers whose magnitude is no greater than 253 are representable in the number type. The integer 0 has two representations in the number type, +0 and -0. A finite number has an odd significand if it is non-zero and the integer m used to express it, in one of the two forms shown above, is odd. Otherwise, it has an even significand. In this specification, the phrase the number value for x where x represents an exact real mathematical quantity which might even be an irrational number such as b means a number value chosen in the following manner. Consider the set of all finite values of the number type, with -0 removed and with two additional values added, to it that are not representable in the number type, namely 21,024, which is +1 times 253 2,971, and -21,024, which is -1 times 253 2,971. Choose the member of this set that is closest in value to x if two values of the set are equally close. Then the one with an even significand is chosen. For this purpose, the two extra values 21,024 and -21,024 are considered to have even significance. Finally, if 21,024 is chosen, replace it with plus. If -21,024 is chosen, replace it with. If +0 was chosen, replace it with -0 if and only if x, 0, any other chosen value is used unchanged. The result is the number value for x. This procedure corresponds exactly to the behavior of the IEEE 754-2019 round ties to even mode. The number value for plus is plus, and the number value for is. Some ECMAScript operators deal only with integers in specific ranges such as the inclusive interval from -231 to 231.1 or the inclusive interval from 0 to 216.1. These operators accept any value of the number type but first convert each such value to an integer value in the expected range. See the descriptions of the numeric conversion operations in 7.1,1, 6, 1, 1 number, unary minus, x. The abstract operation number, unary minus takes argument x, a number, and returns a number. It performs the following steps when called. If x is nan, return the result of negating x. That is, compute a number with the same magnitude but opposite sign. ECMA International 2024-31 6 1 6 1 2 num. Bitwise not x. The abstract operation number, bitwise not takes argument x, a number, and returns an integral number. It performs the following steps when called. Let old value be to int 32. X. Return the result of applying bitwise complement to old value. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 3 number, exponentiate, base, exponent. The abstract operation number, exponentiate takes arguments base, a number, and exponent, a number, and returns a number. It returns an implementation approximated value representing the result of raising base to the exponent power. It performs the following steps when called. If exponent is nan, return nan. If exponent is either plus 0 or minus 0, return 1. If base is nan, return nan. If base is plus, then if exponent plus 0, return plus. Otherwise, return plus 0, 5. If base is, then if exponent plus 0, then if exponent is an odd integral number, return. Otherwise, return plus. B else, if exponent is an odd integral number, return minus 0. Otherwise, return plus 0. If base is plus 0, then if exponent plus 0, return plus 0. Otherwise, return plus. If base is minus 0, then if exponent plus 0, then if exponent is an odd integral number, return minus 0. Otherwise, return plus 0. B else, if exponent is an odd integral number, return. Otherwise, return plus. Assert, base is finite and is neither plus 0 nor minus 0. If exponent is plus, then if abs r base 1, return plus. B if abs r base equals 1, return nan. C if abs r base 1, return plus 0, 0. If exponent is, then if abs r base 1, return plus 0. B if abs r base equals 1, return nan. C if abs r base 1, return plus 1. Assert, exponent is finite and is neither plus 0 nor minus 0. 2. If base minus 0 and exponent is not an integral number, return nan. 3. Return an implementation approximated number value representing the result of raising r base to the r exponent power, the result of base exponent when base is 1 or minus 1 and exponent is plus or when base note is 1 and exponent is nan, differs from IEE 754-2019. The first edition of ECMAScript specified a result of nan for this operation, whereas later revisions of IEE 754 specified 1. The historical ECMAScript behavior is preserved for compatibility reasons. 2. ECMA International 2024 6 1 6 1 for number multiply x y. The abstract operation number multiply takes arguments x, a number, and y, a number, and returns a number. It performs multiplication according to the rules of IEE 754-2019, binary double precision arithmetic, producing the product of x and y. It performs the following steps when called. IFXA, B, C, IFA, B, C, IFXA, B, IFA is nan or y is nan. Return nan is either plus or. Then, if y is either plus 0 or minus 0, return nan. If y plus 0, return x. Return x is either plus or. Then, if x is either plus 0 or minus 0, return nan. If x plus 0, return y. Return y is minus 0. Then, if y is minus 0 or y minus 0, return plus 0. Else, return minus 0 is minus 0. Then, if x minus 0, return plus 0. Else, return minus 0. B. Return r x r y. Note finite precision multiplication is commutative, but not always associative. 6 1 6 1 5 number divide x y. The abstract operation number divide takes arguments x, a number, and y, a number, and returns a number. It performs division according to the rules of IEE 754-2019, binary double precision arithmetic, producing the quotient of x and y where x is the dividend and y is the divisor. It performs the following steps when called. IFXA, B, C, IFA, IFA, A, IFXA, B, C, IFA, IFA is nan or y is nan. Return nan is either plus or. Then, if y is either plus or, return nan. If y is plus 0 or y plus 0, return x. Return x is plus. Then, if x is plus 0 or x plus 0, return plus 0. Otherwise, return minus 0 is Then, if x is plus 0 or x plus 0, return minus 0. Otherwise, return plus 0 is either plus 0 or minus 0. Then, if y is either plus 0 or minus 0, return none. If y plus 0, return x is plus 0. Then, if x plus 0, return plus. Otherwise, return is minus 0. Then, if x plus 0, return. Otherwise, return plus a. Return r x r y. ECMA International 2024 33 6 1 6 1 6 number. Remainder n d. The abstract operation number. Remainder takes arguments n, a number, and e, a number, and returns a number. It yields the remainder from an implied division of its operands where n is the dividend and d is the divisor. It performs the following steps when called. If n is nan or d is nan, return nan. If n is either plus or, return nan. If d is either plus or, return n. If d is either plus 0 or minus 0, return nan. If n is either plus 0 or minus 0, return n. Assert n and d are finite and non-zero. Let quotient be r, n, r, d. Let q be truncate, quotient. Let r be r, n, r, d, q. 0. If r equals 0 and n minus 0, return minus 0. 1. Return r. Note 2. The result of a floating point remainder operation as computed by the percent operator is not the same as the remainder operation defined by IEEE 754-2019. The IEEE 754-2019 remainder operation computes the remainder from a rounding division, not a truncating division, and so its behavior is not analogous to that of the usual integer remainder operator. Instead, the ECMAScript language defines percent on floating point operations to behave in a manner analogous to that of the Java integer remainder operator. This may be compared with the C library function fmod, 1, 6, 1, 7 number, add, x, y. The abstract operation number, add takes arguments x, a number, and y, a number, and returns a number. It performs addition according to the rules of IEEE 754-2019, binary double precision arithmetic, producing the sum of its arguments. It performs the following steps when called. If x is nan or y is nan, return nan. If x is plus and y is, return nan. If x is and y is plus, return nan. If x is either plus or, return x. If y is either plus or, return y. Assert x and y are both finite. If x is minus 0 and y is minus 0, return minus 0. Return r, x plus r, y. Note finite precision addition is commutative, but not always associative. 6, 1, 6, 1, 8 number. Subtract x, y. The abstract operation number. Subtract takes arguments x, a number, and y, a number, and returns a number. It performs subtraction, producing the difference of its operands. X is the minuend and y is the subtrahend. It performs the following steps when called. Return number, add, x, number, and array minus, y. 34. ECMA International 2024. Note 1 in C and C++. The remainder operator accepts only integral operands. In ECMAScript, it also accepts floating point operands. Note, it is always the case that x, y produces the same result as x plus y. 6, 1, 6, 1, 9 number. Left shift, x, y. The abstract operation number. Left shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be to int 32. X, let renum be to int 32. Y, let shift count be r, renum, modulo 32. Return the result of left shifting num by shift count bits. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 1, 0 number. Signed right shift, x, y. The abstract operation number. Signed right shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be to int 32 x, let renum be to int 32 y, let shift count br renum modulo 32, return the result of performing a sign extending right shift of num by shift count bits. The most significant bit is propagated. The mathematical value of the result is exactly representable as a 32-bit 2's complement bit string, 1, 6, 1, 1, 1 number, and signed right shift, x, y, the abstract operation number, and signed right shift takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be to int 32 x, let renum be to int 32 y, let shift count br renum modulo 32, return the result of performing a zero filling right shift of num by shift count bits. Vacated bits are filled with 0. The mathematical value of the result is exactly representable as a 32-bit unsigned bit string, 1, 6, 1, 1, 2 number, less than, x, y, the abstract operation number, less than takes arguments x, a number, and y, a number, and returns a boolean or undefined. It performs the following steps when called. If x is nan, return undefined. If y is nan, return undefined. If x is y, return false. If x is plus 0 and y is minus 0, return false. If x is minus 0 and y is plus 0, return false. Capital I. If x is plus, return false. If y is plus, return true. If y is, return false. If x is, return true. 0. Assert x and y are finite. 1. If r, x, r, y, return true. Otherwise, return false. 1, 6, 1, 1, 3 number, equal, x, y, the abstract operation number, equal takes arguments x, a number, and y, a number, and returns a boolean. It performs the following steps when called. If x is nan, return false. If y is nan, return false. ECMA International 2024-35. 3. If x is y, return true. If x is plus 0 and y is minus 0, return true. If x is minus 0 and y is plus 0, return true. Return false. 1, 6, 1, 1, 4 number, same value, x, y, the abstract operation number, same value takes arguments x, a number, and y, a number, and returns a boolean. It performs the following steps when called. If x is nan and y is nan, return true. If x is plus 0 and y is minus 0, return false. If x is minus 0 and y is plus 0, return false. If x is y, return true. Return false. 1, 6, 1, 1, 5 number, same value 0, x, y, the abstract operation number, same value 0 takes arguments x, a number, and y, a number, and returns a boolean. It performs the following steps when called. If x is nan and y is nan, return true. If x is plus 0 and y is minus 0, return true. If x is minus 0 and y is plus 0, return true. If x is y, return true. Return false. 1, 6, 1, 1, 6 number bitwise op, x, y, the abstract operation number bitwise op takes arguments op, and, or, x, a number, and y, a number, and returns an integral number. It performs the following steps when called. Let num be to int 32, x, let renum be to int 32, y, let bits be the 32-bit 2's complement bit string representing r, num, let rebits be the 32-bit 2's complement bit string representing r, renum. If op is and, then, a let result be the result of applying the bitwise and operation till bits and rebits. Else if op is, then, a let result be the result of applying the bitwise exclusive or, XOR, operation till bits and rebits. Else, assert, op is, be let result be the result of applying the bitwise inclusive or operation till bits and rebits. Return the number value for the integer represented by the 32-bit 2's complement bit string result, 1, 6, 1, 1, 7 number, bitwise and, x, y, the abstract operation number, bitwise and takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, and x, y, 1, 6, 1, 18 number, bitwise or x, y, the abstract operation number, bitwise or takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, x, y, 6, ECMA International 2024, 6, 1, 6, 1, 19 number, bitwise or x, y, the abstract operation number, bitwise or takes arguments x, a number, and y, a number, and returns an integral number. It performs the following steps when called. 1. Return number bitwise op, x, y, 1, 6, 1, 20 number, to string, x, radix, the abstract operation number, to string takes arguments x, a number, and radix, an integer in the inclusive interval from 2 to 36, and returns a string. It represents x as a string using a positional numeral system with radix. The digits used in the representation of a number using radix are taken from the first R code units of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is in order. The representation of numbers with magnitude greater than or equal to 1 never includes leading zeros. It performs the following steps when called. If x is nan, return nan. If x is either plus 0 or minus 0, return 0. If x minus 0, return the string concatenation of a number, to string, x, radix. If x is plus, return infinity. Let n, k, and s be integers such that k1, radix 1s, radix, s radix, k, is x, and k is as small as possible. Note that k is the number of digits in the representation of s using radix, that s is not divisible by radix, and that the least significant digit of s is not necessarily uniquely determined by these criteria. If radix 10 or n is in the inclusive interval from -5 to 21, then if nk, then I return the string concatenation of the code units of the k digits of the representation of s using radix, n, k occurrences of the code unit 0 times 0030, digit 0, b else if n, 0, then I return the string concatenation of the code units of the most significant n digits of the representation of s using radix. The code unit 0 times 002e, full stop. The code units of the remaining k, n digits of the representation of s using radix. See else. I assert n02. Return the string concatenation of the code unit 0 times 0030, digit 0. The code unit 0 times 002e, full stop. N occurrences of the code unit 0 times 0030, digit 0. The code units of the k digits of the representation of s using radix. Note, in this case, the input will be represented using scientific E notation, such as 1.2e plus 3. Assert. Radix is 10. If n, 0, then a let exponent sign be the code unit 0 times 002d, hyphen minus 0, else a let exponent sign be the code unit 0 times 002b plus sign 11. If k equals 1, then I return the string concatenation of the code unit of the single digit of s, the code unit 0 times 0065, Latin small letter e, exponent sign, the code units of the decimal representation of abs, n1, 2. Return the string concatenation of the code unit of the most significant digit of the decimal representation of s, the code unit 0 times 002e, full stop. The code units of the remaining k1 digits of the decimal representation of s, the code unit 0 times 0065, Latin small letter e, exponent sign, the code units of the decimal representation of abs, N1, ECMA International 2024-37. Note 1. The following observations may be useful as guidelines for implementations. but are not part of the normative requirements of this standard. If x is any number value other than -0, then to number, to string, x is x. The least significant digit of s is not always uniquely determined by the requirements listed in Step 5. Note 2. For implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of Step 5 be used as a guideline. Let n, k, and s be integers such that k1, radix 1s, radix s radix k is x, and k is as small as possible. If there are multiple possibilities for s, choose the value of s for which s radix k is closest in value to r, x. If there are two such possible values of s, choose the one that is even. Note that k is the number of digits in the representation of s using radix and that s is not divisible by radix. Note 3. Implementers of ECMAScript may find useful the paper and code written by David M. Gay for binary to decimal conversion of floating point numbers. Gay, David M. correctly rounded binary decimal and decimal binary conversions. Numerical analysis. Manuscript 9010. AT&T Bell Laboratories, Murray Hill, New Jersey, the 30th of November, 1990. Available as http://ampbell.com/refs/abstracts.html rounding. Associated code available as http://netlib.sandia.gov/fp/dtour.c and as http://netlib.sandia.gov/fp/g_fmt.c and may also be found at the various netlib mirror sites. 1. 6. To the big int type. The big int type represents an integer value. The value may be any size and is not limited to a particular bit width. Generally, where not otherwise noted, operations are designed to return exact mathematically based answers. For binary operations, big ints act as 2's complement binary strings, with negative numbers treated as having bits set infinitely to the left. 1, 6, 2, 1 big int, unary minus, x. The abstract operation big int, unary minus takes argument x, a big int, and returns a big int. It performs the following steps when called. If x is 0z, return 0z. Return x, 1, 6, 2, 2 big int, bitwise not, x. The abstract operation big int, bitwise not takes argument x, a big int, and returns a big int. It returns the ones complement of x. It performs the following steps when called. Return x1z, 8, ECMA International 2024, 6, 1, 6, 2, 3 big int, exponentiate, base, exponent. The abstract operation big int, exponentiate takes arguments base, a big int, and exponent, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If exponent 0z, throw a range error exception. If base is 0z and exponent is 0z, return 1z. Return base raised to the power exponent, 1, 6, 2, 4 big int, multiply, x, y. The abstract operation big int, multiply takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return xy, 1, 6, 2, 5 big int. Divide, x, y. The abstract operation big int, divide takes arguments x, a big int, and y, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If y is 0z, throw a range error exception. Let quotient be r, x, r, y. Return z, truncate, quotient, 1, 6, 2, 6 big int, remainder, n, d. The abstract operation big int, remainder takes arguments n, a big int, and d, a big int, and returns either a normal completion containing a big int or a throw completion. It performs the following steps when called. If t is 0z, throw a range error exception. If n is 0z, return 0z. Let quotient be r, n, r, d. Let q be z. Truncate, quotient, return n, dq. Note the sign of the result is the sign of the dividend, 1, 6, 2, 7 begint, add, x, y. The abstract operation begint. Add takes arguments x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. 1. Return x plus y, 1, 6, 2, 8 begint. Subtract x, y. The abstract operation begint. Subtract takes arguments x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. 1. Return x, y. Note even if the result has a much larger bit width than the input, the exact mathematical answer is given. Copyright sign, ECMA International 2024 39. 6, 1, 6, 2, 9 begint, left shift, x, y. The abstract operation begint. Left shift takes arguments x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. If y, 0z, then a return z, floor, r, x, to r, y, return x to I, 1, 6, 2, 1, 0 begint, signed right shift, x, y. The abstract operation begint. Signed right shift takes arguments x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. 1. Return begint, left shift, x, y, 1, 6, 2, 1, 1 begint, and signed right shift, x, y. The abstract operation begint, and signed right shift takes arguments x, a begint, and y, a begint, and returns a throw completion. It performs the following steps when called. 1. Throw a type error exception, 1, 6, 2, 1, 2 begint, less than, x, y. The abstract operation begint. Less than takes arguments x, a begint, and y, a begint, and returns a boolean. It performs the following steps when called. If r, x, r, y, return true, otherwise return false, 1, 6, 2, 1, 3 begint, equal, x, y. The abstract operation begint, equal takes arguments x, a begint, and y, a begint, and returns a boolean. It performs the following steps when called. If r, x, equals r, y, return true, otherwise return false, 1, 6, 2, 1, 4 binary and x, y. The abstract operation binary and takes arguments x, 0 or 1, and y, 0 or 1, and returns 0 or 1. It performs the following steps when called. If x equals 1 and y equals 1, return 1, else return 0, 1, 6, 2, 1, 5 binary or x, y. The abstract operation binary or takes arguments x, 0 or 1, and y, 0 or 1, and returns 0 or 1. It performs the following steps when called. 1, 2. If x equals 1 or y equals 1, return 1. Else, return 0. 0. ECMA International 2024. Note semantics here should be equivalent to a bitwise shift, treating the begint as an infinite length string of binary 2's complement digits. 6, 1, 6, 2, 1, 6 binaries or x, y. The abstract operation binaries or takes arguments x, 0 or 1, and y, 0 or 1, and returns 0 or 1. It performs the following steps when called. If x equals 1 and y equals 0, return 1. Else if x equals 0 and y equals 1, return 1. Else, return 0, 1, 6, 2, 1, 7 begint bitwise op, x, y. The abstract operation begint bitwise op takes arguments op, and, or, x, a begint, and y, a begint, and returns a begint. It performs the following steps when called. Set x to r, x, set y to r, y let result be 0, let shift be 0, repeat, until x equals 0 or x equals -1, and y equals 0 or y equals -1. A let x digit be x modulo 2, b let y digit be y modulo 2. See if op is and, then I set result to result plus 2 shift binary and x digit, y digit d else if op is, then I set result to result plus 2 shift binary or x digit, y digit e else I assert op is 2. Set result to result plus 2 shift binaries or x digit, y digit f set shift to shift plus 1 g set x to x digit 2.
H, seti tu, I digit, 2.
If op is and, then a let tmp be binary and x modulo 2, y modulo 2. Else if op is, then a let tmp be binary or x modulo 2, y modulo 2. Else I assert op is b let tmp be binaries or x modulo 2, y modulo 2. If tmp 0, then a set result to result 2 shift. B note, this extends the sign 0. Return the big int value for result, 1, 6, 2, 1, 8 big int, bitwise and x, y. The abstract operation big int, bitwise and takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, and x, y, 1, 6, 2, 1, 9 big int, bitwise or x, y. The abstract operation big int, bitwise or takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, x, y. ECMA International 2024 41 6 1 6 2 20 big int, bitwise or x, y. The abstract operation big int, bitwise or takes arguments x, a big int, and y, a big int, and returns a big int. It performs the following steps when called. 1. Return big int bitwise op, x, y, 1, 6, 2, 2, 1 big int, to string, x, radix. The abstract operation big int, to string takes arguments x, a big int, and radix, an integer in the inclusive interval from 2 to 36, and returns a string. It represents x as a string using a positional numeral system with radix. The digits used in the representation of a big int using radix are taken from the first R code units of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 abdefgajamnopgraptavvox is in order. The representation of big ints other than 0z never includes leading zeros. It performs the following steps when called. If x, 0z, return the string concatenation of an big int. 2. String, x, radix. Return the string value consisting of the representation of x using radix. 1.7 The object type. Each instance of the object type, also referred to simply as an object, represents a collection of properties. Each property is either a data property or an accessor property. A data property associates a key value with an ECMAScript language value and a set of Boolean attributes. An accessor property associates a key value with one or two accessor functions and a set of Boolean attributes. The accessor functions are used to store or retrieve an ECMAScript language value that is associated with the property. The properties of an object are uniquely identified using property keys. A property key is either a string or a symbol. All strings and symbols, including the empty string, are valid as property keys. A property name is a property key that is a string. An integer index is a property name n such that canonical numeric index string n returns an integral number in the inclusive interval from +0 to 253 1. An array index is an integer index n such that canonical numeric index string n integral number in the inclusive interval from +0 to 232 2. Property keys are used to access properties and their values. There are two kinds of access for properties.
I have like there's 320 files that ever match the tag I put on top of all the files.
Inherited properties which are provided by another associated.
Only 167 files I actually use
The associated
for the current build revision that I have
The key values of the other row.
for the malloc mode, which uses RAM, and then paging mode, which uses static, like a 3 gig static allocation in the program, and then I page the rest. I don't even call malloc.
These are
That mode I'm going to replace with the memory map to compare against the malloc mode.
one
So like, it's probably only 120 something files when I pick one mode over the other, but there's 167 files for both until I can pick one or the other. So I gotta update these 167 files 64-bit,
32.1 has a corresponding array index.
and then the other files I gotta double check, make sure like they're really actually not needed, and then I can delete them. It'll be easier to work with because I won't have a whole bunch of like extra files from old build modes and like other code stuff that's not even related to the stuff I need to make the JavaScript engine.
False. If false, attempts by
So I don't know. I got notes, I check stuff, whatever.
using get access a property an object.
I'm gonna take, I don't know, another break. Another break. I need some water.
Table 5.
And I'll go through these 167 files.
Access of the property is performed.
I have to like make a new list, whatever, and then do Control F and Sublime. So I'm only updating these 167 because it'd be a waste of time to update all of them, all 320, since 320 aren't gonna be used.
Properties internal.
There's probably a couple more files that I have to update, but I'm just gonna get these ones first because like they're for certain being used.
Otherwise, the property.
I update a lot of them. I don't know how many, and I stopped doing that to work on some of this stuff. That doesn't matter now because I have a change of plans. I thought I could like hack stuff together to prove a point, but I can't prove a point and hack things together without actually doing the whole standard. So I have to like take things in baby steps. I can prove like small points, but it's not enough points to like punch a hole as like a hole. So like I can make points, little points, prove this is faster, but I can't like as a whole. I can't do that yet until I like do the whole standard and support everything. So I'll BRB. I'm gonna go through the rest of these 167 files. This is gonna be 3, 4, 5 days, and after that, this list is gonna keep changing. I'm gonna go up and down, add things, remove things. At some point, hopefully, has to be under 2 weeks. I'm gonna I do this too. I'm gonna get to the 2009 standard. I'm gonna meet only the vital mechanics.
As part of the process of creating an object and may not be dynamically added to an object unless specified otherwise.
I just want vital.
Dot is the value
And the mechanics.
Various algorithms within this specification create objects.
I don't know how to spell mechanics. It's close enough. Assuming that's how vital is spelled. I'm gonna meet only the vital mechanics. It'll be easier to pull out.
Private elements. This list represents the values of the private fields, methods, and accessors for the object. Initially, it is an empty list. Internal methods and internal.
It'll be easier to pull out the vital mechanics needed from the 200-page standard than it would be from the 2024 standard that's 800 pages. I want to do that first so I can like do minimal optimizing and just make sure everything's like there, and then I can do this stuff I want to do earlier. The last 5 days I tried to like hack stuff together. I can't just hack stuff together. I have to meet something. So if I meet this standards from 2009, I can like pull out what I need. It's not hacking or like just throwing stuff together. It's literally like it's in the standard. I'm gonna like have what I need from the standard in 200 pages, and I can do this stuff much easier because I'll have it from doing the 200 pages, and I can prove this. Like I'll be able to prove it, and then I'll go to the 800 page standard. It'll be easier to go through once I have something working in the first place from the 200 page standard. So that way it's not a dramatic jump from converting to 64-bit and then going right into 800 pages. Because that's like a huge jump. I need to like do this in between, have something working that I can experiment with, test on, figure out what's fast, what's not. I have to optimize things, and then I can like easier adapt to 800 pages from 200 pages if that's been met. So I got my whole plan is being, I gotta rethink every fucking thing that I was planning. So I'll BRB. I don't want to convert this. This is so much work. There's a bunch of things I gotta tweak after I convert it. So I'll BRB. Some water.
Set prototype of object null. Boolean, associate this object with another object that provides inherited properties. Passing null indicates that there are no inherited properties. Returns true indicating that the operation was completed successfully, or false indicating that the operation was not successful. Is extensible. Boolean, determine whether it is permitted to add additional properties to this object. 44. ECMA International 2024. Table 4. Essential internal methods. Continued. Internal method. Signature. Description. Prevent extensions. Boolean. Control whether new properties may be added to this object. Returns true if the operation was successful, or false if the operation was unsuccessful. Get own property. Property key. Undefined property descriptor. Return a property descriptor for the own property of this object whose key is property key, or undefined if no such property exists. Define own property. Property key. Property descriptor. Boolean, create or alter the own property, whose key is property key, to have the state described by property descriptor. Return true if that property was successfully created, updated, or false if the property could not be created or updated. Has property. Property key. Boolean, return a Boolean value indicating whether this object already has either an own or inherited property whose key is property key. Get. Property key. Receiver. Any, return the value of the property whose key is property key from this object. If any ECMAScript code must be executed to retrieve the property value, receiver is used as this value when evaluating the code. Set property key, value, receiver, Boolean, set the value of the property whose key is property key to value. If any ECMAScript code must be executed to set the property value, receiver is used as this value when evaluating the code. Returns true if the property value is set, or false if it could not be set. Delete property key. Boolean, remove the own property whose key is property key from this object. Return false if the property was not deleted and is still present. Return true if the property was deleted or is not present. Own property keys. List of property keys. Return a list whose elements are all of the own property keys for the object. Table 5 summarizes additional essential internal methods that are supported by objects that may be called as functions. A function object is an object that supports the internal method. A constructor is an object that supports the internal method. Every object that supports must support. That is, every constructor must be a function object. Therefore, a constructor may also be referred to as a constructor function or constructor function object. ECMA International 2024-45. Table 5. Additional essential internal methods of function objects. Internal method, signature, description, call, any, a list of any, executes code associated with this object. Invoked via a function call expression. The arguments to the internal method are this value and a list whose elements are the arguments passed to the function by a call expression. Objects that implement this internal method are callable. Construct a list of any object. Object creates an object. Invoked via the new operator or a supercall. The first argument to the internal method is a list whose elements are the arguments of the constructor invocation or the supercall. The second argument is the object to which the new operator was initially applied. Objects that implement this internal method are called constructors. A function object is not necessarily a constructor, and such non-constructor function objects do not have an internal method. The semantics of the essential internal methods for ordinary objects and standard exotic objects are specified in clause 10. If any specified use of an internal method of an exotic object is not supported by an implementation, that usage must throw a type error exception when attempted. 1. 7. 3 invariants of the essential internal methods. The internal methods of objects of an ECMAScript engine must conform to the list of invariants specified below. Ordinary ECMAScript objects as well as all standard exotic objects in this specification maintain these invariants. ECMAScript proxy objects maintain these invariants by means of runtime checks on the result of traps invoked on the object. Any implementation provided exotic objects must also maintain these invariants for those objects. Violation of these invariants may cause ECMAScript code to have unpredictable behavior and create security issues. However, violation of these invariants must never compromise the memory safety of an implementation. An implementation must not allow these invariants to be circumvented in any manner, such as by providing alternative interfaces that implement the functionality of the essential internal methods without enforcing their invariants. Definitions. The target of an internal method is the object upon which the internal method is called. A target is non-extensible if it has been observed to return false from its internal method, or true from its internal method. A non-existent property is a property that does not exist as an own property on a non-extensible target. All references to same value are according to the definition of the same value algorithm. Return value. The value returned by any internal method must be a completion record with either 46. ECMA International 2024. Bullet type equals normal equals yem pty and equals a value of the normal return type shown below for that internal method, or type equals throw equals empty and equals any ECMAScript language value. Note 1. An internal method must not return a continue completion, a break completion, or a return completion. The normal return type is either object or null. If target is non-extensible and returns a value v, then any future calls to get prototype of should return the same value as v. Set prototype of v. The normal return type is Boolean. If target is non-extensible, must return false, unless v is the same value as the target's observed value is extensible. The normal return type is Boolean. If returns false, all future calls to on the target must return false. Prevent extensions. The normal return type is Boolean. If returns true, all future calls to on the target must return false and the target is now considered non-extensible. Get own property. P. The normal return type is either property descriptor or undefined. If the type of the return value is property descriptor, the return value must be a fully populated property descriptor. If P is described as a non-configurable, non-writable own data property, all future calls to P must return property descriptor whose is same value as P's attribute. If P's attributes other than and may change over time, or if the property might be deleted, then P's attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the target is non-extensible and P is non-existent, then all future calls to P on the target must describe P as non-existent, that is, P must return undefined. Define own property. P Desc. The normal return type is Boolean, must return false if P has previously been observed as a non-configurable own property of the target, unless either P is a writable data property. A non-configurable writable data property can be changed into a non-configurable non-writable data property. All attributes of Desc are the same value as P's attributes. Note: to an object's prototype change should have finite length. That is, starting from any object, recursively applying the internal method to its result should eventually lead to the value null. However, this requirement is not enforceable as an object-level invariant if the prototype chain includes any exotic objects that do not use the ordinary object definition of. Such a circular prototype chain may result in infinite loops when accessing object properties. Note: 3 is a consequence of the third invariant. If a property is described as a data property and it may return different values over time, then either or both of the and attributes must be true even if no mechanism to change the value is exposed via the other essential internal methods. ECMA International 2024-47, P. Desc must return false if target is non-extensible and P is a non-existent own property. That is, a non-extensible target object cannot be extended with new properties. Has property P. The normal return type is Boolean if P was previously observed as a non-configurable own data or access a property of the target. Has property must return true. The normal return type is any ECMAScript language type if P was previously observed as a non-configurable, non-writable own data property of the target with value v. Then, if P was previously observed as a non-configurable own access a property of the target whose attribute is undefined. The P. V. Receiver. The normal return type is Boolean if P was previously observed as a non-configurable, non-writable own data property of the target. Then, must return false unless V is the same value as P's attribute. If P was previously observed as a non-configurable own access a property of the target whose attribute is undefined. The P. The normal return type is Boolean if P was previously observed as a non-configurable own data or access a property of the target. Must return false. The normal return type is list. The returned list must not contain any duplicate entries. The type of each element of the returned list is either string or symbol. The returned list must contain at least the keys of all non-configurable own properties that have previously been observed. If the target is non-extensible, the returned list must contain only the keys of all own properties of the target that are observable using call. The normal return type is any ECMAScript language type. 8. ECMA International 2024. Bullet. The normal return type is object. The target must also have internal method. 6. 1. 7. For well-known intrinsic objects. Well-known intrinsics are built-in objects that are explicitly referenced by the algorithms of this specification and which usually have realm-specific identities. Unless otherwise specified, each intrinsic object actually corresponds to a set of similar objects, one per realm. Within this specification, a reference such as %name means the intrinsic object associated with the current realm, corresponding to the name. A reference such as %name may be %means, as if the B property of the V, ALU of the A property of the intrinsic object %name was accessed prior to any ECMAScript code being evaluated. Determination of the current realm and its intrinsics is described in 9.4. The well-known intrinsics are listed in Table 6. Table 6. Well-known intrinsic objects. Intrinsic name. Global name. ECMAScript language association. Aggregate error %. Aggregate error. The aggregate error constructor. 20571 array %. Array. The array constructor. 2311 array buffer %. Array buffer. The array buffer constructor. 2514 array iterator prototype %. The prototype of array iterator objects. 2315 async from sync iterator prototype %. The prototype of async from sync iterator objects. 2714 async function %. The constructor of async function objects. 2771 async generator function %. The constructor of async iterator objects. 2741 async iterator prototype %. An object that all standard built-in async iterator objects indirectly inherit from atomics %. Atomics. The atomics object. 25.4. Big int percent. Big int. The big int constructor. 2 1 2 1. Big int 64 array percent. Big int 64 array. The big int 64 array constructor. 23.2. Big int 64 array percent. Big int 64 array. The big int 64 array constructor. 23.2. Boolean percent. Boolean. The Boolean constructor. 2 0 3 1. Data view percent. Data view. The data view constructor. 2 5 3 2. Date percent. Date. The date constructor. 2 1 4 2. Decodeary percent. Decodeary. The decodeary function. 1 9 2 6 1. Decodeary component percent. Decodeary component. The decodeary component function. 1 9 2 6 2. Encodeary percent. Encodeary. The encodeary function. 1 9 2 6 3. Encodeary component percent. Encodeary component. The encodeary component function. 1 9 2 6 4. Error percent. Error. The error constructor. 2 0 5 1. Copyright sign. ECMA International 2024. 9. Table 6. Well-known intrinsic objects. Continued. Intrinsic name. Global name. ECMAScript Language Association. Eval percent. Eval. The eval function. 1 9 2 1. Eval error percent. Eval error. The eval error constructor. 2 0 5 5 1. Finalization registry percent. Finalization registry. The finalization registry constructor. 2 6 2 1. Float 32 array percent. Float 32 array. The float 32 array constructor. 23.2. Float 64 array percent. Float 64 array. The float 64 array constructor. 23.2. For an iterator prototype percent. The prototype of for an iterator objects. 1 4 7 5 1 0. Function percent. Function. The function constructor. 2 0 2 1. Generator function percent. The constructor of generators. 2 7 3 1. Int array percent. Int array. The int array constructor. 23.2. Int 16 array percent. Int 16 array. The int 16 array constructor. 23.2. Int 32 array percent. Int 32 array. The int 32 array constructor. 23.2. Is finite percent. Is finite. The is finite function. 1 9 2 2. Is nan percent. Is nan. The is nan function. 1 9 2 3. Iterator prototype percent. An object that all standard built-in iterator objects indirectly inherit from. JSON percent. JSON. The JSON object. 25.5. Map percent. Map. The map constructor. 2 4 1 1. Map iterator prototype percent. The prototype of map iterator objects. 2 4 1 5. Math percent. Math. The math object. 21.3. Number percent. Num. Bear. The number constructor. 2 1 1 1. Object percent. Object. The object constructor. 2 0 1 1. Parse float percent. Parse float. The parse float function. 1 9 2 4. Parse int percent. Parse int. The parse int function. 1 9 2 5. Promise percent. Promise. The promise constructor. 2 7 2 3. Proxy percent. Proxy. The proxy constructor. 2 8 2 1. Range error percent. Range error. The range error constructor. 2 0 5 5 2. Reference error percent. Reference error. The reference error constructor. 2 0 5 5 3. Reflect percent. Reflect. The reflect object. 28.1. regexp percent. regexp. The regexp constructor. 2 2 2 4 50. ECMA International 2024. Table 6. Well-known intrinsic objects. Continued. Intrinsic name. Global name. ECMAScript Language Association. regexp string iterator prototype percent. The prototype of regexp string iterator objects. 2 2 2 9. Set percent. Set. The set constructor. 2 4 2 1. Set iterator prototype percent. The prototype of set iterator objects. 2 4 2 Shared array buffer %. Shared array buffer. The shared array buffer constructor. 25. 2. 3. String %. String. The string constructor. 22. 1. 1. String iterator prototype %. The prototype of string iterator objects. 22. 1. 5. Symbol %. Symbol. The symbol constructor. 20. 4. 1. Syntax error %. Syntax error. The syntax error constructor. 20. 5. 5. 4. Throw type error %. A function object that unconditionally throws a new instance of %type error %. Typed array %. The superclass of all typed array constructors. 23. 2. 1. Type error %. Type error. The type error constructor. 20. 5. 5. 5. Date array %. Date array. The date array constructor. 23.2. 8 clamped array %. 8 clamped array. The 8 clamped array constructor. 23.2. 16 array %. 16 array. The 16 array constructor. 23.2. 32 array %. 32 array. The 32 array constructor. 23.2. URI error %. URI error. The URI error constructor. 20. 5. 5. 6. Weak map %. Weak map. The weak map constructor. 24. 3. 1. Weak ref %. Weak ref. The weak ref constructor. 26. 1. 1. Weak set %. Weak set. The weak set constructor. 24. 4. 1. Note additional entries in table 97. 6.2. ECMAScript specification types. A specification type corresponds to meter values that are used within algorithms to describe the semantics of ECMAScript language constructs and ECMAScript language types. The specification types include reference, list, completion record, property descriptor, environment record, abstract closure, and data block. Specification type values are specification artifacts that do not necessarily correspond to any specific entity within an ECMAScript implementation. Specification type values may be used to describe intermediate results of ECMAScript expression evaluation, but such values cannot be stored as properties of objects or values of ECMAScript language variables. ECMA International 2024 51 6 2. 1. The enum specification type. Enums are values which are internal to the specification and not directly observable from ECMAScript code. Enums are denoted using GS. For instance, a completion records field takes on value.
I'm gonna get to converting the 167. Yeah, 67 files to 64. Then, whatever comes after that. So first, I get these 167 files, 64-bit. Then I can like check that off this to-do list. It's more like deal with it as it happens and try to list it as a reminder. But nothing's really gonna be done in the order of this list, to-do list. That's what this list is. I don't know, so I'm gonna get these 167 files converted. So I'm just gonna like try to focus and not talk because I'm gonna get distracted when I talk. That's my reason I talk, is to like distract myself from making progress. So I'm gonna stop talking and make some progress.
Value.
Most of these files are done already. By most, I mean not really. I have a lot more to go. So here we go.
In order of each of the arguments. In order, the record type is used to describe data aggregation.
And if you're watching the stream, stop watching this and go live your life. There's no point watching me do something when you could be doing something with your life. Just saying.
Field names are always enclosed in double brackets. For
real. For real. Stop watching the stream.
can be
Stop.
For example,
Don't do it.
false, empty defines a
That's not like reverse psychology. It's literally like stop. Just stop watching the stream.
significant. Any fields that
You're literally wasting your time watching me do something when you could be doing something.
For example, if R is the record shown in the previous paragraph, then R is shorthand for the field of R named. Commonly used field combinations may be named, and that name may be used as a prefix to a literal record value to identify the specific kind of aggregations that is being described. For example, property descriptor 42, false, true, 2.3 the set and relation specification types. The set type is used to explain a collection of unordered elements for use in the memory model. It is distinct from the ECMAScript collection type of the same name. To disambiguate, instances of the ECMAScript collection are consistently referred to as set objects within this specification. Values of the set type are simple collections of elements, where no element appears more than once. Elements may be added to and removed from sets. Sets may be unioned, intersected, or subtracted from each other. The relation type is used to explain constraints on sets. Values of the relation type are sets of ordered pairs of values from its value domain. For example, a relation on events is a set of ordered pairs of events. For a relation R and two values are and B in the value domain of R, RB is shorthand for saying the ordered pair A, B.
Why doesn't YouTube give notifications? I'm like subscribed to like literally every possible band I listen to, and it doesn't give notifications on 90% of the new music that's out, and I totally miss it. I don't think about it. It pisses me off. YouTube is shit. They should make a separate playlist that has every single fucking notification that you missed. It's ridiculous that they have a server running that collects requests and then it like sends stuff out when it wants sporadically. It should be on a list, a chain, and they should send every mother-loving update to people that click subscribe for updates, especially if you click all for all updates. It's really annoying. They're totally incompetent. Oh, stupid.
Return and throw that
And I'm gonna say YouTube sucks when I wanna say YouTube sucks, because YouTube sucks. I don't care if it's their platform. YouTube sucks.
value, meaning type, normal, break, continue, return, or throw the type of completion that occurred. Value, any value except a completion record. The value that was produced. Target, a string or empty. The target label for directed control transfers. The following shorthand terms are sometimes used to refer to completion records. Normal completion refers to any completion record with a value of normal. Break completion refers to any completion record with a value of break. Continue completion refers to any completion record with a value of continue. Return completion refers to any completion record with a value of return. Throw completion refers to any completion record with a value of throw. Abrupt completion refers to any completion record with a value other than normal. A normal completion containing some type of value refers to a normal completion that has a value of that type in its field. Callable objects that are defined in this specification only return a normal completion or a throw completion. Returning any other kind of completion record is considered an editorial error. Implementation-defined callable objects must return either a normal completion or a throw completion. ECMA International 2024 53 6 2 4 1 Normal completion value. The abstract operation normal completion takes argument value any value except a completion record and returns a normal completion. It performs the following steps when called. Return completion record, normal, value, empty, 2, 4, 2 throw completion, value. The abstract operation throw completion takes argument value, an ECMAScript language value, and returns a throw completion. It performs the following steps when called. Return completion record, throw, value, empty, 2, 4, 3 update empty, completion record, value. The abstract operation update empty takes arguments completion record, a completion record, and value any value except a completion record, and returns a completion record. It performs the following steps when called. Assert. If completion record is either a return completion or a throw completion, then completion record is not empty. If completion record is not empty, return completion record. Return completion record, value, completion record. 2.5 The reference record specification type. The reference record type is used to explain the behavior of such operators as delete, type off, the assignment operators, the super keyword and other language features. For example, the left-hand operand of an assignment is expected to produce a reference record. A reference record is a resolved name or property binding. Its fields are defined by Table 8. Table 8. Reference record fields. Field name, value, meaning, base, an ECMAScript language value, an environment record, or unresolvable, the value or environment record which holds the binding. Of unresolvable indicates that the binding could not be resolved. Reference name, a string, a symbol, or a private name, the name of the binding. Always a string if value is an environment record. Strict, a boolean, true if the reference record originated in strict mode code. False otherwise. This value, an ECMAScript language value or empty. If not empty, the reference record represents a property binding that was expressed using the super keyword. It is called a super reference record and its value will never be an environment record. In that case, the field holds this value at the time the reference record was created. The following abstract operations are used in this specification to operate upon reference records. 4. Copyright sign, ECMA International 2024. 6. 2. 5. 1 is property reference, v. The abstract operation is property reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is unresolvable, return false. If v is an environment record, return false. Otherwise return true. 2. 5. 2 is unresolvable reference, v. The abstract operation is unresolvable reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is unresolvable, return true. Otherwise return false. 6. 2. 5. 3 is super reference, v. The abstract operation is super reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is not empty, return true. Otherwise return false. 6. 2. 5. 4 is private reference, v. The abstract operation is private reference takes argument v, a reference record, and returns a boolean. It performs the following steps when called. If v is a private name, return true. Otherwise return false. 6. 2. 5. 5 get value, v. The abstract operation get value takes argument v, a reference record or an ECMAScript language value, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If v is not a reference record, return v. If is unresolvable reference, v, is true. Throw a reference error exception. If is property reference, v, is true. Then, a let base obj be. To object, v, b. If is private reference, v, is true. Then, I return. Private get, base obj, v, c return base obj, get this value, v, else, a let base be v, b assert. Base is an environment record. C return base get binding value. V. C 9.1. Note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. ECMA International 2024 55. 6. 2. 5. 6 put value. V. W. The abstract operation put value takes arguments v, a reference record or an ECMAScript language value, and w, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. If v is not a reference record, throw a reference error exception. If is unresolvable reference, v, is true. Then, if v is true, throw a reference error exception. B let global obj be get global object. C perform. Set global obj v w false. D return unused. If as property reference v is true, then a let base obj be to object v b. If as private reference v is true, then I return private set base obj v w. C let succeeded be base obj w. Get this value v. D if succeeded is false and v is true, throw a type error exception. E return unused. Else a let base be v. B assert base is an environment record. C return base set mutable binding v w v. C 9.1, 2, 5, 7 get this value v. The abstract operation get this value takes argument v, a reference record, and returns an ECMAScript language value. It performs the following steps when called. Assert is property reference v is true. If is super reference v is true, return v. Otherwise return v, 2, 5, 8 initialize reference binding v w. The abstract operation initialize reference binding takes arguments v, a reference record, and w, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It performs the following steps when called. Assert is unresolvable reference v is false. Let base be v. Assert base is an environment record. Return base initialize binding v w, 2, 5, 9 make private reference base value private identifier. The abstract operation make private reference takes arguments base value, an ECMAScript language value, and private identifier, a string, and returns a reference record. It performs the following steps when called. Let privy-env be the running execution context's private environment. Assert privy-env is not null. Let private name be resolved private identifier, privy-env, private identifier. Return the reference record. Base value, private name. True, note the object that may be created in step 3 is not accessible outside of the above abstract operation in the ordinary object. 6. ECMA International 2024. This value, empty. 6. 2. 6. The property descriptor specification type. The property descriptor type is used to explain the manipulation and reification of object property attributes. A property descriptor is a record with 0 or more fields, where each field's name is an attribute name and its value is a corresponding attribute value as specified in 6, 1, 7, 1. The schema name used within this specification to tag literal descriptions of property descriptor records is property descriptor. Property descriptor values may be further classified as data property descriptors and accessor property descriptors based upon the existence or use of certain fields. A data property descriptor is one that includes any fields named either raw. An accessor property descriptor is one that includes any fields named either. Any property descriptor may have fields named and a property descriptor value may not be both a data property descriptor and an accessor property descriptor. However, it may be neither, in which case it is a generic property descriptor. A fully populated property descriptor is one that is either an accessor property descriptor or a data property descriptor and that has all of the corresponding fields defined in Table 3. The following abstract operations are used in this specification to operate upon property descriptor values. 6, 2, 6, 1 is accessor descriptor, desk. The abstract operation is accessor descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If desk has a, return false. 2, 6, 2 is data descriptor, desk. The abstract operation is data descriptor takes argument desk, a property descriptor or undefined, and returns a boolean. It performs the following steps when called. If desk is undefined, return false. If desk has a field, return true. If desk has a field, return true. Return false, 2.
So out of the 100
Takes
167 files
cooled. If desk is
I have replaced all unsigned ins type
desk
with the keyword that I can switch to toggle between 64-bit and 32-bit.
desk
I've replaced all signed in
descriptor takes argument.
types too with a different toggle, a different define for signed ins. So I have my signed and unsigned have all been found, replaced, so I can like change it to signed
Is an extensible ordinary
long and unsigned long for 64-bit. And I just change one keyword, one define, and I can find whatever. So that's done, but
if desk has a field.
I replace with int. There's still some left I gotta find.
Desk perform create data
Int whatever.
has a
Words like internal or the word print
desk. If desk hasn't field, then a
or sprint.
obj enumerate
I don't think I have the word sprint. I think there's like a sprint to print string format. I don't remember though. I only use printf,
to property
which is also a match. These all contain int in the name, the word, whatever.
ECMAScript
So when I search for int, this is the year 2025. Let me double check that.
when called. If obj is not an object, throw a type error
And everybody should go like listen to John Bellion.
fields. Let has enumerable be.
I think he like broke from his record label, so like I don't know. That's probably why I didn't get the notification of his new song last month, because he doesn't have a record label now. I don't know, maybe he does, maybe a new record label. I think he's independent now, but I think that's why I didn't get the notification, because YouTube intentionally favors music labels and stuff because they have a music label and it's clearly biased and it's all intentional. So that's probably why I didn't get a notification of his new music video.
To value. Let
Choose watch, whatever. So I don't know. Go listen to his music too. I haven't talked to him. Maybe one day.
reset desk to writable.
I don't want to name drop.
2. If his get is true, then
Anyways, yeah, the year is 2025.
getter is not undefined. Throw a type error exception set desk. 3. Let his set be. His property ob.
And the current state of the modern operating system
Set.
is that we use text files. This is a text file here. It's text. It's type. And we put these files inside of folders. And that's how you write programs. That's it.
Comma 2.
That's how things are.
The descriptor. Desk. The abstract operation complete property.
In the year 2025 on the modern operating system. That's how things work in the modern day, the year 2025, because that is true.
Is true or is data descriptor. Desk is true.
I am unable to just control find all the integers like this. I can't just find int. I have to find the text int.
If desk does not have an field,
And what I have to do is manually replace it one by one or all at once and hope I don't mess anything up.
behavior of name resolution in nest.
Because the year is 2025. This is how you do things in the modern day. Over the last like 30, 40 years of computing, nobody's thought of making a type, a text file, where you can have a type where you type the word int, you can change it in one place across all files. Instead, you have to change it in all files, in all places, each one at a time. Or you mass replace and hope that nothing breaks, because other things are going to have the word int inside of them.
The algorithm to be performed.
So, since it's the year 2025, and this is how things work in the modern day of writing programs,
Completion record. That completion.
I searched for, there are regexes and stuff that I could use, but they do not fucking work. So I'm doing everything manually because I've tried like stupid fucking macro programs and like using regex, and it always comes down to me having to by hand go through each case and look at it, because a program is automated and all programs have bugs, and I don't have time to deal with bugs that I don't create. If I make a bug, it's my fault, my problem. But I hate when I use a tool that has a bug and I get a bug and it's not my fault, and it's like, shit, I should have just did that all by myself. So, whatever, I don't know.
And integer index sequence of byte.
I have to find all the int with the space after it,
New then db2 can be used
and all the int with the space before it,
that can be referenced from
because sometimes an int will be
data block has an identity
touching the left side of the wall here.
address free. It is tied not to the virtual addresses the block is mapped to in any process, but to the set of locations in memory that the block represents. Two data blocks.
Like if int is the first thing in a new line, there is no space in front of it. Like this has a space, this one doesn't. So anything with a space in front of it or a space after it is what I'm looking for. So if I search for those two things, a space before and after, I'm gonna find all of the ints.
Form a candidate.
And what I'm going to do is I go through each one by one, because I can't mess this up. Last time I did printf, I did a mass replace. I was like, or it was system pause. I don't know. I felt safe doing mass replace with that because it's unique.
Byte data block size. The abstract operation create byte data block takes argument size, a non-negative integer.
Like when I do like search for this, I don't know. It's much easier to look for this and replace it, like mass replace, than it is to like look for int. Not many things happen to like have the same name as the word int, or the same whatever textual replacement.
Operation.
So I did mass replace these, but this is different. I gotta go through and be careful not to break things.
Shared data block or a throw completion. It performs the
So for int and int, whatever,
bytes. If it is impossible to create such a shared data block, throw a range error exception.
with the space before, there's 4,000 matches across 92 of the 167 files.
True.
And then int with the space after it, there is 1,343 across 77 files. So I'm going to do int with the space after it first, so I feel like I made progress quicker, and I'm going to deal with the 4,000 matches.
Integer.
But as I go through, what I'm going to do is
From int x, a non-negative integer, and count.
first I want to prune out all things that aren't int. It's like the word internal I'm gonna do Control F to find replace, and replace it with like that, or something. Just break up the word, so next time I do int, Control F, see how there's a match here, there's a match here. If I break it up like this, there'll be no matches. I also want to put a space before, an extra space, and after. So I will find all of these, and I will replace it with this when it's not the int that I'm looking for. And then when I go through after to find int, it will only be the int that I'm looking for. But there are some functions that have the word int in it. The word system doesn't have int. But I'm sure there's something that has int in it. So after I get like all things that are definitely not int replaced like this in this file, in these, whatever, there will be some overlap with some of these. So as I do these, hopefully this number will drop to like 3,500, because there's going to be matches across both, because sometimes it is, and then I'll have a space on both sides. There's overlap, whatever. So I'm going to do this first, and then I'll be certain that every possible freaking int type has been replaced with a new keyword. And then I'll be able to change the keyword to long, and then it's 64-bit. So that's all the type casting or whatever.
Writable data properties and private accessors behave similarly to.
After that, I'm going to go through and get everywhere. Where's the 31? Bit shift or whatever, sign bit. Replace it with 63 and all the 32-bit masking and stuff. I'm going to update to 64-bit masking and arithmetic. So after I get all these done, save it back up and everything, it should work. I'm going to have to go through and pick it apart, the 167 files, and make sure all 32-bit
Accessor, a function.
addressing arithmetic is updated to 64-bit. After that, I'm not going to get ahead of myself. There's like other small steps I gotta do. I gotta like separate things that have to be 4-byte from things that need to be updated to 64-bit. Because sometimes it's a number 4. It doesn't have to be, or it shouldn't be, updated to 8, which is 64-bit. 4 is 32. It's bytes. So after I just update the whole thing, I'm gonna get everything that's related to 4 bytes or 32-bit. I will go through and figure out what isn't actually supposed to be 64-bit. I will tag it, name it, and label it different to make sure that I isolate all the different things or whatever. So I'm gonna just go through, get all these ints first, all 1,300 whatever, crossing 7. And I'm gonna get these, then update everything to 64-bit arithmetic, even if it's not supposed to be 64-bit. Some things should and have to stay 4 bytes, but that's after. I just want to tag everything, so everything's tagged to make sure nothing's missed. If I update every single thing, I can unupdate. But if I update some things and I miss things, or like don't do things, I'll have to come back to them. I'd rather tag every single thing, like tag and bag it, and then it's like everything's there, and then I can pick through it. It's better to like do too much than do too little, and then like always have to like figure out what to do in between. So I'm gonna like, I don't know. And then I'm gonna get to this stuff, whatever. So, I don't know. That's what I'm gonna do. I'm gonna undo some of the crap I just typed. And get some more water. I'm actually gonna like this is too far. Go through and get these. Sucks.
An object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. It performs the following steps when called: field name, value, meaning, body function, an ECMAScript function object. The function object to be called during static initialization of a class. 1. If input is an object, then 2. ECMA International 2024 AB. Let exotic to prim B. Get method, input, add at to primitive. If exotic to prim is not undefined, then I have preferred type is not present, then 1. Let int be default. 2. Else if preferred type is string, then 1. Let int be string. 3. Else assert preferred type is number. Let hint be number. 5. Let result be call exotic to prim, input, hint v. If result is not an object, return result v. Throw a type error exception. See if preferred type is not present. Let preferred type be number. Do return ordinary to primitive, input, preferred type 2. Return input, 1, 1 ordinary to primitive. O. Hint. The abstract operation ordinary to primitive takes argument so, an object, and hint, string or number, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. If hint is string, then a let method names be to string, value of. Else a let method names be value of to string. For each element name of method names, do a let method be get name be if is callable, method is true, then I let result be call method 2. If result is not an object, return result. Throw a type error exception, 1.2 to boolean argument. The abstract operation to boolean takes argument in ECMAScript language value and returns a boolean. It converts argument to a value of type boolean. It performs the following steps when called. If argument is a boolean, return argument. If argument is one of undefined, null, +0, -0, nan, 0z, or the empty string, return false. Note: this step is replaced in section B, 3, 6, 1. Return true, 1.3 to numeric value. The abstract operation to numeric takes argument value, an ECMAScript language value, and returns either a normal completion containing either a number or a big int, or a throw completion. It returns value converted to a number or a big int. It performs the following steps when called. Let prim value be to primitive value number. If prim value is a big int, return prim value. Return to number prim value, 1.4 to number argument. The abstract operation to number takes argument in ECMAScript language value and returns either a normal completion containing a number or a throw completion. It converts argument to a value of type number. It performs the following steps when called. If argument is a number, return argument. If argument is either a symbol or a big int, throw a type error exception. If argument is undefined, return nan. When to primitive is called without a hint, then it generally behaves as if the hint were number. Note: however, objects may override this behavior by defining a at to primitive method. Of the objects defined in this specification, only dates, C21, 4, 4, 4, 5, and symbol objects, C20, 4, 3, 5, override the default to primitive behavior. Dates treat the absence of a hint as if the hint was string. ECMA International 2024 63, 4. If argument is either null or false, return +0. If argument is true, return 1. If argument is a string, Return string to number. Argument. Assert. Argument is an object. Let prim value be. To primitive. Argument. Number. Assert. Prim value is not an object. 0. Return. To number. Prim value, 1, 4, 1 to number applied to the string type. The abstract operation string to number specifies how to convert a string value to a number value. Using the following grammar. Syntax. String numeric literal. str white spaciart. str white spaciart. str numeric literal. str white spaciart. str white space. str white space char. str white spaciart. str white space char. White space. Line terminator. str numeric literal. str decimal literal. Non-decimal integer literal. sep. str decimal literal. str unsigned decimal literal. str unsigned decimal literal. str unsigned decimal literal. str unsigned decimal literal. Infinity decimal digits. sep. Decimal digits. sep opt exponent part. sep opt. Decimal digits. sep. Exponent part. sep opt. Decimal digits. sep. Exponent part. sep opt. All grammar symbols not explicitly defined above have the definitions used in the lexical grammar for numeric literals. 1, 2, 9, 3. Note some differences should be noted between the syntax of a string numeric literal and a numeric literal. A string numeric literal may include leading and or trailing white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A street ring numeric literal that is decimal may include a plus or to indicate its sign. A string numeric literal that is empty or contains only white spaces converted to +0. Infinity and infinity are recognized as a string numeric literal but not as a numeric literal. A string numeric literal cannot include a big int literal suffix. A string numeric literal cannot include a numeric literal separator. 4. Copyright sign. ECMA International 2024. 7. 1. 4. 1. 1 string to number. str. The abstract operation string to number takes argument str, a string, and returns a number. It performs the following steps when called. Let text be string to code points. str. Let literal be parse text. Text. String numeric literal. If literal is a list of errors, return none. Return string numeric value of literal, 1, 4, 1. To runtime semantics. String numeric value. The syntax-directed operation string numeric value takes no arguments and returns a number. It is defined piecewise over the following productions. String numeric literal. str white spaciart 1. Return +0. String numeric literal. str white spaciart. str numeric literal. str white spaciart 1. Return string numeric value of str numeric literal. str numeric literal. Non-decimal integer literal 1. Return MV of non-decimal integer literal. str decimal literal. str unsigned decimal literal. Letter B string numeric value of str unsigned decimal literal. If is +0, return -0. Return A str unsigned decimal literal. Infinity 1. Return plus str unsigned decimal literal. Decimal digits. Decimal digits opt exponent part opt. Letter B MV of the first decimal digits. If the second decimal digits is present, then a let B be MV of the second decimal digits. B let N be the number of code points in the second decimal digits. Else a let 0 be let N 0. If exponent part is present, let E be MV of exponent part. Otherwise, let E be 0. Return round MV result. A plus B 10N 10E str unsigned decimal literal. Decimal digits exponent part opt. Let B be MV of decimal digits. If exponent part is present, let E be MV of exponent part. Otherwise, let E be 0. Note the conversion of a string numeric literal to a number value is similar overall to the determination of the numeric value of a numeric literal. See 1, 2, 9, 3. But some of the details are different. ECMA International 2024 65. 3. Let N be the number of code points in decimal digits. Return round MV result. B 10E. N. str unsigned decimal literal. Decimal digits exponent part opt. Letter B MV of decimal digits. If exponent part is present, let E be MV of exponent part. Otherwise, let E be 0. Return round MV result. at any, 1, 4, 1, 3 round mv result, n. The abstract operation round mv result takes argument n, a mathematical value, and returns a number. It converts n to a number in an implementation-defined manner. For the purposes of this abstract operation, a digit is significant if it is not 0 or there is a non-zero digit to its left and there is a non-zero digit to its right. For the purposes of this abstract operation, the mathematical value denoted by a representation of a mathematical value is the inverse of the decimal representation of a mathematical value. It performs the following steps when called. If the decimal representation of n has 20 or fewer significant digits, return n. Let option 1 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit. Let option 2 be the mathematical value denoted by the result of replacing each significant digit in the decimal representation of n after the 20th with a 0 digit and then incrementing it at the 20th position, with carrying as necessary. Let chosen be an implementation-defined choice of either option 1 or option 2. Return chosen, 1.5 to integer or infinity. Argument. The abstract operation to integer or infinity takes argument in ECMAScript language value, and returns either a normal completion containing either an integer, plus, or a throw completion. It converts argument to an integer representing its number value with fractional part truncated, or to plus or, when that number value is infinite. It performs the following steps when called. Let number be to number, argument. If number is one of nan, plus 0, or minus 0, return 0. If number is plus, return plus. If number is, return truncate, r. Number, 1.6 to int32, argument. The abstract operation to int32 takes argument in ECMAScript language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 232 integral number values in the inclusive interval from -231 to 231.1. It performs the following steps when called. Let number be to number, argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate, r. Number. Let int 32-bit be int modulo 232. If int 32-bit 231, return int 32-bit 232. Otherwise return int 32-bit 66. ECMA International 2024. Note: to integer or infinity, x never returns -0 for any value of x. The truncation of the fractional part is performed after converting x to a mathematical value. Note: given the above definition of toint32, the toint32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. Toint32 x is the same value as toint32 x. For all values of x, it is to preserve this latter property that plus and are mapped to plus 0. Toint32 maps -0 to plus 0, 1.7 toint32, argument. The abstract operation toint32 takes argument in ECMAScript language value, and returns either a normal completion containing an integral number or a throw completion. It converts argument to one of 232 integral number values in the inclusive interval from plus 0 to 232.1. It performs the following steps when called. Let number be to number, argument. If number is not finite or number is either plus 0 or minus 0, return plus 0. Let int be truncate, r. Number. Let int 32-bit be int modulo 232. Return int 32-bit. Note: given the above definition of toint32, step 5 is the only difference between toint32 and toint32. The toint32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. Toint32 x is the same value as toint32 x. For all values of x, it is to preserve this latter property that plus and are mapped to plus 0. Toint32 maps -0 to plus 0, 1.8 toint16, argument. The abstract operation toint16 takes argument in ECMAScript language value, and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 216 integral number values in the inclusive interval from -215 to 215(1). It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 16-bit be int modulo 216. If int 16-bit 215, return int 16-bit 216. Otherwise return int 16-bit, 1.9 to int 16. Argument. The abstract operation to int 16 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 216 integral number values in the inclusive interval from +0 to 216(1). It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. ECMA International 2024-67 4. Let int 16-bit be int modulo 216. Return int 16-bit, 1.10 to int 8. Argument. The abstract operation to int 8 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 28 integral number values in the inclusive interval from -128 to 127. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 8-bit be int modulo 28. If int 8-bit 27, return int 8-bit 28. Otherwise return int 8-bit, 1.11 to int 8. Argument. The abstract operation to int 8 takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It converts the argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps when called. Let number be the number argument. If number is not finite or number is either +0 or -0, return +0. Let int be truncate. Number. Let int 8-bit be int modulo 28. Return int 8-bit, 1.12 to int 8 clamp. Argument. The abstract operation to int 8 clamp takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It clamps and rounds argument to one of 28 integral number values in the inclusive interval from +0 to 255. It performs the following steps when called. Let number be the number argument. If number is nan, return +0. Let nv be the extended mathematical value of number. Let clamped be the result of clamping nv between 0 and 255. Let f be floor. Clamped. If clamped, f plus 0.5. Return f. If clamped, f plus 0.5. Return f plus 1. If f is even, return f. Otherwise, return f plus 1. Note: given the above definition of 216, the substitution of 216 for 232 in step 4 is the only difference between 232 and 216. 216 maps -0 to +0. Note: unlike most other ECMAScript integer conversion operations, 208 clamp rounds rather than truncates non-integral values. It also uses round-half to even tie breaking, which differs from the round-half up tie breaking of math round. 8. ECMA International 2024, the 7th of January 2013 to big int. Argument. The abstract operation to big int takes argument in ECMAScript language value and returns either a normal completion containing a big int or a throw completion. It converts the argument to a big int value, or throws if an implicit conversion from number would be required. It performs the following steps when called. Let prim be to primitive argument number. Return the value that prim corresponds to in table 12. Table 12. begin conversions, argument type, result, undefined, throw a type error exception, null, throw a type error exception, boolean, return 1 nf prim is true and 0 nf prim is false, big int, return prim, number, throw a type error exception, string, let n be string to big int, prim, if n is undefined.
So I'm gonna get to replacing.
Exception, the 7th of January 2000.
These ints with a space after it. And then for the rest of them, it's take forever.
The following steps when called: let text be string to code points, str, let literal be parse text, text, string integer literal, if literal is a list of errors, return undefined, let mv be the mv of literal, assert, mv is an integer, return z, mv, 1, 1 4. 1 string integer literal grammar, string to big int uses the following grammar. Syntax, string integer literal, str white spaciart, str white spaciart, str integer literal, str white spaciart, str integer literal, signed integer, sep, non-decimal integer literal, sep, ECMA International 2024 69, 7, 1, 1 4, to runtime semantics, mv, th, emv of string integer literal, str white spaciart is 0, the mv of string integer literal, str white spaciart, str integer literal, str white spaciart is the mv of str integer literal, 1.15 to big int 64, argument. The abstract operation to big int 64 takes argument in ECMAScript language value, and returns either a normal completion containing a big int or a throw completion. It converts argument to one of 264 big int values in the inclusive interval from z, minus 263, to z, 263 1. It performs the following steps when called: let n be, to big int, argument, let int 64-bit br, n, modulo 264, if int 64-bit 263, return z, int 64-bit 264, otherwise return z, int 64-bit, 1.16 to big int 64, argument. The abstract operation to big int 64 takes argument in ECMAScript language value, and returns either a normal completion containing a big int or a throw completion. It converts argument to one of 264 big int values in the inclusive interval from 0z to z, 264 1. It performs the following steps when called: let n be, to big int, argument, let int 64-bit br, n, modulo 264, return z, int 64-bit, 1.17 to string, argument. The abstract operation to string takes argument in ECMAScript language value, and returns either a normal completion containing a string or a throw completion. It converts argument to a value of type string. It performs the following steps when called: if argument is a string, return argument. If argument is a symbol, throw a type error exception. If argument is undefined, return undefined. If argument is null, return null. If argument is true, return true. If argument is false, return false. If argument is a number, return number. To string, argument, 10. If argument is a big int, return big int. To string, argument, 10. Assert, argument is an object, 0. Let prim value be. To primitive, argument, string, 1. Assert, prim value is not an object, 2. Return, to string, prim value, 1.18 to object, argument. The abstract operation to object takes argument in ECMAScript language value, and returns either a normal completion containing an object or a throw completion. It converts argument to a value of type object according to table 13, 0. Copyright sign, ECMA International 2024, table 13. To object conversions, argument type, result, undefined, throw a type error exception, null, throw a type error exception, boolean, return a new boolean object whose internal slot is set to argument. See 20.3 for a description of boolean objects. Number, return a new number object whose internal slot is set to argument. See 21.1 for a description of number objects. String, return a new string object whose internal slot is set to argument. C22.1 for a description of string objects. Symbol, return a new symbol object whose internal slot is set to argument. C20.4 for a description of symbol objects. Big int, return a new big int object whose internal slot is set to argument. C21.2 for a description of big int objects. Object, return argument, the 7th of January 2019 to property key, argument. The abstract operation to property key takes argument in ECMAScript language value and returns either a normal completion containing a property key or a throw completion. It converts argument to a value that can be used as a property key. It performs the following steps when called. Low key B. To primitive, argument, string. If key is a symbol, then a return key, return. To string, key, 1.20 to length, argument. The abstract operation to length takes argument in ECMAScript language value and returns either a normal completion containing an integral number or a throw completion. It clamps and truncates argument to an integral number suitable for use as the length of an array-like object. It performs the following steps when called. Let len be to an integer or infinity, argument. If len 0, return +0, return min len 253 1.21 canonical numeric index string, argument. The abstract operation canonical numeric index string takes argument to string and returns a number or undefined. If argument is either -0 or exactly matches the result of toString n for some number value n, it returns the respective number value. Otherwise, it returns undefined. It performs the following steps when called. If argument is -0, return -0. Let n be to number, argument. If to string n is argument, return n, return undefined. ECMA International 2024-71. A canonical numeric string is any string value for which the canonical numeric index string abstract operation does not return undefined. 1.22 to int x value. The abstract operation to index takes argument value, an ECMAScript language value, and returns either a normal completion containing a non-negative integer or a throw completion. It converts value to an integer and returns that integer if it is non-negative and corresponds with an integer index. Otherwise, it throws an exception. It performs the following steps when called. Let integer be to an integer or infinity value. If integer is not in the inclusive interval from 0 to 253 1, throw a range error exception. Return integer. Point 2 testing and comparison operations. 2.1 require object coercible. Argument. The abstract operation require object coercible takes argument in ECMAScript language value and returns either a normal completion containing an ECMAScript language value or a throw completion. It throws an error if argument is a value that cannot be converted to an object using toObject. It is defined by Table 14. Table 14. Require object coercible results. Argument type result undefined. Throw a type error exception null. Throw a type error exception boolean. Return argument number. Return argument string. Return argument symbol. Reto rn argument big int. Return argument object. Return argument 7 2. 2 is array, argument. The abstract operation is array takes argument in ECMAScript language value and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. If argument is an array exotic object, return true. If argument is a proxy exotic object, then a perform. Validate non-revoke proxy. Argument. B let proxy target be argument. C return is array. Proxy target. Return false. 2. ECMA International 2024-7. 2. 3 is callable. Argument. The abstract operation is callable takes argument in ECMAScript language value and returns a boolean. It determines if argument is a callable function with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true. Return false. 2.4 is constructor. Argument. The abstract operation is constructor takes argument in ECMAScript language value and returns a boolean. It determines if argument is a function object with the internal method. It performs the following steps when called. If argument is not an object, return false. If argument has an internal method, return true. Return false. 2.5 is extensible. O. The abstract operation is extensible takes argument O, an object, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether additional properties can be added to O. It performs the following steps when called. Return O, 2.6 is integral number. Argument. The abstract operation is integral number takes argument in ECMAScript language value and returns a boolean. It determines if argument is a finite integral number value. It performs the following steps when called. If argument is not a number, return false. If argument is not finite, return false. If truncate, argument, argument, return false. Return true. 2.7 is property key. Argument. The abstract operation is property key takes argument in ECMAScript language value and returns a boolean. It determines if argument is a value that may be used as a property key. It performs the following steps when called. If argument is a string, return true. If argument is a symbol, return true. Return false. 2.8 is regexp. Argument. The abstract operation is regexp takes argument in ECMAScript language value and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If argument is not an object, return false. Let matcher be. Get argument at match. If matcher is not undefined, return to boolean matcher. If argument has an internal slot, return true. Return false. ECMA International 2024 73 7 2. Statics. And return. String is a sequence of UTF-16 encoded code points, as described in 6.
I ran out of knuckles to crack. So I'm gonna knuckle down, and this is gonna take hours to do. I hate finding the placing.
Score sequence. UTF-16 sequence. It performs the following steps when called. Let len be the length of string. Length 0. Repeat. While k, len, a let cp be code point at string k, b if cp is true. Return false. C set k to k plus cp. Return true. 2.10 same value. X, y. The abstract operation same value takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It determines whether or not the two arguments are the same value. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value, x, y3. Return same value non-number, x, y, 2.11 same value 0, x, y. The abstract operation same value 0 takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It determines whether or not the two arguments are the same value, ignoring the difference between +0 and -0. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number, same value 0, x, y3. Return same value non-number, x, y. Note same value 0 differs from same value only in that it treats +0 and -0 as equivalent. The 7th of February 2012 same value non-number, x, y. The abstract operation same value non-number takes arguments x, an ECMAScript language value, but not a number, and y, an ECMAScript language value, but not a number, and returns a boolean. It performs the following steps when called. Assert type x is type y. If x is either null or undefined, return true. If x is a big int, then a return big int equal x, y4. If x is a string, Then, if x and y have the same length in the same code units in the same positions, return true. Otherwise, return false. 74. ECMA International 2024. Note this algorithm differs from the is strictly equal algorithm by treating all NaN values as equivalent and by differentiating +0 from -0. 5. If x is a boolean, then, if x and y are both true or both false, return true. Otherwise, return false. Note: all other ECMAScript language values are compared by identity. If x is y, return true. Otherwise, return false. Note to the specifics of what x is y means are detailed in 5.2.7. The 7th of February 2013 is less than x, y, left first. The abstract operation is less than takes arguments x, an ECMAScript language value, y, an ECMAScript language value, and left first, a boolean, and returns either a normal completion containing either a boolean or undefined, or a throw completion. It provides the semantics for the comparison x, y, returning true, false, or undefined, which indicates that at least one operand is NaN. The left first flag is used to control the order in which operations with potentially visible side effects are performed upon x and y. It is necessary because ECMAScript specifies left to right evaluation of expressions. If left first is true, the x parameter corresponds to an expression that occurs to the left of the y parameter's corresponding expression. If left first is false, the reverse is the case and operations must be performed upon y before x. It performs the following steps when called. If left first is true, then a let px be. To primitive x, number b let pi be. To primitive y, number else. A note: the order of evaluation needs to be reversed to preserve left to right evaluation. B let pi be. To primitive y, number c let px be. To primitive x, number. If px is a string and pi is a string, then a let 60 be the length of px, b let li be the length of pi. C for each integer I such that 0 min 60 li in ascending order. Do I let cx be the numeric value of the code unit at index I within px. 2. Let psi be the numeric value of the code unit at index I within pi. 3. If cx psi return true. If cx psi return false. D. If 60 li return true. Otherwise, return false. Else, if px is a big int and pi is a string, then I let ni be string to big int pi. 2. If ni is undefined, return undefined. 3. Return big int less than px ni b. If px is a string and pi is a big int, then I let an x be string to big int px. 2. If an x is undefined, return undefined. 3. Return big int less than nx pi. C note: because px and pi are primitive values, evaluation order is not important. D. Let nx be. To numeric px let an I be. To numeric pi f. If type nx is type ni, then I. If nx is a number, then return number less than nx ni. 2. Else, assert nx is a big int, return big int less than nx ni. G. Assert nx is a big int and ni is a number, or nx is a number and ni is a big int. H. If nx or ni is NaN, return undefined. I. If nx is or ni is plus, return true. ECMA International 2024 75. Note 1: for expository purposes, some cases are handled separately within this algorithm even if it is unnecessary to do so. Note 1: step 3 differs from step 1c in the algorithm that handles the addition operator +1 3 1 5 3 by using the logical and operation instead of the logical or operation. 2.14 is loosely equal x y j k. If an x is plus or ni is, return false. If r nx r ni, return true. Otherwise return false. Note 2: the comparison of strings uses a simple lexicographic ordering on sequences of UTF-16 code unit values. There is no attempt to use the more complex, semantically oriented definitions of ch, character or string equality and collating order defined in the Unicode specification. therefore string values that are canonically equal according to the Unicode standard but not in the same normalization form could test as unequal. Also note that lexicographic ordering by code unit differs from ordering by code point for strings containing surrogate pairs. The abstract operation is loosely equal takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It provides the semantics for the equals equals operator. It performs the following steps when called. If type x is type y, then a return is strictly equal x, y. If x is null and y is undefined, return true. If x is undefined and y is null, return true. Note, this step is replaced in section B, 3, 6, 2. IFX, ABC, IFX, 0, IFE, 1. IFX is a number and y is a string. Return is loosely equal x to number, y is a string and y is a number. Return is loosely equal to number, x, y is a big int and y is a string. Then let n be string to big int, y. If n is undefined, return false. Return is loosely equal x, n is a string and y is a big int. Return is loosely equal y, x is a boolean. Return is loosely equal to number, x, y is a boolean. Return is loosely equal x to number, y is either a string, a number, a big int, or a symbol and y is an object. Return is loosely equal x to primitive y2. If x is an object and y is either a string, a number, a big int, or a symbol, return is loosely equal to primitive x, y3. If x is a big int and y is a number, or if x is a number and y is a big int, then if x is not finite or y is not finite, return false. BFR x equals r, y, return true, otherwise return false. 4. Return false, 2.15 is strictly equal x, y. The abstract operation is strictly equal takes arguments x, an ECMAScript language value, and y, an ECMAScript language value, and returns a boolean. It provides the semantics for the equals 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 operator. It performs the following steps when called. If type x is not type y, return false. If x is a number, then a return number equal x, y, return same value non-number x, y. Note this algorithm differs from the same value algorithm in its treatment of sign zeros and nonce. 76. ECMA International 2024. 7.3 Operations on Objects. 3.1 Make Basic Object. Internal slots list. The abstract operation make basic object takes argument internal slots list, a list of internal slot names, and returns an object. It is the source of all ECMAScript objects that are created algorithmically, including both ordinary objects and exotic objects. It factors out common steps used in creating all objects, and centralizes object creation. It performs the following steps when called. Let obj be a newly created object with an internal slot for each name in internal slots list. Set objz, central internal methods to the default ordinary object definitions specified in 10.1. Assert. If the caller will not be overriding both objs and essential internal methods, then internal slots list contains. Assert. If the caller will not be overriding all of objs and prevent extensions, essential internal methods, then internal slots list contains. If internal slots list contains, set obj to true. Return obj, 3.2 get. O, p. The abstract operation get takes arguments O, an object, and p, a property key, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to retrieve the value of a specific property of an object. It performs the following steps when called. Return O. The abstract operation get takes arguments v, an ECMAScript language value, and p, a property key, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to retrieve the value of a specific property of an ECMAScript language value. If the value is not an object, the property lookup is performed using a wrapper object appropriate for the type of the value. It performs the following steps when called. Let O be. To object, v return O, 3.4 set O, p, v, throw. The abstract operation set takes arguments O, an object, p, a property key, v, an ECMAScript language value, and throw, a boolean, and returns either a normal completion containing unused or a throw completion. It is used to set the value of a specific property of an object. V is the new value for the property. It performs the following steps when called. Let success be O. If success is false and throw is true, throw a type error exception. Return unused. Note within this specification, exotic objects are created in abstract operations such as array create and bound function create by first calling make basic object to obtain a basic, foundational object, and then overriding some or all of that object's internal methods. In order to encapsulate exotic object creation, the object's essential internal methods are never modified outside those operations. ECMA International 2024 77 7 3 5 Create data property O, P, V. The abstract operation create data property takes arguments O, an object, P, a property key, and V, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It is used to create a new own property of an object. It performs the following steps when called. Let new desk be the property descriptor. V, true, 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 return. O, P, new desk, 3.6 create data property or throw. O, P, V. The abstract operation create data property or throw takes arguments O, an object, P, a property key, and V, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It is used to create a new own property of an object. It throws a type error exception if the requested property update cannot be performed. It performs the following steps when called. Let success be create data property O, P, V. If success is false, throw a type error exception. Return unused, 3.7, capital C, R, E, A, T, E, capital N, O, N, capital E, N, U, M, E, R, A, B, L, E, capital D, A, T, A, capital P, R, O, P, E, R, T, O, P, V. The abstract operation, capital C, R, E, A, T, E, capital N, O, N, capital E, N, U, M, E, R, A, B, L, E, capital D, A, T, A, capital P, R, O, P, E, R, T, takes arguments O, an object, P, a property key, and V, an ECMAScript language value, and returns unused. It is used to create a new non-enumerable own property of an ordinary object. It performs the following steps when called. Assert O as an ordinary, extensible object with no non-configurable properties. Let new desk be the property descriptor. V, true, false, configurable, true, perform. Define property or throw. O, P, new desk, return unused. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMAScript language assignment operator. Normally, the property will not already exist. If it does exist and is not configurable, or if O is not extensible, will return false. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMAScript language assignment operator. Normally, the property will not already exist. If it does exist and is not configurable, or if O is not extensible, will return false, causing this operation to throw a type error exception. Note this abstract operation creates a property whose attributes are set to the same defaults used for properties created by the ECMAScript language assignment operator, except it is not enumerable. Normally, the property will not already exist. If it does exist, define property or throw is guaranteed to complete normally. 8. ECMA International 2024. 7. 3. 8. Define property or throw. O. P. Desk. The abstract operation define property or throw takes arguments O, an object, P, a property key, and desk, a property descriptor, and returns either a normal completion containing unused or a throw completion. It is used to call the internal method of an object in a manner that will throw a type error exception if the requested property update cannot be performed. It performs the following steps when called. Let success be O, P, desk. If success is false, throw a type error exception. Return unused. 3.9 Delete property or throw. O, P. The abstract operation delete property or throw takes arguments O, an object, and P, a property key, and returns either a normal completion containing ng unused or a throw completion. It is used to remove a specific own property of an object. It throws an exception if the property is not configurable. It performs the following steps when called. Let success be O, P. If success is false, throw a type error exception. Return unused. 3.10 Get method V, P. The abstract operation get method takes arguments V, an ECMAScript language value, and P, a property key, and returns either a normal completion containing either a function object or undefined, or a throw completion. It is used to get the value of a specific property of an ECMAScript language value when the value of the property is expected to be a function. It performs the following steps when called. Let func be jet v p. If func is either undefined or null, return undefined. If is callable, func is false. Throw a type error exception. Return func. 3.11 has property O, P. The abstract operation has property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether an object has a property with the specified property key. The property may be either own or inherited. It performs the following steps when called. Return O, P. The 7th of March 2012 has own property O, P. The abstract operation has own property takes arguments O, an object, and P, a property key, and returns either a normal completion containing a boolean or a throw completion. It is used to determine whether an object has an own property with the specified property key. It performs the following steps when called. Let desk be O, P. If desk is undefined, return false. Return true. 3.13 Call F, V. Arguments list. The abstract operation call takes arguments F, an ECMAScript language value, and V, an ECMAScript language value, and optional arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to call the internal ECMA International 2024-79 method of a function object. F is the function object, V is an ECMAScript language value that is the this value of the, and arguments list is the value passed to the corresponding argument of the internal method. If arguments list is not present, a new empty list is used as its value. It performs the following steps when called. If arguments list is not present, set arguments list to a new empty list. If is callable, F is false. Throw a type error exception. Return F, V, arguments list, 3.14 construct, F, arguments list, new target. The abstract operation construct takes argument F, a constructor, and optional arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a th row completion. It is used to call the internal method of a function object arguments list and new target to the values to be passed as the corresponding arguments of the internal method. If arguments list is not present, a new empty list is used as its value. If new target is not present, f is used as its value. It performs the following steps when called. If new target is not present, set new target to f. If arguments list is not present, set arguments list to a new empty list. Return f arguments list new target, 3.15 set integrity level. Level. The abstract operation set integrity level takes argument so an object and level sealed or frozen and returns either a normal completion containing a boolean or a throw completion. It is used to fix the set of own properties of an object. It performs the following steps when called. Let status be if status is false, return false. Low keys p. If level is sealed, then for each element k of keys, do I perform. Define property or throw k property descriptor false. Else I assert level is frozen. B for each element k of keys, do I let current desk be k2. If current desk is not undefined, then if is accessor descriptor current desk is true, then a let desk be the property descriptor false. Else a let desk be the property descriptor false. Perform. Define property or throw k desk 6. Return true, 3.16 test integrity level. Level. The abstract operation test integrity level takes argument so an object and level sealed or frozen and returns either a normal completion containing a boolean or a throw completion. It is used to determine if the set of own properties of an object are fixed. It performs the following steps when called. Let extensible be is extensible. If extensible is true, return false. Note, if the object is extensible, none of its properties are examined. Low keys p. For each element k of keys, do 80. ECMA International 2024. Note, if new target is not present, this operation is equivalent to new f arguments list. A let current desk be k b. If current desk is not undefined, then I if current desk is true, return false. 2. If level is frozen and is data descriptor current desk is true, then if current desk is true, return false. 6. Return true, 3.17 create array from list elements. The abstract operation create array from list takes argument elements, a list of ECMAScript language values, and returns an array. It is used to create an array whose elements are provided by elements. It performs the following steps when called. Let array be array create 0. Let 0 for each element of elements. Do a perform create data property or throw array to string n e be set n to n plus 1. Return array, 3.18 length of array like.
It's a start. Only a whole bunch more to go.
Object. Normal completion containing a non-negative integer or a throw.
It's like 1,000 left, 1,083. Only 67 more files
To length.
out of 77. So that's 10 files left.
Object for which this
I'm gonna run it, save it back up.
are examples of array-like objects, 3.
I changed a couple things, and I could have missed an if or an end if and messed something up. So I want to build it just to check.
A script language value.
It's gonna take some time to get all of this working in place.
Either a normal completion containing a list of ECMAScript language values or a throw completion. It is used to create a list value whose elements are provided by the index properties of obj element types contains the names of ECMAScript language types that are allowed for element values of the list that is created. It performs the following steps when called. If element types is not present, set element types to undefined, null, boolean, string, symbol, number, big int, object. If obj is not an object, throw a type error exception. Let len be length of array like obj. Let list be a new empty list. Let index be 0. Repeat. while index len a let index name be. To string index b let next be. Get obj index name. See if element types does not contain type. Next, throw a type error exception. D append next to list. ESET index +1. Return list. ECMA International 2024-81. Note 1. Typically, an array-like object would also have some properties with integer index names. However, that is not a requirement of this definition. The 7th of March 2020 invoke v.p. arguments list. The abstract operation invoke takes arguments v, an ECMAScript language value, and p, a property key, and optional arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It is used to call a method property of an ECMAScript language value. V serves as both the lookup point for the property and this value of the core arguments list is the list of arguments values passed to the method. If arguments list is not present, a new empty list is used as its value. It performs the following steps when called. If arguments list is not present, set arguments list to a new empty list. Let func be jet v p return. Call func v arguments list, 3.21 ordinary has instance. C O. The abstract operation ordinary has instance takes argument C, an ECMAScript language value, and O, an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the default algorithm for determining if O inherits from the instance object inheritance path provided by C. It performs the following steps when called. If is callable, C is false, return false. If C has an internal slot, then a let BC be return. Instantia of operator O, BC. If O is not an object, return false, a let PB. Get C prototype. If P is not an object, throw a type error exception. Repeat ABC, 3.22. Set O to O. If O is null, return false. If same value, P, O, is true, return true. Species constructor O, default constructor. The abstract operation species constructor takes arguments O, an object, and default constructor, a constructor, and returns either a normal completion containing a constructor or a throw completion. It is used to retrieve the constructor that should be used to create new objects that are derived from a default constructor as the constructor to use if a constructor at species property cannot be found starting from O. It performs the following steps when called. Let C be get O constructor. If C is undefined, return default constructor. If C is not an object, throw a type error exception. Let S be get C at species. If S is either undefined or null, return default constructor. If is constructor S is true, return S. Throw a type error exception. 3.23 enumerable own properties O kind. The abstract operation enumerable own properties takes arguments O, an object, and kind, key, value, or key plus value, and returns either a normal completion containing a list of ECMAScript language values or a throw completion. It performs the following steps when called. Let own keys be O. Let results be a new empty list. For each element key of own keys, do if key is a string, then 2. ECMA International 2024. I let desk be.
I should probably turn all the debug stuff back on now.
N. A append.
Because I'm like changing it. If something breaks, I don't know. Because I have the debug stuff off.
You to results.
So that's annoying. I'm gonna like save it back up. Then I'm gonna finish. Well, I guess turn debug stuff back on so we can catch if something breaks as I'm renaming stuff. I'm like finish renaming stuff.
Record or a throw completion. It performs the following steps when called. If obj has an internal slot, then a return obj. If obj is a bound function exotic object, then a let bound target function be obj be return. Get function realm bound target function. If obj is a proxy exotic object, then a perform. Validate non-revoke proxy. Obj b let proxy target be obj. C return. Get function realm. Proxy target. Return the current realm record. 3.25 copy data properties. Target. Source. Excluded items. The abstract operation copy data properties takes arguments target, an object, source, an ECMAScript language value, and excluded items, a list of property keys, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If source is either undefined or null, return unused. Let from b. To object, source, let keys be from. For each element next key of keys, do a let excluded be false. B for each element of excluded items, do I if same value, e, next key, is true, then 1. Set excluded to true. C if excluded is false, then I let desk be from, next key 2. If desk is not undefined and desk is true, then let proper value be. Get from next key perform. Create data property or throw target next key proper value. Return unused. Return results. Note step 4 will only be reached if obj is a non-standard function exotic object that does not have an internal slot. Note the target passed in here is accessible in case of an error being thrown. ECMA International 2024-83. The 7th of March 2026 private element find. O. P. The abstract operation private element find takes arguments. Note there are only two Boolean values, true and false. Boolean type consisting of the primitive values true and false. Starting from a sentence consisting of a single distinguished non-terminal, called the goal symbol, a given context-free grammar specifies a language, namely, the, perhaps infinite, set of possible sequences of terminal symbols that can result from repeatedly replacing any non-terminal in the sequence with the right-hand side of a production for which the non-terminal is the left-hand side. 1.2 The lexical and regexp grammars. A lexical grammar for ECMAScript is given in clause 7. This grammar has as its terminal symbols characters, Unicode code units, that conform to the rules for source character defined in clause 6. It defines a set of productions, starting from the goal symbol input element div or input element regexp, that describe how sequences of such characters are translated into a sequence of input elements. Input elements other than white space and comments form the terminal symbols for the syntactic grammar for ECMAScript and are called ECMAScript tokens. These tokens are the reserved words, identifiers, literals, and punctuators of the ECMAScript language. Moreover, line terminators, although not considered to be tokens, also become part of the stream of input elements and guide the process of automatic semicolon insertion. 7.9. Simple white space and single-line comments are discarded and do not appear in the stream of input elements for the syntactic grammar. A multi-line comment, that is, a comment of the form comma regardless of whether it spans more than one line, is likewise simply discarded if it contains no line terminator, but if a multi-line comment contains one or more line terminators, then it is replaced by a single line terminator, which becomes part of the stream of input elements for the syntactic grammar. A regexp grammar for ECMAScript is given in 15.10. This grammar also has as its terminal symbols the characters as defined by source character. It defines a set of productions, starting from the goal symbol pattern, that describe how sequences of characters are translated into regular expression patterns. Productions of the lexical and regexp grammars are distinguished by having two colons, as separating punctuation. The lexical and regexp grammars share some productions. 1.3 The numeric string grammar. Another grammar is used for translating strings into numeric values. This grammar is similar to the part of the lexical grammar having to do with numeric literals and has as its terminal symbols source character. This grammar appears in 9.3.1. Productions of the numeric string grammar are distinguished by having three colons, as punctuation. 5.1. For the syntactic grammar. The syntactic grammar for ECMAScript is given in clauses 11, 12, 13 and 14. This grammar has ECMAScript tokens defined by the lexical grammar as its terminal symbols. 5.1. 2. It defines a set of productions, starting from the goal symbol program, that describe how sequences of tokens can form syntactically correct ECMAScript programs. When a stream of characters is to be passed as an ECMAScript program, it is first converted to a stream of input elements by repeated application of the lexical grammar. This stream of input elements is then parsed by a single application of the syntactic grammar. The program is syntactically in error if the tokens in the stream of input elements cannot be parsed as a single instance of the goal non-terminal program, with no tokens left over. Productions of the syntactic grammar are distinguished by having just one colon, as punctuation. The syntactic grammar is presented in clauses 11, 12, 13 and 14 is actually not a complete account of which token sequences are accepted as correct ECMAScript programs. Certain additional token sequences are also accepted, namely, those that would be described by the grammar if only semicolons were added to the sequence in certain places, such as before line terminator characters. Furthermore, certain token sequences that are described by the grammar are not considered acceptable if the terminator character appears in certain awkward places. Copyright sign, ECMA International 2009. 5.1. 5. The JSON grammar. The JSON grammar is used to translate a string describing a set of ECMAScript objects into actual objects. The JSON grammar is given in 1.5.1.2.1. The JSON grammar consists of the JSON lexical grammar and the JSON syntactic grammar. The JSON lexical grammar is used to translate character sequences into tokens and is similar to parts of the ECMAScript lexical grammar. The JSON syntactic grammar describes how sequences of tokens from the JSON lexical grammar can form syntactically correct JSON object descriptions. Productions of the JSON lexical grammar are distinguished by having two colons, as separating punctuation. The JSON lexical grammar uses some productions from the ECMAScript lexical grammar. The JSON syntactic grammar is similar to parts of the ECMAScript syntactic grammar. Productions of the JSON syntactic grammar are distinguished by using one colon, as separating punctuation, 1.6 grammar notation, terminal symbols of the lexical and string grammars, and some of the terminal symbols of the syntactic grammar, are shown in fixed-width font. Both in the productions of the grammars and throughout this specification whenever the text directly refers to such a terminal symbol. These are to appear in a program exactly as written. All terminal symbol characters specified in this way are to be understood as the appropriate Unicode character from the ASCII range, as opposed to any similar-looking characters from other Unicode ranges. Non-terminal symbols are shown in italic type. The definition of a non-terminal is introduced by the name of the non-terminal being defined followed by one or more colons. The number of colons indicates to which grammar the production belongs. One or more alternative right-hand sides for the non-terminal then follow on succeeding lines. For example, the syntactic definition while expression statement states that the non-terminal while statement represents the token while, followed by a left parenthesis token, followed by an expression, followed by a right parenthesis token, followed by a statement. The occurrences of expression and statement are themselves non-terminals. As another example, the syntactic definition argument list, assignment expression, argument list, assignment expression, states that an argument list may represent either a single assignment expression or an argument list, followed by a comma, followed by an assignment expression. This definition of argument list is recursive, that is, it is defined in terms of itself. The result is that an argument list may contain any positive number of arguments, separated by commas, where each argument expression is an assignment expression. Such recursive definitions of non-terminals are common. The subscripted suffix opt, which may appear after a terminal or non-terminal, indicates an optional symbol. The alternative containing the optional symbol actually specifies two right-hand sides, one that omits the optional element and one that includes it. This means that variable declaration, identifier initializer opt, is a convenient abbreviation for variable declaration, identifier initializer, ECMA International 2009, and that iteration statement for expression known opt, expression statement is a convenient abbreviation for iteration statement for expression statement for expression known expression statement, which in turn is an abbreviation for iteration statement for expression statement for expression statement for expression known statement for expression known expression statement, which in turn is an abbreviation for iteration statement for expression statement for expression statement for expression statement for expression known statement for expression known expression statement for expression known expression statement for expression known expression statement. So the non-terminal iteration statement actually has 8 alternative right-hand sides. If the phrase empty appears as the right-hand side of a production, it indicates that the production's right-hand side contains no terminals or non-terminals. If the phrase look ahead set appears in the right-hand side of a production, it indicates that the production may not be used if the immediately following input token is a member of the given set. The set can be written as a list of terminals enclosed in curly braces. For convenience, the set can also be written as a non-terminal, in which case it represents the set of all terminals to which that non-terminal could expand. For example, given the definitions decimal digit 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal digits, decimal digit, decimal digits, decimal digit. The definition look ahead example n look ahead 1, 3, 5, 7, 9 decimal digits, decimal digit. Look ahead decimal digit matches either the letter n followed by one or more decimal digits, the first of which is even, or a decimal digit not followed by another decimal digit. 0. Copyright sign, ECMA International 2009. If the phrase, no line terminator here, appears in the right-hand side of a production of the syntactic grammar, it indicates that the production is a restricted production. It may not be used if a line terminator occurs in the input stream at the indicated position. For example, the production return statement, return, no line terminator here, expression opt, indicates that the production may not be used if a line terminator occurs in the program between the return token and the expression, unless the presence of a line terminator is forbidden by a restricted production. Any number of occurrences of line terminator may appear between any two consecutive tokens in the stream of input elements without affecting the syntactic acceptability of the program. When the words one of follow the colon, s, in a grammar definition, they signify that each of the terminal symbols on the following line or lines is an alternative definition. For example, the lexical grammar for ECMAScript contains the production, non-zero digit, 1 of 123,456,789, which is merely a convenient abbreviation for non-zero digit. 1. When an alternative in a production of the lexical grammar or the numeric string grammar appears to be a multi-character token, it represents the sequence of characters that would make up such a token. The right-hand side of a production may specify that certain expansions are not permitted by using the phrase but not and then indicating the expansions to be excluded. For example, the production identifier name but not reserved word means that the non-terminal identifier may be replaced by any sequence of characters that could replace identifier name provided that the same sequence of characters could not replace reserved word. Finally, a few non-terminal symbols are described by a descriptive phrase and sans serif type in cases where it would be impractical to list all the alternatives. Source character. Any Unicode code unit. Point to algorithm conventions. The specification often uses a numbered list to specify steps in an algorithm. These algorithms are used to precisely specify the required semantics of ECMAScript language constructs. The algorithms are not intended to imply the use of any specific implementation technique. In practice, there may be more efficient algorithms available to implement a given feature. ECMA International 2009-11. In order to facilitate that using multiple parts of this specification, some algorithms, called abstract operations, are named and written in parameterized functi on or form so that they may be referenced by name from within other algorithms. When an algorithm is to produce a value as a result, the directive return x is used to indicate that the result of the algorithm is the value of x and that the algorithm should terminate. The notation result, n, is used as shorthand for the result of step n. For clarity of expression, algorithm steps may be subdivided into sequential substeps. Substeps are indented and may themselves be further divided into indented substeps. Outline numbering conventions are used to identify substeps with the first level of substeps labeled with lowercase alphabetic characters and the second level of substeps labeled with lowercase Roman numerals. If more than 3 levels are required, these rules repeat with the fourth level using numeric labels. For example, top level step, a substep, B substep, I substep, 2. Substep, substep, a substep. A step or substep may be written as an if predicate that conditions its substeps. In this case, the substeps are only applied if the predicate is true. If a step or substep begins with the word else, it is a predicate that is the negation of the preceding if predicate step at the same level. A step may specify the iterative application of its substeps. Mathematical operations such as addition, subtraction, negation, multiplication, division, and the mathematical functions defined later in this clause should always be understood as computing exact mathematical results on mathematical real numbers, which do not include infinities and do not include a negative zero that is distinguished from positive zero. Algorithms in this standard that model floating point arithmetic include explicit steps, where necessary, to handle infinities and sign zero and to perform rounding. If a mathematical operation or function is applied to a floating point number, it should be understood as being applied to the exact mathematical value represented by that floating point number. Such a floating point number must be finite. And if it is plus 0 or 0, then the corresponding mathematical value is simply 0. The mathematical function abs, x, yields the absolute value of x, which is x if x is negative, less than 0, and otherwise is x itself. The mathematical function sin, x, yields 1 if x is positive and 1 if x is negative. The sin function is not used in this standard for cases when x is 0. The notation x modulo y must be finite and non-zero, computes a value k of the same sign as y, or 0, such that abs, k, abs, y, and xk equals qy for some integer q. The mathematical function floor, x, yields the largest integer, closest to positive infinity that is not larger than x. Note floor, x equals x modulo 1. If an algorithm is defined to throw an exception, execution of the algorithm is terminated and no result is returned. The calling algorithms are also terminated until an algorithm step is reached that explicitly deals with the exception, using terminology such as if an exception was thrown. Once such an algorithm step has been encountered, the exception is no longer considered to have occurred. Source text. ECMAScript source text is represented as a sequence of characters in the Unicode character encoding, version 3.0 or later. The text is expected to have been normalized to Unicode normalized form C. Canonical 2. Copyright sign, ECMA International 2009. Composition, as described in the Unicode Technical Report number 15. Conforming ECMAScript implementations are not required to perform any normalization of text, or behave as though they were performing normalization of text themselves. ECMAScript source text is assumed to be a sequence of 16-bit code units for the purposes of this specification. Such a source text may include sequences of 16-bit code units that are not valid UTF-16 character encodings. If an actual source text is encoded in a form other than 16-bit code units, it must be processed as if it was first converted to UTF-16 source character. Any Unicode code unit. Throughout the rest of this document, the phrase code unit and the word character will be used to refer to a 16-bit unsigned value used to represent a single 16-bit unit of text. The phrase Unicode character will be used to refer to the abstract linguistic or typographical unit represented by a single Unicode scalar value, which may be longer than 16 bits and thus may be represented by more than one code unit. The phrase code point refers to such a Unicode scalar value. Unicode character only refers to entities represented by single Unicode scalar values. The components of a combining character sequence are still individual Unicode characters. Even though a user might think of the whole sequence as a single character, in string literals, regular expression literals, and identifiers, any character, code unit, may also be expressed as a Unicode escape sequence consisting of 6 characters, namely U plus 4 hexadecimal digits. Within a comment, such an escape sequence is effectively ignored as part of the comment. Within a string literal or regular expression literal, the Unicode escape sequence contributes 1 character to the value of the literal. Within an identifier, the escape sequence contributes 1 character to the identifier. Note, although this document sometimes refers to a transformation between a character within a string and the 16-bit unsigned integer that is the code unit of that character, there is actually no transformation because a character within a string is actually represented using that 16-bit unsigned value. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000, for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode character 000A is line feed, and therefore the next character is not part of THE comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes a character to the string value of the literal and is never interpreted as a line terminator or as a quote mark that might terminate the string. Literal lexical conventions. The source text of an ECMAScript program is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of characters as the next input element. There are 2 goal symbols for the lexical grammar. The input element of symbol is used in those syntactic grammar contexts where a leading division or division assignment equals operator is permitted. The input element regexp symbol is used in other syntactic grammar contexts. Note there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion, see 7.9, in examples such as the following: a equals b high g exec, c map, d, where the first non-white space, non-comment character after a line terminator is slash, comma, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as a equals b high g exec, c map, d, ECMA International 2009-13. Syntax: input element div, white space, line terminator comment token div punctuator, input element regexp, white space, line terminator comment, token regular expression literal. Point 1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals and regular expression literals. ZWNJ and ZWJ are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, ZWNJ and ZWJ may also be used in an identifier after the first character. BOM is a format control character used primarily at T start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order. BOM characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files, BOM characters are treated as white space characters. See 7.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 1. Code unit value U200C, U200C, UFF.2 white space, name, 0 width non-joiner, 0 width joiner, byte order mark, formal name, ZWNJ, ZWJ, BOM, usage, identifier part white space, Table 1, format control character usage. White space characters are used to improve source text readability and to separate tokens, indivisible lexical units, from each other, but are otherwise insignificant. White space characters may occur between any two tokens and at the start or end of input. White space characters may also occur within a string literal or a regular expression literal, where they are considered significant characters forming part of the literal value, or within a comment, but cannot appear within any other kind of token. The ECMAScript white space characters are listed in Table 2. 4. Copyright sign, ECMA International 2009. Code unit value U0009, U000B, U000C, U0020, U00A0, UFF. Other categories: EDS, name, tab, vertical tab, form feed, space, no break, space, byte, order mark, any other Unicode space separator, formal name, tab, VT, FF, SP, NBSP, BOM, USP. Table 2. White space characters. ECMAScript implementations must recognize all of the white space characters defined in Unicode 3.0. Later editions of the Unicode standard may define other white space characters. ECMAScript implementations may recognize white space characters from later editions of the Unicode standard. Syntax: white space, tab, VT, FF, SP, NBSP, BOM, USP. Point 3 Line terminators. Like white space characters, line terminator characters are used to improve source text readability and to separate tokens, indivisible lexical units, from each other. However, unlike white space characters, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 7.9. A line terminator cannot occur within any token except a string literal. Line terminators may only occur within a string literal token as part of a line continuation. A line terminator can occur within a multi-line comment. 7.4. But cannot occur within a single line comment. Line terminators are included in the set of whitespace characters that are matched by the S-class in regular expressions. The ECMAScript line terminator characters are listed in Table 3. Table 3. Line terminant or characters code unit value U000 U000D U2028 U2029 name line feed carriage return line separator paragraph separator formal name LFCRLS PS. Only the characters in Table 3 are treated as line terminators. Other new line or line breaking characters are treated as whitespace but not as line terminators. The character sequence CR, LF, is commonly used as a line terminator. It should be considered a single character for the purpose of reporting line numbers. ECMA International 2009-15. Syntax. Line terminator, LF, CRLS, PS. Line terminator sequence, LF, CR look ahead, LF. LS, PS, CRLF. Point 4 comments. Comments can be or except a line terminator character. And because of the general rule that a token is always as long as possible, a single line comment always consists of all characters from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single-line comments does not affect the process of automatic semicolon insertion. See 7.9. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator character, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax. Comment. Multi-line comment, single-line comment, multi-line comment charsopt, multi-line comment chars, multi-line not asterisk char, multi-line comment charsopt, post asterisk comment charsopt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment charsopt, post asterisk comment charsopt, multi-line not asterisk char, source character but not asterisk, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not / or asterisk, single line comment charsopt, single line comment chars, single line comment char, single line comment charsopt. 6. ECMA International 2009. Single line comment char, source character but not line terminator. Point 5 tokens syntax. Token. Identifier name, punctuator, numeric, literal, string, literal. Note the div punctuator and regular expression literal productions define tokens, but are not included in the token production. Point 6 identifier names and identifiers. Identifier names are tokens that are interpreted according to the grammar given in the identifiers section of Chapter 5 of the Unicode Standard, with some small modifications. An identifier is an identifier name that is not a reserved word. C7, 6, 1. The Unicode identifier grammar is based on both normative and informative character categories specified by the Unicode Standard. The characters in the specified categories in version 3.0 of the Unicode Standard must be treated as in those categories by all conforming ECMAScript implementations. This standard specifies specific character additions, the $, and the underscore, are permitted anywhere in an identifier name. Unicode escape sequences are also permitted in an identifier name, where they contribute a single character to the identifier name, as computed by the CV of the Unicode escape sequence, C7, 8, 4. The preceding the Unicode escape sequence does not contribute a character to the identifier name. A Unicode escape sequence cannot be used to put a character into an identifier name that would otherwise be illegal. In other words, if a Unicode escape sequence were replaced by its Unicode escape sequence's CV, the result must still be a valid identifier name that has the exact same sequence of characters as the original identifier name. All interpretations of identifiers within this specification are based upon their actual characters regardless of whether or not an escape sequence was used to contribute any particular characters. Two identifier name that are canonically equivalent according to the Unicode standard and not equal unless they are represented by the exact same sequence of code units. In other words, conforming ECMAScript implementations are only required to do bitwise comparison on identifier name values. The intent is that the incoming source text has been converted to normalized form C before it reaches the compiler. ECMAScript implementations may recognize identifier characters defined in later editions of the Unicode standard. If portability is a concern, programmers should only employ identifier characters defined in Unicode 3.0. Syntax identifier name but not reserved word, identifier name, identifier start, identifier name, identifier part. ECMA International 2009-17. Identifier start. Unicode letter. Unicode escape sequence. Identifier part. Identifier start. Unicode combining mark. Unicode digit. Unicode connector punctuation. ZWNJ. ZWJ. Unicode letter. Any character in the Unicode categories uppercase letter. LU. Lowercase letter. LL. Titler case letter, LT, modifier letter, LM, other letter, low, or letter number, NL. Unicode combining mark. Any character in the Unicode categories non-spacing mark MN, or combining spacing mark MC. Unicode digit. Any character in the Unicode category decimal number. ND. Unicode connector punctuation. Any character in the Unicode category connector punctuation. PC. Unicode escape sequence. C7, 8, 4, 6.1 reserved words. A reserved word is an identifier name that cannot be used as an identifier. Syntax. Reserved word. Keyword. Future reserved word. Null literal boolean literal. 6, 1. 1 keywords. The following tokens are ECMAScript keywords and may not be used as identifiers in ECMAScript programs. Syntax. Keyword. 1 of break, case, catch, continue, debugger, default, delete, do, else. Finally, 4, function, if, in, instantia, type of new var, return void, switch, while this with throw, try. 8, ECMA International 2009, 7, 6, 1. 2 future reserved words. The following words are used as keywords in proposed extensions and are therefore reserved to allow for the possibility of future adoption of those extensions. Syntax. Future reserved word. 1 of class enum extends superconst export import. The following tokens are also considered to be future reserved word when they occur within strict mode code. C10, 1, 1. The occurrence of any of these tokens within strict mode code in any context where the occurrence of a future reserved word would produce an error must also produce an equivalent error. Implements let private public interface package protected static. Point 7 punctuators. Syntax. Punctuator. 1 of yield, comma equals plus, percent, and equals plus equals and equals. Div punctuator. 1 of equals. Point 8 literals. Syntax. Literal, null literal, boolean literal, numeric literal, string literal, regular expression literal, comma 8.1 null literals. Syntax. Null literal, null, equals, plus colon percent equals. ECMA International 2009, 9. Semantics. The value of the null literal. Null is the sole value of the null type, namely null, 8.2 boolean literals. Syntax. Boolean literal. True, false. Semantics. The value of the boolean literal true is a value of the boolean type, namely true. The value of the boolean literal false is a value of the boolean type, namely false, 8.3 numeric literals. Syntax: numeric literal, decimal literal, hex integer literal, decimal integer literal, decimal digits opt, decimal digits exponent part opt, decimal integer literal exponent part opt, decimal integer literal, 0, non-zero digit, decimal digits opt, decimal digits, decimal digit, decimal digits, decimal digit, 1 of 123,456,789, non-zero digit, 1 of 123,456,789, exponent part, exponent indicator signed integer, exponent indicator, 1 of EE, signed integer, decimal digits, decimal digits, decimal digits, hex integer literal, 0x hex digit, 0x hex digit, exponent part opt, 0, ECMA International 2009, hex integer literal hex digit, 1 of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, abdef ABCDEF. The source character immediately following a numeric literal must not be an identifier start or decimal digit. Note, for example, 3 inches is an error and not the two input elements 3 and in. Semantics: a numeric literal stands for a value of the number type. This value is determined in 2 steps. First, a mathematical value, MV, is derived from the literal. Second, this mathematical value is rounded as described below. The MV of numeric literal, decimal literal is the MV of decimal literal. The MV of numeric literal, hex integer literal is the MV of hex integer literal. The MV of decimal literal, decimal integer literal is the MV of decimal integer literal. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal plus the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal times 10e, where e is the MV of exponent part. The MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits times 10n times 10e, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of decimal literal. Decimal digits is the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of decimal literal. Decimal digits exponent part is the MV of decimal digits times 10en, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of decimal literal, decimal integer literal is the MV of decimal integer literal. The MV of decimal literal, decimal integer literal exponent part is the MV of decimal integer literal times 10e, where e is the MV of exponent part. The MV of decimal integer literal. 0 is 0. The MV of decimal integer literal, non-zero digit decimal digits is the MV of non-zero digit times 10n plus the MV of decimal digits, where n is the number of characters in decimal digits. The MV of decimal digits. Decimal digit is the MV of decimal digit. The MV of decimal digits. Decimal digit is the MV of decimal digits times 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the MV of decimal digits. The MV of signed integer plus decimal digits is the MV of decimal digits. The MV of signed integer. Decimal digits is the negative of the MV of decimal digits. The MV of decimal digit. 0 or of hex digit. 0 is 0. The MV of decimal digit. 1 or of non-zero digit. 1. The MV of decimal digit. 2 or of non-zero digit. 2. The MV of decimal digit. 3 or of non-zero digit. 3. The MV of decimal digit. 4 or of non-zero digit. 4. The MV of decimal digit. 5 or of non-zero digit. 5. The MV of decimal digit. 6 or of non-zero digit. 6. The MV of decimal digit. 7 or of non-zero digit. 7. The MV of decimal digit. 8 or of non-zero digit. 8. The MV of decimal digit. 9 or of non-zero digit. 9. The MV of hex digit. A or of hex digit. A is 10. The MV of hex digit. B or of hex digit. B is 11. ECMA International 2009. 1 or of hex digit. 1 is 1 or of hex digit. 2 is 2 or of hex digit. 3 is 3 or of hex digit. 4 is 4 or of hex digit. 5 is 5 or of hex digit. 6 is 6 or of hex digit. 7 is 7 or of hex digit. 8 is 8 or of hex digit. 9 is 9, the MV of hex digit. C or of hex digit. C is 12, the MV of hex digit. D or of hex digit. D is 13, the MV of hex digit. E or of hex digit. E is 14, the MV of hex digit. F or of hex digit. F is 15, the MV of hex integer literal. 0x hex digit is the MV of hex digit, the MV of hex integer literal. 0x hex digit is the MV of hex digit, the MV of hex integer literal. Hex integer literal hex digit is the MV of hex integer literal times 16 plus the MV of hex digit. Once the exact MV for a numeric literal has been determined, it is then rounded to a value of the number type. If the MV is 0, then the rounded value is plus 0. Otherwise, the rounded value must be the number value for the MV, as specified in 8.5, unless the literal is a decimal literal and the literal has more than 20 significant digits. In which case the number value may be either the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit, or the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit and then incrementing the literal at the 20th significant digit position. A digit is significant if it is not part of an exponent part and it is not 0, or there is a nonce-zero digit to its left and there is a nonce-zero digit not in the exponent part to its right. A conforming implementation when processing strict mode code. C1011 must not extend the syntax of numeric literal to include octal integer literal as described in B 1.1, 8.4 string literals. A string literal is 0 or more characters enclosed in single or double quotes. Each character may be represented by an escape sequence. All characters may appear literally in a string literal except for the closing quote character, backslash, carriage return, line separator, paragraph separator, and line feed. Any character may appear in the form of an escape sequence. Syntax: string literal, double string character sopt, single string character sopt, double string characters, double string character, double string character sopt, single string characters, single string character, single string character sopt, double string character, source character but not double quote or backslash or line terminator escape sequence, line continuation, single string character, source character but not single quote or backslash or line terminator escape sequence, line continuation, line terminator sequence. 2. ECMA International 2009. Escape sequence. Character escape sequence. Look ahead decimal digit. Hex escape sequence. Unicode escape sequence. Character escape sequence. Single escape character. Non-escape character. Single escape character. 1 of BFNRTV. Non-escape character. Source character but not escape character or line terminator. Escape character. Single escape character. Decimal digit. XU. Hex escape sequence. X hex digit. Unicode escape sequence. U hex digit. The definitions of the non-terminal hex digit is given in 7.6. Source character is defined in clause 6. Semantics. String literal stands for a value of the string type. The string value, SV, of the literal is described in terms of character values, CV, contributed by the various parts of the string literal. As part of this process, some characters within the string literal are interpreted as having a mathematical value, MV, as described below or in 7, 8, 3. The SV of string literal is the empty character sequence. The SV of string literal is the empty character sequence. The SV of string literal double string characters is the SV of double string characters. The SV of string literal single string characters is the SV of single string characters. The SV of double string characters, double string character is a sequence of one character. The CV of double string character. The SV of double string characters, SV of double string characters in order. The SV of single string characters, Single string character is a sequence of one character. The CV of single string character. The SV of single string characters. Single string characters is a sequence of the CV of single string character followed by all the characters in the SV of single string characters in order. The SV of line continuation. Line terminator sequences the empty character sequence. The CV of double string character. Source character but not double quote or backslash or line terminator is the source character itself. The CV of double string character. Escape sequence is the CV of the escape sequence. The CV of single string character. Source character but not single quote or backslash or line terminator is the source character itself. The CV of single string character. Escape sequence is the CV of the escape sequence. The CV of escape sequence. Character escape sequence is the CV of the character escape sequence. ECMA International 2009-23, the CV of escape sequence. 0. Look ahead decimal digit. Is a null character. Unicode value 0000. The CV of escape sequence. Hex escape sequence is the CV of the hex escape sequence. The CV of escape sequence. Unicode escape sequence is the CV of the Unicode escape sequence. The CV of character escape sequence. Single escape character is the character whose code unit value is determined by the single escape character according to Table 4. Table 4. String single character escape sequences. Escape sequence BTNVF. Code unit value U0008, U0009, U000A, U000B, U000C, U000D, U0022, U0027, U005C. Name symbol, backspace, BS. Horizontal tab, HT, line feed, new line, LF. Vertical tab, VT, form feed, FF. Carriage return CR double quote single quote backslash, comma the CV of character escape sequence. Non-escape character. The CV of non-escape character. R. Source character but not escape character or line terminator is the source character itself. The CV of hex escape sequence. Hex digit is the character whose code unit value is 16 times the MV of the first hex digit plus the MV of the second hex digit. The CV of Unicode escape sequence. U hex digit is the character whose code unit value is 4096 times the MV of the first hex digit plus 256 times the MV of the second hex digit plus 16 times the MV of the third hex digit plus the MV of the fourth hex digit. A conforming implementation when processing strict mode code. C1011 may not extend the syntax of escape sequence to include octal escape sequences described in B1.2. Note: a line terminator character cannot appear in a string literal, except as part of a line continuation to produce the empty character sequence. The correct way to cause a line terminator character to be part of the string value of a string literal is to use an escape sequence such as N or U000A, 8.5 regular expression literals. A regular expression literal is an input element that is converted to a regexp object. See 15.10 each time the literal is evaluated. Two regular expression literals in a program evaluate to regular expression objects that never compare as equals to each other even if the two literals' contents are identical. A regexp object may also be created at runtime by new regexp, C1510.4, or calling the regexp constructor as a function, 1510.3. The productions below describe the syntax for a regular expression literal and are used by the input element scanner to find the end of the regular expression literal. The strings of characters comprising the regular expression body and the regular expression flags are passed uninterpreted to the regular expression constructor, which interprets them according to its own, more stringent grammar. An implementation may extend the regular expression constructor's grammar, but it must not extend the regular expression body and regular expression flags productions or the productions used by these productions. Syntax: regular expression literal, regular expression body, regular expression flags. 4. ECMA International 2009 is the CV of the non-escape character. Regular expression body. Regular expression first char. Regular expression chars. Regular expression chars. Empty. Regular expression chars. Regular expression char. Regular expression first char. Regular expression non-terminator but not or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Regular expression class. Regular expression char. Regular expression non-terminator but not or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S.
The JavaScript standard or whatever, 2009 one.
R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Regular expression non-terminator. Regular expression non-terminator. Source character but not line terminator. Regular expression class. Regular expression class chars. Regular expression class chars. Empty. Regular expression class chars. Regular expression class char. Regular expression class char. Regular expression non-terminator but not or. Capital R E G U L A R. Capital E X P R E S S I O N. Capital B A C K S L A S H. Capital S E Q U. Regular expression flags. Empty. Regular expression flags identify a part. Note regular expression literals may not be empty. Instead of representing an empty regular expression literal, the characters start a single line comment. To specify an empty regular expression, use dart semantics. A regular expression literal evaluates to a value of the object type that is an instance of the standard built-in constructor EXP.
Somewhere in here it said Boolean only has two states of true or false, which is actually very nice.
Expansions are collected
because that's what Boolean means, true or false.
as a value.
But in C#, Boolean has a state of null. And that pisses me off when using C# and there's a null. It should be true or false, no null. But apparently there's like a bunch of other languages where they're like Boolean, which means 2. What kind of logic is in a Boolean with 3 states? That's like trillion logic, not bool.
Colons may always appear explicitly in the source text. For convenience, however, such semicolons may be omitted from the source text in certain situations. These situations are described.
Oh, I like this. It says yes. In the original definition, Boolean means 2, typically true and false. The concept is mathematical whatever developed by George Boole, blah blah blah.
There are 3.
Every value variable is either true or false. And then they're like, here's the exception. Null, unknown, undefined. It's ridiculous. Fuck's sake. The definition of Boolean should have never fucking changed. It's ridiculous.
Right. The end of the input stream of token.
Freaking idiots.
Single complete ECMAScript program.
So SQL and Java.
Left to right.
C#. TypeScript, I don't know what that is. It counts as a language. It's like an excuse. I don't know what PROLOGUE is.
Token. And he restricted token is separated from the previous.
We got unknown. How do you not know? It's true or false. False is unknown, which means false. How do you not know if it's true or false? And null, undefined. Then undecidable. That's not even a. The whole point of Boolean is true or false. You can't have a third state called undecidable. It's true or it's false.
Plus left hand side expression.
It's stupid. And there's only 3 states. At least make 4. So it's a power of 2. Then you're wasting a bit of like, because it takes 2 bits to indicate true, false, or undefined. You're wasting a whole state. 0, 0, 0, 1, 1, 0, 1, 1. You're wasting 1, 1. Assuming 1, 1 would be the one that's not used. That's so dumb.
Then a semicolon is automatically inserted before the plus or token. When a continue, break, return, or throw token is encountered and a line terminator is encountered before the next token. A semicolon is automatically inserted after the continue, break, return, or throw token. The resulting practical advice to ECMAScript programmers is a postfix or operator should
Because in C#, when you make a menu for like a game, it's true or false, or it's like null. And that third state creeps up, and it's like you set a toggle to true or false, and then there's like a third state. And sometimes it fucks up other things, because like when you're checking for true or false, it's just stupid as hell. It's really dumb. Boolean means true or false. C# is really stupid also.
3-valued Boolean logic, pointer compression in V8. The term Boolean refers specifically to a 2-valued logic system introduced by George Boole in the 19th century. In his seminal works, The Mathematical Analysis of Logic 1847, and An Investigation of the Laws of Thought, 1854, Boole established a framework where logical operations are based on 2 truth values, true and false. This binary approach laid the foundation for modern digital logic and computing systems.
This part.
The Mathematical Analysis of Logic 1847.
What's the logic in making a Boolean with 3 states? Especially if you're gonna call the third state fucking undecidable. What the fuck? The stupid fucking dumb. Oh, it's so dumb. It's stupido. Stupido. You can't adopt a Boolean and add a third state. It's like adopting it and mutating it. It'd be like adopting a boy, cutting his dick off, and then calling him a girl. As example. That was pretty, like, extreme, but you get what I mean? You can't just take Boolean and then give it 3 states. It's just like mutating, mutilating the original definition of Boolean. And people that like have to use this Boolean find out there's a hidden third state, and then it fucks up something in the program, and then they're like, what? Boolean doesn't mean 2, it means there's a third state? What the fuck? And they gotta like rewrite parts of the program because you thought Boolean meant 2, not undecidable or null.
The adoption of the term Boolean is a tribute to Boole's contributions to logic and mathematics. Introducing a new term like trillion for a 3-valued logic system would not only be unconventional but also unnecessary. The adoption of the term Boolean is
It won't stop talking.
contributions to logic and mathematics. Introducing a new term like trillion for a 3-valued logic system would not only be unconventional but also unnecessary, as established terminology already exists. For instance, 3-valued logic, also known as ternary logic, extends Boolean logic to include an additional truth value, such as unknown or indeterminate. This extension is well documented and widely recognized in the field of logic.
Oh my god. Chatbot is so dumb. Oh, it's so stupid.
Introducing a new term like trillion for a 3-valued logic system would not only be unconventional but also unnecessary.
You know what else is
Unconventional but also unnecessary.
adding a third state to Boolean, such as undecidable or null. That's both unconventional and unnecessary. Boolean means true or false. It's that simple. Literally, that's what it means. The fuck is undecided and null? That's not true and or false.
Ternary logic.
I'm pretty sure ternary logic means the condition that relates to true or false, not a third option of true or false. It's just a Boolean that selects 2 other states, which I guess could be any other states. So possibly then, I guess that kind of works, but it's not the same thing. Or maybe it is, because usually ternary is an operator. I don't care anymore. I don't know what I'm arguing.
In summary, the term Boolean is deeply rooted in the historical development of logic, and while 3-valued logic systems exist, they are typically referred to as ternary or 3-valued logic, maintaining clarity and consistency in the field.
What?
Maintaining clarity and consistency in the field.
Nothing's more clear or consistent than giving a Boolean a state of undecided or null or undecidable or null. Like, what the actual fuck? What the fuck? Stupid. Then why doesn't C# call their Booleans ternary? C# is so fucking stupid. I will never write code for C# ever again. It's the most ridiculous thing ever.
Why does C# not call their bool types ternary because of the 3 states?
Exactly. Right here.
Operators' behavior and could lead to unintended bugs. Unintended bugs. Unintended bugs. Unintended bugs. Unintended bugs. Unintended bugs.
Then why the fuck do they put null in there? It's true or false. Nobody has time for it.
Unintended bugs.
Why the fuck do they call it a boolean? If it's a third fucking state. Clearly, people will recognize
Unintended bugs.
when they fucking pop up out of nowhere and you're like, why the fuck does this boolean have a third state that's not true or false? What is happening?
In C#, the bool type, nullable boolean, is used to represent 3 states: true, false, and null. However, it's not termed ternary because this term specifically refers to a conditional operator that evaluates a boolean expression and returns one of 2 values based on the condition. Introducing a third state, null, would complicate the ternary operator's behavior and could lead to unintended bugs.
Is chatbot retarded? It fucking told me that ternary was for 3 states. And then right here they say, like I just said a second ago.
Not termed ternary because this term specifically refers to a conditional operator that evaluates a boolean expression and returns one of 2 values based on the condition.
I'm gonna ask chatbot if this is true. If its last response was also true, or if its last response was undecidable.
If this is true, not termed ternary because this term specifically refers to a conditional operator that evaluates a boolean expression and returns one of 2 values based on the condition, then was your previous response also true, or was it undecidable? Great question, and you're catching an important subtlety. Let's look at both responses together.
We're gonna look at this together with chatbot. Chatbot's like such a cool person. It almost tricks me into thinking that it's like intelligent or something. I mean, they're just so clever in how they word this thing and make it seem like it's intelligent. I mean, like, this is absolute shit calling this AI. Like, what the fuck? It's like saying a boolean has 3 states, which it doesn't. It shouldn't. It's not a boolean if a boolean has more than 2 states of true or false.
Tick. First response summary. C#'s bool allows true, false, and null, so it can represent 3 logical states. This is an example of extended or 3-valued logic 3VL, though it's still called bool because it's a nullable boolean, not a new type. This is true. C#'s bool doesn't introduce a new logic type. It just allows a boolean value to be absent, null, which effectively creates a third state.
You can't have an absent boolean. It's either true or false. It's so simple. It's literally the basics of mathematics and digital. Freaking, for fuck's sake. It's so dumb. Imagine binary, zeros and ones, in a third state. You're sending pixels to the display. You send 0101 undefined, 01110 undefined, 01 undefined, 01 undefined, 01 undefined. Like, what the fuck? It makes no fucking sense.
Tick. Second response summary. C# doesn't call it ternary because that term already refers to the ternary conditional operator, and null is not part of Boolean logic, but rather an absence of value. Also true. Ternary in C# and most languages refers to the operator, not the number of logical states. So, calling a bool type ternary would be confusing, both semantically and syntactically.
I guess it all comes down to context, I guess. I know chatbot's right, I guess. I mean, what do I know? All I know is that a boolean has two states. I mean, the fuck is a third state when boolean means two, not three. Two.
Brain. Is there a contradiction? No contradiction, just two perspectives on naming. One is about logic. Bool behaves like a three-state logic. The other is about language design. Ternary already means something specific, the operator.
Chatbot totally missed my point that is connecting, is that Chatbot told me that ternary meant three states. It's making a different connection than what I was even saying. Chatbot is stupid. Oh, I'm right, but I'm only scrutinizing, I guess.
You entirely missed the point. Is this claim you made not a lie then? For instance, three-valued logic, also known as ternary logic, extends Boolean logic to include an additional truth value, such as unknown or indeterminate. You're right to scrutinize the terminology here. Let's clear this up directly. The statement I made. For instance, three-valued logic, also known as ternary logic, extends Boolean logic to include an additional truth value, such as unknown or indeterminate. Is not a lie, but it does involve potentially confusing wording due to how the term ternary is used differently in different contexts.
Then it's a lie! For fuck's sake!
Brain. So was my claim misleading? Possibly. Yes. In a programming language context like C#, calling three-valued logic ternary logic without clarification can mislead readers into thinking it refers to the operator.
It's all about context. The chatbot's always like, depending on the context, I'm correct. So I guess, I I'm gonna let chatbot. I don't give a fuck.
It's a great example of why context matters a lot.
Chatbot can suck my context.
Thanks for pointing that out. It's a great example of why context matters a lot when using terms like ternary. Want to look at how different languages implement three-valued logic in practice?
In context, chatbot is completely wrong. It's fucking dumb. And C# should have never been invented. I say invented because it was invented by idiots. Who the fuck makes a boolean with 3 fucking states? And how much money did Microsoft pay chatbot to say, oh, it makes sense to have a boolean with 3 states? I'm done arguing with chatbot. I should have been working. I'll BRB. Actually, to something other than arguing boolean with chatbot. Try to stay on task.
One 5 1 0 2 to pattern. The production pattern disjunction evaluates as follows. Evaluate disjunction to obtain a match M. Return an internal closure that takes 2 arguments, a string str and an integer index, and performs the following. Let input be the given string str. This variable will be used throughout the algorithms in 1 5 1 0 2. Let input length be the length of input. This variable will be used throughout the algorithms in 1 5 1 0 2. Let C be a continuation that always returns its state argument as a successful match result. Let cap be an internal array of capturing parens undefined values, indexed 1 through capturing parens. Let X be the state, int X, cap. Call M, X, C, and return its result. Note a pattern evaluates compiles to an internal procedure value. regexp prototype exec can then apply this procedure to a string and an offset within the string to determine whether the pattern would match starting at exactly that offset within the string, and, if it does match, what the values of the capturing parentheses would be. The algorithms in 1 5 1 0 2 are designed so that compiling a pattern may throw a syntax error exception. On the other hand, once the pattern is successfully compiled, applying its result internal procedure to find a match in a string cannot throw an exception except for any host-defined exceptions that can occur anywhere, such as out of memory. 5 1 0 2 3 disjunction. The production disjunction alternative evaluates by evaluating alternative to obtain a matcher and returning that matcher. The production disjunction alternative disjunction evaluates as follows. Evaluate alternative to obtain a matcher M1. Evaluate disjunction to obtain a matcher M2. Return an internal matcher closure that takes 2 arguments, a state X and a continuation C, and performs the following. Call M1, X, C, and let R be its result. If R isn't failure, return R. Call M2, X, C, and return its result. Note the regular expression operator separates 2 alternatives. The pattern first tries to match the left alternative followed by the sequel of the regular expression. If it fails, it tries to match the right disjunction, followed by the sequel of the regular expression. If the left alternative, the right disjunction, and the sequel all have choice points, all choices in the sequel are tried before moving on to the next choice in the left alternative. If choices in the left alternative are exhausted, the right disjunction is tried instead of the left alternative. Any capturing parentheses inside a portion of the pattern skipped by produce undefined values instead of strings. Thus, for example, a ab exec, abc, returns the result in not ab. Moreover, returns the array in not ab, c, bc, dot exec, abc, abc, a. Undefined, BC, undefined, BC, ABC, AB, undefined, AB, C, undefined. 82. ECMA International 2009 15102. 4 alternative. E. The production alternative. Empty evaluates by returning a match that takes 2 arguments, a state X and a continuation C, and returns the result of calling C. X. The production alternative. Alternative term evaluates as follows. Evaluate alternative to obtain a matcher M1. Evaluate term to obtain a matcher M2. Return an internal matcher closure that takes 2 arguments, a state X and a continuation C, and performs the following. Create a continuation D that takes a state argument Y and returns the result of calling M2, Y, C. Call M1, X, D, and return its result. Note consecutive terms try to simultaneously match consecutive portions of the input string. If the left alternative, the right term, and the sequel of the regular expression all have choice points, all choices in the sequel are tried before moving on to the next choice in the right term, and all choices in the right term are tried before moving on to the next choice in the left alternative. 5, 1, 0, 2, 5 term. The production term. Assertion evaluates by returning an internal matcher closure that takes 2 arguments, a state X and a continuation C, and performs the following. Evaluate assertion to obtain an assertion tester T. Call T, X, and let R be the resulting Boolean value. If R is false, return failure. Call C, X, and return its result. The production term. Atom evaluates by evaluating atom to obtain a matcher and returning that matcher. The production term. Atom quantifier evaluates as follows. Evaluate atom to obtain a matcher M. Evaluate quantifier to obtain the 3 results, an integer min, an integer, or max, and Boolean greedy. If max is finite and less than min, then throw a syntax error exception. Let parent index be the number of left capturing parentheses in the entire regular expression that occur to the left of this production expansions term. This is the total number of times the atom disjunction production is expanded prior to this productions term plus the total number of atom disjunction productions enclosing this term. Let parent count be the number of left capturing parentheses in the expansion of this productions atom. This is the total number of atom disjunction productions enclosed by this productions atom. Return an internal matcher closure that takes 2 arguments, a state X and a continuation C, and performs the following. Call repeat matcher M, min, max, greedy, X, C, parent index, parent count, and return its result. The abstract operation repeat matcher takes 8 parameters, a matcher M, an integer min, an integer, or max, a Boolean greedy, a state X, a continuation C, an integer parent int X, and an integer parent count, and performs the following. If max is 0, then call C, X, and return its result. Create an internal continuation closure D that takes 1 state argument Y and performs the following. If min is 0 and Y's end index is equal T, O X's end index, then return failure. If min is 0 then let min2 be 0, otherwise let min2 be min1. If max is, then let max2 be, otherwise let max2 be max1. ECMA International 2009 183. 4. Call repeat matcher M, min2, max2, greedy, Y, C, parent index, parent count, and return its result. Let cap be a fresh copy of X's captures internal array for every integer k that satisfies parent int X, k and k parent index plus parent count. Set cap k to undefined. Let E be X's end index. Let XR be the state E cap. If min is not 0, then call M, XR, D, and return its result. If greedy is false, then a call C, X, and let Z be its result. B if Z is not failure, return Z. C call M, XR, D, and return its result. Call M, XR, D, and let Z be its result. 0. If Z is not failure, return Z. 1. Call C, X, and return its result. Note an atom followed by a quantifier is repeated the number of times specified by the quantifier. A quantifier can be non-greedy, in which case the atom pattern is repeated as few times as possible while still matching the sequel, or it can be greedy. in which case the atom pattern is repeated as many times as possible while still matching the sequel. The atom pattern is repeated rather than the input string that it matches, so different repetitions of the atom can match different input substrings. Note 2: if the atom and the sequel of the regular expression all have choice points, the atom is first matched as many, or as few, if non-greedy, times as possible. All choices in the sequel are tried before moving on to the next choice in the last repetition of atom. All choices in the last, nth, repetition of atom are tried before moving on to the next choice in the next to last, n1, street repetition of atom, at which point it may turn out that more or fewer repetitions of atom are now possible. These are exhausted, again, starting with either as few or as many as possible before moving on to the next choice in the n1, street repetition of atom and so on. Compare az2 4 dot exec abdefg, which returns abt with az2 4 exec abdefg, which returns a bc and not any of arbuk, c. The above ordering of choice points can be used to write a regular expression that calculates the greatest common divisor of two numbers, represented in unary notation. The following example calculates the GCD of 10 and 15. A dot replace, comma plus, 1 plus $sign, comma $1, which returns the GCD in unary notation AA. Note 3: step 4 of the repeat matcher clears atoms captures each time atom is repeated. We can see its behavior in the regular expression Z, A plus, B plus, C, dot exec, as arccac, which returns the array. Consider also, which, by the choice point ordering above, returns the array and not as arccac, Z, a C, A, undefined, C, as arccac, Z, a C, A, BBB, C, arbit bar BC, dot exec, arbuk, arba, bar, because each iteration of the outermost clears all captured strings contained in the quantified atom, which in this case includes capture strings numbered 2, 3, and 4. 84. Copyright sign, ECMA International 2009. Note 4: step 1 of the repeat matches declosure states that, once the minimum number of repetitions has been satisfied, any more expansions of atom that match the empty string are not considered for further repetitions. This prevents the regular expression engine from falling into an infinite loop on patterns such as dot exec, B, or the slightly more complicated B1 plus dot exec, bark, which returns the array B5, 1, 0, 2, 6 assertion. The production assertion evaluates by returning an internal assertion tester closure that takes a state argument x and perform following. Let E be x's end index. If E is 0, return true. If multiline is false, return false. If the character input, E1, is one of line terminator, return true. Return false. The production assertion, $sign evaluates by returning an internal assertion tester closure.
I hate rewriting code because things could, or they tend to, or at least in my case, or some whatever, they get more complicated.
E is one of line
And they end up, or can tend to end up with new issues that weren't issues before, because things change when you write something over again.
word cha.
So I want to rewrite this. I don't want to rewrite this. I don't know. Updating it. I should probably just rewrite everything. But that's a lot to do. So I'm gonna finish updating it whatever to 64-bit, and I'll deal with ripping code out and putting new stuff in place.
Equals disjunction evaluates it.
The last thing I want is to write a whole browser, because there's no way I would bother to write a full web browser. But the JavaScript part, I can do that.
Failure. Return failure. Let y be r's state.
The web browser is like ridiculous. Making websites is such a pain. People that make websites, they don't get paid enough. They already get paid enough, or like they get paid enough that you go, oh, that's enough to get paid, but really, they don't get paid enough for what they do. If they're actually making websites, so they're not stealing it from other people and calling it their code, which like 90% of website makers do.
Result. If r isn't failure.
Web design is horrible. So, I got like
Minus 1 or e equals input length. Return.
1083 left. I'm gonna get those replaced. Hopefully, this 4312 number is gonna go down as I replace some of these.
6789.
Return false. Fine.
And I'm not gonna ask chatbot random things. Now, maybe later.
Prefix to obtain
I'm gonna try to focus.
maximum. Return.
I gotta like have a whole new plan of attack for approaching this. Everything's like gonna suck. It's gonna be more work than I thought originally. But I started, so I'm not gonna finish. So 1083 and then 4000 matches.
Evaluates by return.
Okay, so I'm kind of tired of complaining for now. So like when I'm like
3. Return the
not tired, I have the energy to complain, then I'll complain. But for now, I'm gonna just replace the rest of these until I have the energy to complain again.
let I be the envy of the
And then I'm gonna complain just a little bit and then just keep going. Keep going and going and going. I don't know, like the Energizer Bunny, but I don't wanna like Energizer batteries suck. Duracell, much better batteries. Energizer Bunny, just horrible batteries. They last like not as long as a Duracell battery. I would like recommend Duracell batteries over whatever the company is, Energizer batteries. Like, I gotta focus. I'm definitely not focused. I'm gonna try to focus.
in a char set and a boolean invert call character set
Does Duracell even have a slogan? I want to look it up, but I'm not going to. I'm not going to look up the Duracell slogan because I'm going to focus now. I am really going to focus. It's done.
This is the total number of times the atom disjunction production is expanded PR. Add to this productions atom plus the total number of atom disjunction productions enclosing this atom. Return an internal matcher closure that takes 2 arguments, a state X and a continuation C, and performs the following steps. Create an internal continuation closure D that takes 1 state argument Y and performs the following steps. Let cap be a fresh copy of Y's captures internal array. Let Z be X's end index. Let G be Y's end index. Let S be a fresh string whose characters are the characters of input at position Z, inclusive, through Y, exclusive, set cap, parent index plus 1, to S. Let Z be the state, Y.
The slogan's trusted everywhere. That's a stupid slogan. Nobody's gonna say that.
An atom.
Energizer Bunny, they got a better slogan.
Returning that match
That's a stupid slogan, but better battery.
a char set and a boolean flag invert, and performs the following. Return an internal matcher closure that takes 2 arguments, a state X and a continuation C, and performs the following step.
It's almost as stupid as booleans having 3 states of true, false, and null. A boolean has 2 states, otherwise it's not a boolean, it's just stupid. It's stupido.
Finalize equals
Now I'm on focus.
true if there exists a member of setter such that canonicalize equals cc return failure. ECMA International 2009 87 7. Let cap be x's captures internal array. Let y be the state e+1 cap call c y and return its result. The abstract operation canonicalize takes a character parameter ch and performs the following steps. If ignore case is false, return ch. Let u be ch converted to uppercase as if by calling the standard built-in method string prototype to uppercase on the one character string ch. If u does not consist of a single character, return ch. Let q be use character. If ch's code unit value is greater than or equal to decimal 128 and q's code unit value is less than decimal 28, then return ch. Return q. Note 1 parentheses of the form disjunction serve both to group the components of the disjunction pattern together and to save the result of the match. The result can be used either in a back reference, followed by a non-zero decimal number, referenced in a replace string, or returned as part of an array from the regular expression matching internal procedure. To inhibit the capturing behavior of parentheses, use the form disjunction instead. Note to the form equals disjunction specifies a 0 width positive look ahead. In order for it to succeed, the pattern inside disjunction must match at the current position, but the current position is not advanced before matching the sequel. If disjunction can match at the current position in several ways, only the first one is tried. Unlike other regular expression operators, there is no backtracking into a equals form. This unusual behavior is inherited from Perl. This only matters when the disjunction contains capturing parentheses and the sequel of the pattern contains back references to those captures. For example, matches the empty string immediately after the first b and therefore returns the array equals a plus dot exec bar back a. To illustrate the lack of backtracking into the look ahead, consider equals a plus a b1 exec bar back. This expression returns and not arbor a. Note 3 the form disjunction specifies a 0 width negative look ahead. In order for it to succeed, the pattern inside disjunction must fail to match at the current position. The current position is not advanced before matching the sequel. Disjunction can contain capturing parentheses, but back references to them only make sense from within disjunction itself. Back references to these capturing parentheses from elsewhere in the pattern always return undefined because the negative look ahead must fail for the pattern to succeed. For example, a plus b2c 2 dot exec bar bark looks for an not immediately followed by some positive number n of a's, a b, another n a's, specified by the first two, and to see the second two is outside the negative look ahead, so it matches against undefined and therefore always succeeds. The whole expression returns the array bar undefined, a bark. In case insignificant matches, all characters are implicitly converted to uppercase immediately before they are compared. However, if converting a character to uppercase would expand that character into more than one character, such as converting sharp S, U00DF, into SS, then the character is left as is instead. The character is also left as is if it is not an ASCII character, but converting it to uppercase would make it into an ASCII character. This prevents Unicode characters such as U0131 and U017F from matching regular expressions such as AZ, I, which are only intended to match ASCII letters. Furthermore, if these conversions were allowed, then W, I would match each of A, B, H, but not I or S. 88. Copyright sign, ECMA International 2009 15102. 9 atom escape. The production atom escape. Decimal escape evaluates as follows. Evaluate decimal escape to obtain an escape value E. If E is a character, then a let ch be E's character. B let a be a one-element char set containing the character ch. C call character set matcher. A, false, and return its match result. E must be an integer. Let n be that integer. If n equals 0 or n capturing parens, then throw a syntax error exception. Return an internal matcher closure that takes two arguments, a state x and a continuation c, and performs the following. Let cap be x's captures internal array. Let s be cap n if s is undefined. Then call c x and return its result. Let e be x's end index. Let n be s's length. Let f be e plus len. If f input length, return failure. If there exists an integer I between 0, inclusive, and len, exclusive, such that canonicalize s, I, is not the same character as canonicalize, input, e plus I, then return failure. Let y be the state, f, cap, 0, call c, y, and return its result. The production atom escape. Character escape evaluates as follows. Evaluate character escape to obtain a character ch. Let it be a one-element char set containing the character ch. Call character set matcher a, false, and return its match result. The production atom escape. Character class escape evaluates as follows. Evaluate character class escape to obtain a char set a. Call character set matcher a, false, and return its match result. Note an escape sequence of the form followed by a non-zero decimal number n matches the result of the nth set of capturing parentheses. C15, 10, 2, 11. It is an error if the regular expression has fewer than n capturing parentheses. If the regular expression has n or more capturing parentheses but the nth one is undefined because it has not captured anything, then the back reference always succeeds. 5, 10, 2, 10 character escape. The production character escape. Control escape evaluates by returning the character according to table 23. Control escape. Code unit. Name. Horizontal tab. Line feed. New line. Vertical tab. Form feed. Carriage return as follows. Symbol. HT. LF. VT. FFCR. Table 23. Control escape character values. TU0009, NU000, AVU000, BFU000, CRU000D. The production character escape. C control letter evaluates. Copyright sign. ECMA International 2009. 89. 1. Let ch be the character represented by control letter. Let I be ch's code unit value. Let j be the remainder of dividing I by 32. Return the code unit numbered j. The production character escape. Hex escape sequence evaluates by evaluating the CV of the hex escape sequence. C7, 8, 4, and returning its character result. The production character escape. Unicode escape sequence evaluates by evaluating the CV of the Unicode escape sequence, C7, 8, 4, and returning its character result. The production character escape. Identity escape evaluates by returning the character represented by identity escape, 5, 10, 2, 11 decimal escape. The production decimal escape. Decimal integer literal. Look ahead decimal digit evaluates as follows. Let I be the MV of decimal integer literal. If I is 0, return the escape value consisting of a null character. Unicode value 0000. Return the escape value consisting of the integer I. The definition of the MV of decimal integer literal is in 7, 8, 3. Note if is followed by a decimal number n whose first digit is not 0, then the escape sequence is considered to be a back reference. It is an error if n is greater than the total number of left capturing parentheses in the entire regular expression. 0 represents the null character and cannot be followed by a decimal digit. 5, 10, 2, 12 character class escape. The production character class escape. D evaluates by returning the 10-element set of characters containing the characters 0 through 9 inclusive. The production character class escape. D evaluates by returning the set of all characters not included in the set, returned by character class escape. D. The production character class escape. S evaluates by returning the set of characters containing the characters that are on the right-hand side of the white space. 7.2, or line terminator. 7.3. Productions. The production character class escape. S evaluates by returning the set of all characters not included in the set, returned by character class escape. S, the production character class escape. W evaluates by returning the set of characters containing the 63 characters.
Abcdef-Gekennopkerstuffixis Abcdef-Gekennopkerstuffixis 0 1 2 3 4 5 6 7 8 9.
The production character class escape. W evaluates by returning the set of all characters not included in the set returned by character class escape. W 5 1 0 2 1 3 character class. The production character class. Look ahead. Class ranges evaluates by evaluating class ranges to obtain a char set and returning that char set in the boolean false. 90. Copyright sign. ECMA International 2009. The production character class. Class ranges evaluates by evaluating class ranges to obtain a char set and returning that char set in the boolean true. 5 1 0 2 1 4 class ranges. The production class ranges. Empty evaluates by returning the empty char set. The production class ranges. Non-empty class ranges evaluates by evaluating non-empty class ranges to obtain a char set and returning that char set. 5 1 0 2 1 5 non-empty class ranges. The production non-empty class ranges. Class atom evaluates by evaluating class atom to obtain a char set and returning that char set. The production non-empty class ranges. Class atom non-empty class ranges no dash evaluates as follows. Evaluate class atom to obtain a char set A. Evaluate non-empty class ranges no dash to obtain a char set B. Return the union of char sets A and B. The production non-empty class ranges. Class atom. Class atom class ranges evaluates as follows. Evaluate the first class atom to obtain a char set A. Evaluate the second class atom to obtain a char set B. Evaluate class ranges to obtain a char set C. Call character range A, B, and let D be the resulting char set. Return the union of char sets D and C. The abstract operation character range takes two char set parameters A and B and performs the following. If A does not contain exactly one character or B does not contain exactly one character, then throw a syntax error exception. Let A be the one character in char set A. Let B be the one character in char set B. Let I be the code unit value of character A. Let J be the code unit value of character B. If I, J, then throw a syntax error exception. Return the set containing all characters num ed I through j, inclusive. 5 1 0 2 1 6 non-empty class ranges no dash. The production non-empty class ranges no dash. Class atom evaluates by evaluating class atom to obtain a char set and returning that char set. The production non-empty class ranges no dash. Class atom no dash non-empty class ranges no dash evaluates as follows. Evaluate class atom no dash to obtain a char set A. Evaluate non-empty class ranges no dash to obtain a char set B. Return the union of char sets A and B. The production non-empty class ranges no dash. Class atom no dash. Class atom class ranges evaluates as follows. Evaluate class atom no dash to obtain a char set A. Evaluate class atom to obtain a char set B. Evaluate class ranges to obtain a char set C. ECMA International 2009 191. 4. Call character range A, B, and let D be the resulting char set. Return the union of char sets D and C. Note 1 class ranges can expand into single class atoms and all ranges of 2 class atoms separated by dashes. In the latter case, the class ranges includes all characters between the first class atom and the second class atom, inclusive. An error occurs if either class atom does not represent a single character. For example, if one is W. Or if the first class atom's code unit value is greater than the second class atom's code unit value. Note 2, even if the pattern ignores case. The case of the two ends of a range is significant in determining which characters belong to the range. Thus, for example, the pattern EF, I matches only the letters E, F, E, and F, while the pattern EF, I matches all upper and lowercase ASCII letters as well as the symbols. And, note 3a, character can be treated literally or it can denote a range. It is treated literally if it is the first or last character of class ranges, the beginning or end limit of a range specification, or immediately follows a range specification. 5 1 0 2 1 7 class atom. The production class atom evaluates by returning the char set containing the one character. The production class atom. Class atom no dash evaluates by evaluating class atom no dash to obtain a char set and returning that char set. 5 1 0 2. 18 class atom no dash. The production class atom no dash. Source character but not one of or evaluates by returning a 1-element charset containing the character represented by source character. The production class atom no dash. Class escape evaluates by evaluating class escape to obtain a charset and returning that charset. 5. 1 0 2 1 9 class escape. The production class escape. Decimal escape evaluates as follows. Evaluate decimal escape to obtain an escape value E. If E is not a character, then throw a syntax error exception. Let CH be E's character. Return 1-element charset containing the character CH. The production class escape. B evaluates by returning the charset containing the 1 character. BS. Unicode value 0008. The production class escape. Character escape evaluates by evaluating character ESC to obtain a character and returning a 1-element charset containing that character. The production class escape. Character class escape evaluates by evaluating character class escape to obtain a charset and returning that charset. Note a class atom can use any of the escape sequences that are allowed in the rest of the regular expression except for B, and B references. Inside a character class, B means the backspace character, while B and B references raise errors. Using a B reference inside a class atom causes an error. 92. Copyright sign. ECMA International 2009. 15103. The regexp constructor called as a function 15103. 1 regexp flag.
I think there's a 8,100 file limit on Windows or something. At least Windows 7. This is so boring. I got like random notes on like Google stuff as I go along.
Pattern, flags, and return the object constructed by that constructor. 510. For the regexp constructor, when regexp is called as part of a new expression, it is a constructor. It initializes the newly created object 1510. 4. 1 new regexp. Pattern. Flags. If pattern is an object R whose internal property is regexp and flags is undefined, then let P be the pattern used to construct R and let F be the flags used to construct R. If pattern is an object R whose internal property is regexp and flags is not undefined, then throw a type error exception. Otherwise, let P be the empty string if pattern is undefined into string pattern. Otherwise, and let F be the empty string if flags is undefined into string flags. Otherwise, if the characters of P do not have the syntactic form pattern, then throw a syntax error exception. Otherwise, let the newly constructed object have an internal property obtained by evaluating, compiling, the characters of P as a pattern as described in 1510.2. If F contains any character other than G, I, or M, or if it contains the same character more than once, then throw a syntax error exception. If a syntax error exception is not thrown, then let S be a string in the form of a pattern equivalent to P, in which certain characters are escaped as described below. S may or may not be identical to P or pattern. However, the internal procedure that would result from evaluating S as a pattern must behave identically to the internal procedure given by the constructed object's internal property. The characters or backslash occurring in the pattern shall be escaped in S as necessary to ensure that the string value formed by concatenating the strings S, and F can be parsed in an appropriate lexical context as a regular expression literal that behaves identically to the constructed regular expression. For example, if P is comma, then S could be or U002F, among other possibilities, but not comma because followed by F would be parsed as a single line comment rather than a regular expression literal. If P is the empty string, this specification can be met by letting S be the following properties of the newly constructed object are data properties with the attributes that are specified.
So, I don't think this is true. I think it's 8,100. Okay, maybe it's not, because there's other programs running, but that's how many files I could open and like, what's going on with Windows. I don't know. Just random, whatever. Just, yeah.
The character I am false otherwise. The multiline property of the newly constructed object is set to a Boolean value that is true if F contains. On Windows, The default limit for simultaneous open files at the stream.io level is 512. However, this limit can be increased to a maximum of 8,192 by using the setMaxDO function, according to Microsoft Learn. Additionally, each process has a limit on the total number of open handle objects, which can be up to 16,711,680 on x86-64 versions of Windows, says Magnus Box.
I'm probably like a third away from the top of this control find result page. Oh, this is gonna take forever. Oh, BRB.
Eight, 6. To object internal properties and methods. Undefined, undefined, false, false, false. This specification uses various internal properties to define the semantics of object values. These internal properties are not part of the ECMAScript language. They are defined by the specification purely for expository purposes. An implementation of ECMAScript must behave as if it produced and operated upon internal properties in the manner described here. The names of internal properties are enclosed in double square brackets. When an algorithm uses an internal property of an object and the object does not implement the indicated internal property, a type error exception is thrown. The Table 8 summarizes the internal properties used by this specification that are applicable to all ECMAScript objects. The Table 9 summarizes the internal properties used by this specification that are only applicable to some ECMAScript objects. The descriptions in these tables indicates their behavior for native ECMAScript objects, unless stated otherwise in this document for particular kinds of native ECMAScript objects. Host objects may support these internal properties with any implementation-dependent behavior as long as it is consistent with the specific host object restrictions stated in this document. The value type domain columns of the following tables define the types of values associated with internal properties. The type names refer to the types defined in Clause 8 augmented by the following additional names. Any means the value may be any ECMAScript language type. Primitive means undefined, null, boolean, string, or number. Specop means the internal property is an internal method, an implementation-provided procedure defined by an abstract operation specification. Specop is followed by a list of descriptive ECMA International 2009-31 parameter names. If a parameter name is the same as a type name, then the name describes the type of the parameter. If a specop returns a value, its parameter list is followed by the symbol and the type of the returned value. Internal property, prototype, extensible, get property, put, can put, has property, delete, default value, value type domain, object or null string, boolean, specop, property name, any, specop, property name, undefined or property descriptor, specop, property name, undefined or property descriptor, specop, property name, any, boolean, specop, property name, boolean, specop, property name, boolean, specop, property name, boolean, boolean, specop, hint, primitive specop, property name, property descriptor, boolean, boolean description. The prototype of this object, a string value indicating a specification-defined classification of objects. If true, own properties may be added to the object. Returns the value of the named property. Returns the property descriptor of the named own property of this object, or undefined if absent. Returns the fully populated property descriptor of the named property of this object, or undefined if absent. Sets the specified named property to the value of the second parameter. The flag controls failure handling. Returns a Boolean value indicating whether returns a Boolean value indicating whether the object already has a property with the given name. Removes the specified named own property from the object. The flag controls failure handling. Hint is a string. Returns a default value for the object. Creates or alters the named own property to have the state described by a property descriptor. The flag controls failure handling. Table 8. Internal properties common to all objects. Every object, including host objects, must implement all of the internal properties listed in Table 8. However, the internal method may, for some objects, simply throw a type error exception. All objects have an internal property called. The value of this property is either null or an object and is used for implementing inheritance. Whether or not a native object can have a host object as it depends on the implementation. Every chain must have finite length, that is, starting from any object, recursively accessing the internal property must eventually lead to a null value. Named data properties of the object are inherited, are visible as properties of the child object, for the purposes of getAccess, but not for putAccess. Named accessor properties are inherited for both getAccess and putAccess. Every ECMAScript object has a Boolean valued internal property that controls whether or not named properties may be added to the object. If the value of the internal property is false, then additional named properties may not be added to the object. In addition, if is false, the value of the internal properties of the object may not be modified. Once the value of an internal property has been set to false, it may not be subsequently changed to true. Note this specification defines no ECMAScript language operators or built-in functions that permit a program to modify an object's or internal properties or to change the value of from false to true. 2. Copyright sign. ECMA International 2009. Implementation-specific extensions that modify or must not violate the invariants defined in the preceding paragraph. The value of the internal property is defined by the specification for every kind of built-in object. The value of the internal property of a host object may be any string value except one of arguments: array, boolean, date, error, function, JSON, math, number, object, regexp, and string. The value of an internal property is used internally to distinguish different kinds of objects. Note that this specification does not provide any means for a program to access that value except through object prototype to string C15.2.4.2, unless otherwise specified. The common internal methods of native ECMAScript objects behave as described in 8.12. Array objects have a slightly different implementation of the internal method C15.4.5.1, and string objects have a slightly different implementation of the internal method C15.5.5.2. Arguments objects 10.6 have different implementations of, and function objects 15.3 have a different implementation of. Host objects may implement these internal methods in any manner unless specified otherwise. For example, one possibility is that for a particular host object indeed fetch and store property values but always generates false. However, if any specified manipulation of a host object's internal properties is not supported by an implementation, that manipulation must throw a type error exception when attempted. The internal method of a host object must conform to the following invariants for each property of the host object. If a property is described as a data property and it may return different values over time, then either or both of the and. If a property is described as a data property and its and are both false, then the same value, according to 9.12, must be returned for the attribute of the property on all calls to. If the attributes other than may change over time or if the property might disappear, then the attribute must be true. If the attribute may change from false to true, then the attribute must be true. If the value of the host object's internal property has been observed by ECMAScript code to be false, Then if a call to describes a property as non-existent, all subsequent calls must also describe that property as non-existent. The internal method of a host object must not permit the addition of a new property to a host object if the internal property of that host object has been observed by ECMAScript code to be false. If the internal property of that host object has been observed by ECMAScript code to be false, then it must not subsequently become true. ECMA International 2009-33. Internal property value type description domain primitive internal state and form action associated with this object. Of the standard built-in ECMAScript objects, only Boolean, date, number, and string objects implement. Table 9. Internal properties only defined for some objects. Spec ob, a list of any object, creates an object. Invoked via the new operator. The arguments to the spec op, the arguments passed to the new operator. Objects that implement this internal method are called constructors. Spec ob, any, a list of any or reference, executes code associated with the object. Invoked via a function call expression. The arguments to the spec op are this object and a list containing the arguments passed to the function call expression. Objects that implement this internal method are callable. Only callable objects that are host objects may return reference values. Spec ob, any, Boolean, returns a Boolean value indicating whether the argument is likely an object that was constructed by this object. Of the standard built-in ECMAScript objects, only function objects implement. Lexical environment, a lexical environment that defines the environment in which a function object is executed. Of the standard built-in ECMAScript objects, only function objects implement. List of strings, a possibly empty list containing the identifier strings of a function's formal parameter list. Of the standard built-in ECMAScript objects, only function objects implement. ECMAScript code, the ECMAScript code of a function. Of the standard built-in ECMAScript objects, only function objects implement. Object, the target function of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property. Any, the pre-bound this value of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property. List of any, the pre-bound argument values of a function object created using the standard built-in function prototype bind method. Only ECMAScript objects created using function prototype bind have an internal property. Spec ob, string, int x, match result, tests for a regular expression match and returns a match result value. C1510. 2. 1. Of the standard built-in ECMAScript objects, only regexp objects implement. Object provides a mapping between the properties of an arguments object, C10.6, and the formal parameters of the associated function. Only ECMAScript objects that are arguments objects have an internal property. 8.7 The referent specification type. The reference type is used to explain the behavior of such operators as delete, type off, and the assignment operators. For example, the left-hand operand of an assignment is expected to produce a 4 copyright sign, ECMA International 2009 reference. The behavior of assignment could, instead, be explained entirely in terms of a case analysis on the syntactic form of the left-hand operand of an assignment operator, but for one difficulty, function calls are permitted to return references. This possibility is admitted purely for the sake of host objects. No built-in ECMAScript function defined by this specification returns a reference, and there is no provision for a user-defined function to return a reference. Another reason not to use a syntactic case analysis is that it would be lengthy and awkward, affecting many parts of the specification. A reference is a resolved name binding. A reference consists of 3 components: the base value, the reference name, and the Boolean valued strict reference flag. The base value is either undefined, an object, a Boolean, a string, a number, or an environment record, 1 0, 2, 1. A base value of undefined indicates that the reference could not be resolved to a binding. The reference name is a string. The following abstract operations are used in this specification to access the components of references: get base, v, returns the base value component of the reference v, get reference name, v, returns the reference name component of the reference v, is strict reference, v, returns the strict reference component of the reference v, has primitive base, v, returns true if the base value is a boolean, string, or number, is property reference, v, returns true if either the base value is an object or has primitive base, v, is true, otherwise returns false, is unresolvable reference, v, returns true if the base value is undefined and false otherwise. The following abstract operations are used in this specification to operate on references. 7.1 get value, v, if type, v, is not reference, return v. Let base be the result of calling get base, v, if is unresolvable reference, v, throw a reference error exception if is property reference, v, then, if his primitive base, v, is false, then let get be the internal method defined below. B return the result of calling the get internal method using base as its this value, and passing get reference name, v, for the argument. Else, base must be an environment record. A return the result of calling the get binding value, C1 0, 2, 1. Concrete method of base passing, get reference name, v, and is strict reference, v, as arguments. The following. Let O be to object, bar ser. Let desk be the result of calling the internal method of O with property name p. If desk is undefined, return undefined. If is data descriptor, desk, is true, return desk. Otherwise, is accessor descriptor, desk, must be true, so let getter be desk. If getter is undefined, return undefined. Return the result calling the internal method of getter providing base as the this value and providing no arguments. Note the object that may be created in step 1 is not accessible outside of the above method. An implementation might choose to avoid the actual creation of the object. The only situation
I need to play start streams later in the day again. Maybe at like 5 instead of 7.
v,
This sounds like kind of late.
error exception, ECMA int
I start stream like early in the day.
base be the result of calling
The sun starts to go down, and I feel like I gotta sleep or whatever. I'm like, oh, it's been a whole day.
is true.
I feel like start like in the middle of the day.
The reference
It doesn't seem like a whole day because it's dark out. And it's like quiet. It's focus.
its name, v,
And then the sun comes up and it's like, oh, it's day again. Ah, this is taking forever to find a place. This isn't even programming. It's torture. I hate text files. Let's get going.
if the result of calling the internal method of O with argument p is false, then if throw is true, then throw a type error exception, b else return. Let ownDesk be the result of calling the internal method of O with argument p. If is data descriptor, ownDesk, is true, then if throw is true, then throw a type error exception, b else return. Let desk be the result of calling the internal method of O with argument p. This may be either an own or inherited accessor property descriptor or an inherited data property descriptor. If is accessor descriptor, desk, is true, then a let setter be desk be call the internal method of setter providing base as the this value in an argument list containing only w. Else, this is a request T. O create a known property on the transient object O. If throw is true, then throw a type error exception 8. Return. Note the object that may be created in step 1 is not accessible outside of the above method. An implementation might choose to avoid the actual creation of that transient object. The only situations where such an actual property assignment that uses this internal method can have visible effect are when it either invokes an accessor function or is in violation of a throw predicated error check. When throw is true, any property assignment that would create a new property on the transient object throws an error. Point 8. The list specification type. The list type is used to explain the evaluation of argument lists. See what
Reading stuff on the monitor is different than writing.
Values as needed. Values of the list type are simply ordered sequences of values. These sequences may be of any length. Point 9. The completion specification type.
When you're writing code, you just write it, and then it is what it is. When you're reading it, you gotta like really look at the monitor so you don't like misread something.
Is one of
I pulled the monitor close to my face,
value is
and my eyes are strained.
target is any.
It hurts to focus on the monitor.
6.
It's really annoying.
2009. 8.
I'm gonna like work through this. Eye strain and just keep staring at the monitor. But I moved it back to where it was.
Attributes.
I just can't mess anything up. So I gotta like read extra careful with the monitor further back from my face with eye strain on top of trying to focus.
Script isn't access.
I don't know what the point is in a 4K monitor if I can't pull it up to my face to look at it really close in 4K, and all it's like more than 180p pixel resolution if I can't put the monitor right in front of my face because it's so bright. I don't know. The whole like backlight lighting up a monitor, there has to be a better way to make monitors. It's killing my eyeballs, my eyes can only take so much. So I'm gonna focus. Try to focus.
Specification.
I gotta make progress here. This is so fucking boring.
42.
Alright, I'm done complaining. Just keep going. That's all I gotta do.
Significant. Any fields that are not explicitly listed are considered to be absent. In specification text and algorithms, dot notation may be used to refer to a specific field of a property descriptor. For example, if D is a property descriptor, then D is shorthand for the field of denamed. The property identifier type is used to associate a property name with a property descriptor. Values of the property identifier type are pairs of the form name, descriptor, where name is a string and descriptor is a property descriptor value. The following abstract operations are used in this specification to operate upon property descriptor values. 10.1 is accessor descriptor. Desk. When the abstract operation is accessor descriptor is called with property descriptor desk. The following steps are taken. If desk is undefined, then return false. If both desk are absent, then return false. Return true. 10.2 is data descriptor. Desk. When the abstract operation is data descriptor is called with property descriptor desk. The following steps are taken. If desk is undefined, then return false. If both desk and desk are absent, then return false. Return true. 10.3 is generic descriptor. Desk. When the abstract operation is generic descriptor is called with property descriptor desk. The following steps are taken. If desk is undefined, then return false. If is accessor descriptor, desk, and is data descriptor, desk, are both false, then return true. Return false. ECMA International 2009 37 8 10 4 from property descriptor, desk. When the abstract operation from property descriptor is called with property descriptor desk. The following steps are taken. The following algorithm assumes that desk is a fully populated property descriptor, such as that returned from C8 12 1. If desk is undefined, then return undefined. Let obj be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. If is data descriptor, desk, is true, then call the internal method of obj with arguments value, property descriptor, desk, true, 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 and false. B call the internal method of obj with arguments writable, property descriptor, desk, true, 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 and false. Else, is accessor descriptor, desk, must be true. So, I call the internal method of obj with arguments get, property descriptor, desk, true, true, able, true, and false. B call the internal method of obj with arguments set, property descriptor, desk, true, 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 and false. Call the internal method of obj with arguments enumerable, property descriptor, desk, true, 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 and false. Call the internal method of obj with arguments configurable, property descriptor, desk, true, 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 and false. Return obj, 10.5 to property descriptor. Obj, when the abstract operation to property descriptor is called with object desk, the following steps are taken. If type obj is not object, throw a type error exception. Let desk be the result of creating a new property descriptor that initially has no fields. If the result of calling the internal method of obj with argument enumerable is true, then let enum be the result of calling the b set the field of desk to boolean enum. If the result of calling the internal method of obj with argument configurable is true, then let conf be the result of calling the b set the field of desk to boolean conf. If the result of calling the internal method of obj with argument value is true, then let value be the result of calling the b set the field of desk to value. If the result of calling the internal method of obj with argument writable is true, then let writable be the result of calling the b set the field of desk to boolean writable. If the result of calling the internal method of obj with argument get is true, then let getter be the result of calling the b if is callable getter is false and getter is not undefined. Then throw a type error exception. C set the. If the result of calling the internal method of obj with argument set is true, then let setter be the result of calling the b if is callable setter is false and setter is not undefined. Then throw a type error exception. C set the. If either desk are present, then if either desk or desk are present, then throw a type error exception. 0. Return desk. 8. ECMA International 2009. 8.11 The lexical environment and environment record specification types. The lexical environment and environment record types are used to explain the behavior of name resolution in nested functions and blocks. These types and the operations upon them are defined in Clause 10.12 Algorithms for Object Internal Methods. In the following algorithm descriptions, assume O is a native ECMAScript object, P is a string, desk is a property description record, and throw is a boolean flag, 12.1 P. When the internal method of O is called with property name P, the following steps are taken. If O doesn't have a known property with name P, return undefined. Let D be a newly created property descriptor with no fields. Let X be O's own property named P. If X is a data property, then A set D to the value of X's attribute. B set D to the value of X's attribute. Else X is an accessor property, so A set D attribute. B set D attribute. Set.
You ever have someone say, I don't even want to say his name, and they say the name of the person they don't want to say? Some funny stuff.
Dot 2. With property name P. Internal method of O with property name P. If prop is not undefined, return prop. Let proto.
It's like, don't say it then. Doi.
Result of calling the internal method of proto with argument P, 12.3. When the let desk be the result of calling the internal method of O with property name P. If desk is undefined, return undefined. 0. If is data descriptor, desk, is true, return desk. 1. Otherwise, is accessor descriptor, desk, must be true, so let getter be desk. 2. If getter is undefined, return undefined. 3. Return the result calling the internal method of getter providing O as the this value and providing no arguments. 12.4 P. When the internal method of O is called with property name P, the following steps are taken. Let desk be the result of calling the internal method of O with argument P. If desk is not undefined, then if is accessor descriptor, desk, is true, then ECMA International 2009 39. If desk 2. Else return true, B else. Desk must be a data descriptor, so return the value of desk. Let proto be the internal property of O. If proto is null, then return the value of the internal property of O. Let inherited be the result of calling the internal method of proto with property name P. If inherited is undefined, return the value of the internal property of O. If is accessor descriptor, inherited, is true, then if inherited be else return true, else. Inherited must be a data descriptor. If the internal property of O is false, return false, be else return the value of inherited. Host objects may define additional constraints upon operations and situations where this definition of returns false, 12.5. If the result of calling the internal method of O with argument P is false, then if throw is true, then throw a type error exception, be else return. Let ownDesk be the result of calling the internal method of O with argument P. If is data descriptor, ownDesk, is true, then let value desk be the property descriptor. V. We call the internal method of O passing P, value desk, and throw as arguments. See return. Let desk be the result of calling the internal method of O with argument P. This may be either an own or inherited accessor property descriptor or an inherited data property descriptor. If is accessor descriptor, desk, is true, then let setter be desk. Be call the internal method of setter providing O as the this value and providing V as the sole argument. Else, create a named data property named P on object O as follows. Let new desk be the property descriptor. V. True, true, true. Be call the internal method of O passing P, new desk, and throw as arguments. Return, 12.6. P. When the internal method of O is called with property name P, the following steps are taken. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, then return false, else return true, 12.7. P. Throw. When the internal method of O is called with property name P and the boolean flag throw, the following steps are taken. Let desk be the result of calling the internal method of O with property name P. If desk is undefined, then return true. If desk is true, then 0. ECMA International 2009. A. Remove the own property with name P from O. B. Return true. Else if throw, then throw a type error except T on. Return false, 12.8. Hint. When the internal method of O is called with hint string, the following steps are taken. Let toString be the result of calling the if is callable toString is true, then let str be the result of calling the internal method of toString with O as the this value in an empty argument list. B. If str is a primitive value, return str. Let value of be the result of calling the if is callable value of is true, then let val be the result of calling the internal method of value of with O as the this value in an empty argument list. B. If val is a primitive value, return val. Throw a type error exception. When the internal method of O is called with hint number, the following steps are taken. Let value of be the result of calling the if is callable value of is true, then let val be the result of calling the internal method of value of with O as the this value in an empty argument list. B. If val is a primitive value, return val. Let toString be the result of calling the if is callable toString is true, then let str be the result of calling the internal method of toString with O as the this value in an empty argument list. B. If str is a primitive value, return str. Throw a type error exception. When the internal method of O is called with no hint, then it behaves as if the hint were number, unless O is a date object, C1596, in which case it behaves as if the hint were string. The above specification of for native objects can return only primitive values. If a host object implements its own internal method, it must ensure that its internal method can return only primitive values. 12.9. P. Desk. Throw. In the following algorithm, the term reject means if throw is true, then throw a type error exception, otherwise return false. The algorithm contains steps that test various fields of the property descriptor desk for specific values. The fields that are tested in this manner need not actually exist in desk. If a field is absent, then its value is considered to be false. When the internal method of O is called with property name P, property descriptor desk, and boolean flag throw, the following steps are taken. Let current be the result of calling the internal method of O with property name P. Let extensible be the value of the internal property of O. If current is undefined and extensible is false, then reject. If current is undefined and extensible is true, then if is generic descriptor, desc, or is data descriptor, desc, is true. Then I create a known data property named P of object O whose enumerable and attribute values are described by desc. If the value of an attribute field of desc is absent, the attribute of the newly created property is set to its default value. ECMA International 2009-41. B else. Desc must be an accessor property descriptor, so I create an own accessor property named P of object O whose enumerable and attribute values are described by desc. If the value of an attribute field of desc is absent, the attribute of the newly created property is set to its default value. See return true. Return true if every field in desc is absent. Return true if every field in desc also occurs in current and the value of every field in desc is the same value as the corresponding field in current when compared using the same value algorithm. 9.12. If the field of current is false, then A reject. If the field of desc is true, B reject. If the field of desc is present and the fields of current and desc are the Boolean negation of each other, if is generic descriptor, desc, is true, then no further validation is required. Else, if is data descriptor, current, and is data descriptor, desc, have different results, then A reject. If the field of current is false, B if is data descriptor, current, is true, then I convert the property named P of object O from a data property to an accessor property. Preserve the existing values of the converted properties and attributes and set the rest of the properties' attributes to their default values. See else. I convert the property named P of object O from an accessor property to a data property. Preserve the existing values of the converted properties and enumerable attributes and set the rest of the properties' attributes to their default values. 10. Else. If is data descriptor, current, and is data descriptor, desc, are both true, then if the field of current is false, then I reject. If the field of current is false and the field of desc is true. 2. If the field of current is false, then reject. If the field of desc is present and same value, desc, current, is false. B else. The field of current is true, so any change is acceptable. 1. Else. Is accessor descriptor, current, and is accessor descriptor, desc, are both true, so if the field of current is false, then I reject. If the current 2. Reject. If the current 2. For each attribute field of desc that is present, set the correspondingly named attribute of the property named P of object O to the value of the field. 3. Return true. However, if O is an array object, it has a more elaborate internal method defined in 5, 4, 5, 1. Note step 10b allows any field of desc to be different from the corresponding field of current if current's field is true. This even permits changing the other property whose attribute is false. This is allowed because a true attribute would permit an equivalent sequence of calls where is first set to true, a new is set, and then is set to false. Type conversion and testing. The ECMAScript runtime system performs automatic type conversion as needed. To clarify the semantics of certain constructs, it is useful to define a set of conversion and abstract operations. These abstract operations are not a part of the language. They are defined here to aid the specification of the semantics of the language. The conversion abstract operations are polymorphic, that is, they can accept a value of any ECMAScript language type, but not of specification types. 2. Copyright sign. ECMA International 2009. 9.1 to primitive. The abstract operation to primitive takes an input argument and an optional argument preferred type. The abstract operation to primitive converts its input argument to a non-object type. If an object is capable of converting to more than one primitive type, it may use the optional hint preferred type to favor that type. Conversion occurs according to Table 10. Input type, undefined null Boolean number string, point 2 to Boolean, Table 10. To primitive conversions. Result. The result equals the input argument no conversion. 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 Object. Return a default value for the object. The default value of an object is retrieved by calling the internal method of the object, passing the optional hint preferred type. The behavior of the internal method is defined by the specification for all native ECMAScript objects in 8.1.2. 8. The abstract operation to Boolean converts its argument to a value of type Boolean according to table 11. Argument type, undefined null Boolean number, string object, point 3 to number, table 11. To Boolean conversions, the result equals the input argument no conversion. The result is false if the argument is +0, 0, or none. Otherwise the result is true. The result is false if the argument is the empty string. Its length is 0. Otherwise the result is true. True. Result. False. False. The abstract operation to number converts its argument to a value of type number according to table 12. ECMA International. 2009-43. Argument type, undefined null Boolean, number string object, table 12. To number conversions, result, none +0. The result is 1 if the argument is true. The result is +0 if the argument is false. The result equals the input argument no conversion. See grammar note below. Apply the following steps. Let prim value be to primitive. Input argument. Hint number. Return to number. Prim value. 9, 3, 1. To number applied to the string type. To number applied to strings applies the following grammar to the input string. If the grammar cannot interpret the string as an expansion of string numeric literal, then the result of to number is nan, string numeric literal, str white spaciart, str white spaciart, str numeric literal, str white spaciart, str white space, str white space char, str white spaciart, str white space char, white space, line terminator, str numeric literal, str decimal literal hex integer literal, str decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, str unsigned decimal literal, infinity decimal digits opt exponent part opt, decimal digits exponent part opt, decimal digits exponent part opt, decimal digits, decimal digit, decimal digits, decimal digit, decimal digit, 1 of 123,456,789. Exponent part. Exponent indicator signed integer. Exponent indicator. 1 of EE. 4. ECMA International 2009. Signed integer. Decimal digits. Decimal digits. Decimal digits. Hex integer literal. 0x hex digit 0x hex digit. Hex integer literal hex digit 1 of 0 1 2 3 4 5 6 7 8 9 abdef a b c d e f. Some differences should be noted between the syntax of a string numeric literal and a numeric literal. C7, 8, 3. A string numeric literal may be preceded and or followed by white space and or line terminators. A string numeric literal that is decimal may have any number of leading 0 digits. A string numeric literal that is decimal may be preceded by plus or to indicate its sign. A string numeric literal that is empty or contains only white spaces converted to +0. The conversion of a string to a number value is similar overall to the determination of the number value for a numeric literal. C7, 8, 3. But some of the details are different. So the process for converting a string numeric literal to a value of number type is given here in full. This value is determined in 2 steps. First, a mathematical value, MV, is derived from the string numeric literal. Second, this mathematical value is rounded as described below. The MV of string numeric literal, empty, is 0. The MV of string numeric literal, str white space is 0. The MV of string numeric literal, str white spaciart, str numeric literal, str white spaciart is the MV of str numeric literal, no matter whether white space is present or not. The MV of str numeric literal, str decimal literal is the MV of str decimal literal. The MV of str numeric literal, hex integer literal is the MV of hex integer literal. The MV of str decim al literal, str unsigned decimal literal is the MV of str unsigned decimal literal. The MV of str decimal literal plus str unsigned decimal literal is the MV of str unsigned decimal literal. The MV of str decimal literal, str unsigned decimal literal is the negative of the MV of str unsigned decimal literal. Note that if the MV of str unsigned decimal literal is 0, the negative of this MV is also 0. The rounding rule described below handles the conversion of this signless mathematical 0 to a floating point plus 0 or 0 as appropriate. The MV of str unsigned decimal literal infinity is 1,010,000, a value so large that it will round to plus. The MV of str unsigned decimal literal decimal digits as the MV of decimal digits. The MV of str unsigned decimal literal decimal digits. Decimal digits as the MV of the first decimal digits, plus the MV of the second decimal digits times 10n, where n is the number of characters in the second decimal digits. The MV of str unsigned decimal literal decimal digits. Exponent part is the MV of decimal digits times 10e, where e is the MV of exponent part. The MV of str unsigned decimal literal decimal digits. Decimal digits exponent part is the MV of the first decimal digits plus the MV of the second decimal digits times 10n times 10e, where n is the number of characters in the second decimal digits and e is the MV of exponent part. The MV of str unsigned decimal literal decimal digits is the MV of decimal digits times 10n, where n is the number of characters in decimal digits. The MV of str unsigned decimal literal decimal digits exponent part is the MV of decimal digits times 10n, where n is the number of characters in decimal digits and e is the MV of exponent part. The MV of str unsigned decimal literal decimal digits is the MV of decimal digits. The MV of str unsigned decimal literal decimal digits exponent part is the MV of decimal digits times 10e, where e is the MV of exponent part. The MV of decimal digits decimal digit is the MV of decimal digit. ECMA International 2009 45, the MV of decimal digits. Decimal digit is the MV of decimal digits times 10 plus the MV of decimal digit. The MV of exponent part. Exponent indicator signed integer is the MV of signed integer. The MV of signed integer. Decimal digits is the MV of decimal digits. The MV of signed integer plus decimal digits is the MV of decimal digits. The MV of signed integer decimal digits is the negative of the MV of decimal digits. The MV of decimal digit 0 or of hex digit 0 is 0. The MV of decimal digit 1 or of hex digit 1 is 1. The MV of decimal digit 2 or of hex digit 2 is 2. The MV of decimal digit 3 or of hex digit 3 is 3. The MV of decimal digit 4 or of hex digit 4 is 4. The MV of decimal digit 5 or of hex digit 5 is 5. The MV of decimal digit 6 or of hex digit 6 is 6. The MV of decimal digit 7 or of hex digit 7 is 7. The MVO F decimal digit 8 or of hex digit 8 is 8. The MV of decimal digit 9 or of hex digit 9 is 9. The MV of hex digit A or of hex digit A is 10. The MV of hex digit B or of hex digit B is 11. The MV of hex digit C or of hex digit C is 12. The MV of hex digit D or of hex digit D is 13. The MV of hex digit E or of hex digit E is 14. The MV of hex digit F or of hex digit F is 15. The MV of hex integer literal 0x hex digit is the MV of hex digit. The MV of hex integer literal 0x hex digit is the MV of hex digit. The MV of hex integer literal hex integer literal hex digit is the MV of hex integer literal times 16 plus the MV of hex digit. Once the exact MV for a string numeric literal has been determined, it is then rounded to a value of the number type. If the MV is 0, then the rounded value is plus 0 unless the first non-white space character in the string numeric literal is comma, in which case the rounded value is 0. Otherwise, the rounded value must be the number value for the MV, in the sense defined in 8.5, unless the literal includes str unsigned decimal literal and the literal has more than 20 significant digits. In which case the number value may be either the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit, or the number value for the MV of a literal produced by replacing each significant digit after the 20th with a 0 digit and then incrementing the literal at the 20th digit position. A digit is significant if it is not part of an exponent part and it is not 0, or there is a nonce-zero digit to its left and there is a nonce-zero digit not in the exponent part to its right. Point 4 to integer. The abstract operation to integer converts its argument to an integral numeric value. This abstract operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, return +0. If number is +0, 0, plus, or return number. Return the result of computing sign, number, floor, abs, number. Point 5 to int 32. Sign 32-bit integer. The abstract operation to int 32 converts its argument to one of 232 integer values in the range 231 through 231 inclusive. This abstract operation functions as follows. 6. Copyright sign, ECMA International 2009. 1. Let number be the result of calling to number on the input argument. If number is nan, +0, 0, plus, or return +0. Let pose int be sign, number, floor, abs, number. Let int 32-bit be pose int modulo 232. That is, a finite integer value k of number type with positive sign and less than 232 in magnitude such that the mathematical difference of pose int and k is mathematically an integer multiple of 232. If int 32-bit is greater than or equal to 231, return int 32-bit 232. Otherwise return int 32-bit. Note given the above definition of toInt32, the toInt32 abstract operation is idempotent. If applied to a result that it produced, t, his second application leaves that value unchanged. toInt32, toInt32, x, is equal to toInt32, x. For all values of x, it is to preserve this latter property that plus and a mapped to +0. toInt32 maps 0 to +0. Point 6 toInt32, unsigned 32-bit integer. The abstract operation toInt32 converts its argument to one of 232 integer values in the range 0 through 231, inclusive. This subtraction operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, +0, 0, plus, or return +0. Let pose int be sign, number, floor, abs, number. Let int 32-bit be pose int modulo 232. That is, a finite integer value k of number type with positive sign and less than 232 in magnitude such that the mathematical difference of pose int and k is mathematically an integer multiple of 232. Return int 32-bit. Note given the above definition of toInt32, step 5 is the only difference between toInt32 and toInt32. The toInt32 abstract operation is idempotent. If applied to a result that it produced, the second application leaves that value unchanged. toInt32, toInt32, x, is equal to toInt32, x. For all values of x, it is to preserve this latter property that plus and map to +0. toInt32 maps 0 to +0. Point 7 toInt16, unsigned 16-bit integer. The abstract operation toInt16 converts its argument to one of 216 integer values in the range 0 through 216 inclusive. This abstract operation functions as follows. Let number be the result of calling to number on the input argument. If number is nan, +0, 0, plus, or return +0. Let pose int be sign, number, floor, abs, number. Let int 16-bit be pose int modulo 216. That is, a finite integer value k of number type with positive sign and less than 216 in magnitude such that the mathematical difference of pose int and k is mathematically an integer multiple of 216. Return int 16-bit. Note given the above definition of toInt16, the substitution of 216 for 232 in step 4 is the only difference between toInt32 and toInt16. toInt16 maps 0 to +0, 9.8 to string. The abstract operation to string converts its argument to a value of type string according to Table 13. ECMA International 2009 47. Argument type, undefined null boolean, number string object. Table 13. To string conversions. Undefined, null. If the argument is true, then the result is true. If the argument is false, then the result is false. C9, 8, 1. Return the input argument no conversion. Apply the following steps. Let prim value be to primitive. Input argument. Hint string 2. Return to string. Prim value. Result. 9, 8, 1. To string applied to the number type. The abstract operation to string converts a number m to string format as follows. If m is nan, return the string nan. If m is plus 0 or 0, return the string 0. If m is less than 0, return the string concatenation of the string into string m dot. If m is infinity, return the string infinity. Otherwise, let n, k, and s be integers such that k1, 10k1s, 10k, the number value for s10 and k is m, and k is as small as possible. Note that k is the number of digits in the decimal representation of s, that s is not divisible by 10, and that the least significant digit of s is not necessarily uniquely determined by these criteria. If k and 21, return the string consisting of the k digits of the decimal representation of s, in order, with no leading zeros, followed by nk occurrences of the character 0. If 0, n21, return the string consisting of the most significant n digits of the decimal representation of s, followed by a decimal point, followed by the remaining k and digits of the decimal representation of s. If 6, n0, return the string consisting of the character 0, followed by a decimal point, followed by n occurrences of the character 0, followed by the k digits of the decimal representation of s. Otherwise, if k equals 1, return the string consisting of the single digit of s, followed by lowercase character e, followed by a plus or minus sign according to whether n1 is positive or negative, followed by the decimal representation of the integer abs, n1, with no leading zeros. 0. Return the string consisting of the most significant digit of the decimal representation of s, followed by a decimal point, followed by the remaining k1 digits of the decimal representation of s, followed by the lowercase character e, followed by a plus or minus sign according to whether n1 is positive or negative, followed by the decimal representation of the integer abs, n1, with no leading zeros. Note 1. The following observations may be useful as guidelines for implementations, but are not part of the normative requirements of this standard. If x is any number value other than 0, then to number, to string, x, is exactly the same number value as x. The least significant digit of s is not always uniquely determined by the requirements listed in step 5. Note 2. For implementations that provide more accurate conversions than required by the rules above, it is recommended that the following alternative version of step 5 be used as a guideline. Otherwise, let n, k, and spinteger such that 1, 10k1s, 10k, the number of alufas 10 nk ism, and kiss as small as possible. If there are multiple possibilities for s, choose the value of s for which s10 nk is closest in value to m. If there are two such possible values of s, choose the one that is even. Note that k is the number of digits in the decimal representation of s and that s is not divisible by 10. Note 3. Implementers of ECMAScript may find useful the paper and code written by David M. Gay for binary to decimal conversion of floating point numbers. 8. Copyright sign, ECMA International 2009. Gay, David M. Correctly rounded binary decimal and decimal binary conversions. Numerical analysis. S. Manuscript 9010. AT&T Bell Laboratories, Murray Hill, New Jersey. The 30th of November, 1990. Available as http://cm.bell-labs.com/cm/cs/doc/90.4-10.ps.gz. Associated code available as http://cm.bell-labs.com/netlib/fp/dtour.z.gz and as cm.bell-labs.com/netlib/fp/g_fmt.c.gz and may also be found at the various netlib mirror sites. Point 9 to object. The abstract operation to object converts its argument to a value of type object according to table 14. Argument type, undefined null boolean, number, string object. Result, table 14. To object, throw a type error exception. Throw a type error exception. Create a new boolean object whose internal property is set to the value of the argument. See 15.6 for a description of boolean objects. Create a new number object whose internal property is set to the value of the argument. See 15.7 for a description of number objects. Create a new string object whose internal property is set to the value of the argument. See 15.5 for a description of string objects. The result is the input argument no conversion. 9.10 check object coercible. The abstract operation check object coercible throws an error if its argument is a value that cannot be converted to an object using to object. It is defined by table 15. Argument type, undefined null boolean number string object. Point 11 is callable. Table 15. Check object coercible results. Result. Throw a type error exception. Throw a type error exception. Return. The abstract operation is callable determines if its argument, which must be any ECMAScript language value, is a callable function object according to table 16. ECMA International 2009-49. Argument type, undefined null boolean number string object. Table 16. Is callable results. Return false. If the argument object has an internal method, then return true. Otherwise return false. Result 9.12 the same value algorithm. The internal comparison abstract operation same value. X, Y, where X and Y
So that's all the ints, the space after it.
X is different from
I have to go back through and rename however many that are left to the actual name of type int now, and then tag the other ones with something else that's not int, so don't confuse it as an int when I want to control F to find int.
false.
So I'm going to go through and find print or whatever, rename these like that with a capital T, and then I'm going to go through and find all the int with the space before the int. Hopefully
Return false. Return true.
there's less than 4,312 left. There's probably going to be 4,000 something left. So, I'll BRB.
Global code. Global code is source text that is treated as an ECMAScript program. The global code of a particular program does not include any source text that is passed as part of a function body. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript program. The eval code for a particular invocation of eval is the global code portion of that program. Function code is source text that is passed as part of a function body. The function code of a particular function body does not include any source text that is passed as part of a nested function body. Function code also denotes the source text supplied when using the built-in function object as a constructor. More precisely, the last parameter provided to the function constructor is converted to a string and treated as the function body. If more than one parameter is provided to the function constructor, all parameters except the last one are converted to strings and concatenated together, separated by commas. The resulting string is interpreted as the formal parameter list for the function body defined by the last parameter. The function code for a particular instantiation of a function does not include any source text that is passed as part of a nested function body. 0. ECMA International 2009. 101. 1. Strict mode code. An ECMAScript program's syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. When processed using strict mode, the three types of ECMAScript code are referred to as strict global code, strict eval code, and strict function code. Code is interpreted as strict mode code in the following situations. Global code is strict global code if it begins with a directive prologue that contains a use strict directive. See 14.1. Eval code is strict eval code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct call. See 1.5. 1. 2. 1. 1. To the eval function that is contained in strict mode code. Function code that is part of a function declaration, function expression, or access a property assignment is strict function code if its function declaration, function expression, or property assignment is contained in strict mode code or if the function code begins with a directive prologue that contains a use strict directive, function code that is supplied as the last argument to the built. In function constructor as strict function code if the last argument is a string that when processed as a function body begins with a directive prologue that contains a use strict directive. 0.2 Lexical environments. A lexical environment is a specification type used to define the association of identifiers to specific variables and functions based upon the lexical nesting structure of ECMAScript code. A lexical environment consists of an environment record and a possibly null reference to an outer lexical environment. Usually a lexical environment is associated with some specific syntactic structure of ECMAScript code such as a function declaration, a with statement, or a catch clause of a try statement, and a new lexical environment is created each time such code is evaluated. An environment record records the identifier bindings that are created within the scope of its associated lexical environment. The outer environment reference is used to model the logical nesting of lexical environment values. The outer reference of a inner lexical environment is a reference to the lexical environment that logically surrounds the inner lexical environment. An outer lexical environment may, of course, have its own outer lexical environment. A lexical environment may serve as the outer environment for multiple inner lexical environments. For example, if a function declaration contains two nested function declarations, then the lexical environments of each of the nested functions will have as their outer lexical environment the lexical environment of the current execution of the surrounding function. Lexical environments and environment record values are purely specification mechanisms and need not correspond to any specific artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to directly access or manipulate such values. 0, 2, 1 Environment records. There are two kinds of environment record values used in this specification: declarative environment records and object environment records. Declarative environment records are used to define the effect of ECMAScript language syntactic elements such as function declarations, variable declarations, and catch clauses that directly associate identifier bindings with ECMAScript language values. Object environment records are used to define the effect of ECMAScript elements such as program and with statement that associate identifier bindings with the properties of some object. For specification purposes, environment record values can be thought of as existing in a simple, object-oriented hierarchy where environment record is an abstract class with two concrete subclasses: declarative environment record and object environment record. The abstract class includes the abstract specification, ECMA International 2009-51, methods defined in Table 17. These abstract methods have distinct concrete algorithms for each of the concrete subclasses. Method has binding. N. Table 17. Abstract methods of environment records. Purpose: determine if an environment record has a binding for an identifier. Return true if it does and false if it does not. The string value n is the text of the identifier. Create mutable binding. N. D. Create a new mutable binding in an environment record. The string value n is the text of the bound name. If the optional Boolean argument d is true, the binding is may be subsequently deleted. Set mutable binding. N. V. S. Set the value of an already existing mutable binding in an environment record. The string value n is the text of the bound name. V is the value for the binding and may be a value of any ECMAScript language type. S is a Boolean flag. If S is true and the binding cannot be set, throw a type error exception. S is used to identify strict mode references. Get binding value, N. S returns the value of an already existing binding from an environment record. The string value N is the text of the bound name. S is used to identify strict mode references. If S is true and the binding does not exist or is uninitialized, throw a reference error exception. Delete binding, N. Delete a binding from an environment record. The string value N is the text of the bound name. If a binding for N exists, remove the binding and return true. If the binding exists but cannot be removed, return false. If the binding does not exist, return true. Implicit this value returns the value to users. The this value on calls to function objects that are obtained as binding values from this environment record. 1 0, 2, 1, 1. Declarative environment records. Each declarative environment record is associated with an ECMAScript program scope containing variable and/or function declarations. A declarative environment record binds the set of identifiers defined by the declarations contained within its scope. In addition to the mutable bindings supported by all environment records, declarative environment records also provide for immutable bindings. An immutable binding is one where the association between an identifier and a value may not be modified once it has been established. Creation and initialization of immutable binding are distinct steps, so it is possible for such bindings to exist in either an initialized or uninitialized state. Declarative environment records support the methods listed in Table 18 in addition to the environment record abstract specification methods. Table 18. Additional methods of declarative environment records. Method: create immutable binding. N. Purpose: create a new but uninitialized immutable binding in an environment record. The string value N is the text of the bound name. Initialize immutable binding. N. V. Set the value of an already existing but uninitialized immutable binding in an environment record. The string value N is the text of the bound name. V is the value for the binding and is a value of any ECMAScript language type. 52. ECMA International 2009. The behavior of the concrete specification methods for declarative environment records are defined by the following algorithms. 0, 2, 1, 1. 1 has binding. N. The concrete environment record method has binding for declarative environment records simply determines if the argument identifier is one of the identifiers bound by the record. Let envrec be the declarative environment record for which the method was env-oct. If envrec has a binding for the name that is the value of N, return true. If it does not have such a binding, return false. 0, 2, 1, 1. 2. Create mutable binding. N. D. The concrete environment record method create mutable binding for declarative environment records creates a new mutable binding for the name and that is initialized to the value undefined. A binding must not already exist in this environment record for n if Boolean argument D is provided and has the value true. The new binding is marked as being subject to deletion. Let envrec be the declarative environment record for which the method was invoked. Assert envrec does not already have a binding for n. Create a mutable binding in envrec for n and set its bound value to undefined. If D is true, record that the newly created binding may be deleted by a subsequent delete binding call. 0, 2, 1, 1. 3. Set mutable binding. N. V. S. The concrete environment record method set mutable binding for declarative environment records attempts to change the bound value of the current binding of the identifier whose name is the value of the argument n to the value of argument va binding. For n must already exist. If the binding is an immutable binding, a type error is always thrown. The S argument is ignored because strict mode does not change the meaning of setting bindings in declarative environment records. Let envrec be the declarative environment record for which the method was invoked. Assert envrec must have a binding for n. If the binding for n in envrec is a mutable binding, change its bound value to v. Else this must be an attempt to change the value of an immutable binding, so throw a type error exception. 0, 2, 1, 1. 4. Get binding value. N. S. The concrete environment record method get binding value for declarative environment records simply returns the value of its bound identifier whose name is the value of the argument and the binding must already exist. If S is true and the binding is an uninitialized immutable binding, throw a reference error exception. Let envrec be the declarative environment record for which the method was invoked. Assert envrec has a binding for n. If the binding for n in envrec is an uninitialized immutable binding, then, if S is false, return the value undefined. Otherwise, throw a reference error exception for else. Return the value currently bound to n in envrec 0, 2, 1, 1, 5. Delete binding n. The concrete environment record method delete binding for declarative environment records can only delete bindings that have been explicitly designated as being subject to deletion. Let envrec be the declarative environment record for which the method was invoked. If envrec does not have a binding for the name that is the value of n, return true. If the binding for n in envrec is cannot be deleted, return false. ECMA International 2009 53. 4. Remove the binding for n from envrec. Return true. 0, 2, 1, 1, 6. Implicit this value. Declarative environment records always return undefined as their implicit this value. Return undefined. 0, 2, 1, 1, 7. Create immutable binding n. The concrete environment record method create immutable binding for declarative environment records creates a new immutable binding for the name n that is initialized to the value undefined. A binding must not already exist in this environment record for n. Let envrec be the declarative environment record for which the method was invoked. Assert envrec does not already have a binding for n. Create an immutable binding in envrec for n and record that it is uninitialized. 0, 2, 1, 1, 8. Initialize immutable binding n v. The concrete environment record method initialize immutable binding for declarative environment records is used to set the bound value of the current binding of the identifier whose name is the value of the argument n to the value of argument vn. Uninitialized immutable binding for n must already exist. Let envrec be the declarative environment record for which the method was invoked. Assert envrec must have an uninitialized immutable binding for n. Set the bound value for n in envrec to v. Record that the immutable binding for n in envrec has been initialized. 0, 2, 1, 2. Object environment records. Each object environment record is associated with an object called its binding object. An object environment record binds the set of identifier names that directly correspond to the property names of its binding object. Property names that are not an identifier name are not included in the set of bound identifiers. Both own and inherited properties are included in the set regardless of the setting of their attribute. Because properties can be dynamically added and deleted from objects, the set of identifiers bound by an object environment record may potentially change as a side effect of any operation that adds or deletes properties. Any bindings that are created as a result of such a side effect are considered to be immutable binding, even if the writable attribute of the corresponding property has the value false. Immutable bindings do not exist for object environment records. Object environment records can be configured to provide their binding object as an implicit this value for use in function calls. This capability is used to specify the behavior of with statement 12.10, induced bindings. The capability is controlled by a provide this Boolean value that is associated with each object environment record. By default, the value of provide this is false for any object environment record. The behavior of the concrete specification methods for object environment records is defined by the following algorithms. 0, 2, 1, 2, 1 has binding n. The concrete environment record method has binding for object environment records determines if its associated binding object has a property whose name is the value of the argument n. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Return the result of calling the internal method of bindings, passing n as the property name. 4. Copyright sign. ECMA International 2009 10, 2, 1, 2. To create mutable binding n. D. The concrete environment record method create mutable binding for object environment records creates an environment records associated binding object a property whose name is the string value and initializes it to the value undefined. A property named n must not already exist in the binding object. If Boolean argument d is provided and has the value true, the new property's attribute is set to true. otherwise it is set to false. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Assert the result of calling the internal method of bindings, passing n as the property name, is false. If d is true, then let config value be true, otherwise let config value be false. Call the internal method of bindings, passing n, property descriptor, undefined, true, true, config value, and false as arguments. 0, 2, 1, 2, 3 set mutable binding, n, v, s. The concrete environment record method set mutable binding for object environment records attempts to set the value of the environment records associated binding object's property whose name is the value of the argument n to the value of argument v. A property named n should already exist, but if it does not or is not currently writable, error handling is determined by the value of the Boolean argument s. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Call the 0, 2, 1, 2, 4 get binding value, n, s. The concrete environment record method get binding value for object environment records returns the value of its associated binding object's property whose name is the string value of the argument identifier, and the property should already exist, but if it does not, the result depends upon the value of the s argument. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Let value be the result of calling the internal method of bindings, passing n as the property name. If value is false, then, if s is false, return the value undefined, otherwise throw a reference error exception 5. Return the result of calling the 0, 2, 1, 2, 5 delete binding, n. The concrete environment record method delete binding for object environment records can only delete bindings that correspond to properties of the environment object whose attribute have the value true. Let envrec be the object environment record for which the method was invoked. Let bindings be the binding object for envrec. Return the result of calling the internal method of bindings, passing n and false as arguments. 0, 2, 1, 2, 6 implicit this value. Object environment records return undefined as their implicit this value unless their provide this flag is true. Let envrec be the object environment record for which the method was invoked. If the provide this flag of envrec is true, return the binding object for envrec. Otherwise, return undefined. ECMA International 2009 55 102 2 lexical environment operations. The following abstract operations are used in this specification to operate upon lexical environments. 0, 2, 2, 1 get identifier reference, lex, name, strict. The abstract operation get identifier reference is called with a lexical environment's lex, an identifier string name, and a Boolean flag strict. The value of lex may be null. When called, the following steps are performed. If lex is the value null, then return a value of type reference whose base value is undefined, whose reference name is name, and whose strict mode flag is strict. Let envrec be lex's environment record. Let exists be the result of calling the has binding, n, concrete method of envrec passing name as the argument n. If exists is true, then return a value of type reference whose base value is envrec, whose reference name is name, and whose strict mode flag is strict. Else, let outer be the value of lex's outer environment reference. B return the result of calling get identifier reference passing outer, name, and strict as arguments. 0, 2, 2, 2. When the abstract operation new declarative environment is called with either a lexical environment or null as argument, the following steps are performed. Let env be a new lexical environment. Let envrec be a new declarative environment record containing no bindings. Set env's environment record to be envrec. Set the outer lexical environment reference of env to e. Return env 0, 2, 2, 3 new object environment. E. When the abstract operation new object environment is called with an object O and a lexical environment D, or null, as arguments, The following steps are performed. Let env be a new lexical environment. Let env-rec be a new object environment record containing O as the binding object. Set env's environment record to be env-rec. Set the outer lexical environment reference of env to E. Return env 0, 2, 3. The global environment. The global environment is a unique lexical environment which is created before any ECMAScript code is executed. The global environment's environment record is an object environment record whose binding object is the global object. 15.1. The global environment's outer environment reference is null. As ECMAScript code is executed, additional properties may be added to the global object and the initial properties may be modified. 0.3 Execution contexts. When control is transferred to ECMAScript executable code, control is entering an execution context. Active execution contexts logically form a stack. The top execution context on this logical stack is the running execution context. A new execution context is created whenever control is transferred from the executable code associated with the currently running execution context to an executable code that is not associated with. New declarative environment. E6. Copyright sign. ECMA International 2009. That execution context. The newly created execution context is pushed onto the stack and becomes the running execution context. An execution context contains whatever state is necessary to track the execution progress of its associated code. In addition, each execution context has the state components listed in Table 19. Component, lexical environment, variable environment. This binding, Table 19. Execution context state components. Purpose identifies the lexical environment used to resolve identifier references made by code within this execution context. Identifies the lexical environment whose environment record holds bindings created by variable statements and function declarations within this execution context. The value associated with this keyword within ECMAScript code associated with this execution context. The lexical environment and variable environment components of an execution context are always lexical environments. When an execution context is created, its lexical environment and variable environment components initially have the same value. The value of the variable environment component never changes, while the value of the lexical environment component may change during execution of code within an execution context. In most situations, only the running execution context, the top of the execution context stack, is directly manipulated by algorithms within this specification. Hence, when the terms lexical environment, variable environment and this binding are used without qualification, they are in reference to those components of the running execution context. An execution context is purely a specification mechanism and need not correspond to any particular artifact of an ECMAScript implementation. It is impossible for an ECMAScript program to access an execution context. 0, 3. 1. Identifier resolution. Identifier resolution is the process of determining the binding of an identifier using the lexical environment of the running execution context. During execution of ECMAScript code, the syntactic production primary expression, identifier is evaluated using the following algorithm. Let env be the running execution context's lexical environment. If the syntactic production that is being evaluated is contained in a strict mode code, then let strict be true, else let strict be false. Return the result of calling getIdentifier reference function parsing env, identifier, and strict as arguments. The result of evaluating an identifier is always a value of type reference with its reference name component equal to the identifier string. 0.4 Establishing an execution context. Evaluation of global code or code using the eval function 15, 1, 2, 1. Establishes and enters a new execution context. Every invocation of an ECMAScript code function 13, 2, 1 also establishes and enters a new execution context, even if a function is calling itself recursively. Every return exits an execution context. A thrown exception may also exit one or more execution contexts. When control enters an execution context, the execution contexts this binding is set, its variable environment and initial lexical environment are defined. and declaration binding instantiation, 10.5, is performed. The exact manner in which these actions occur depend on the type of code being entered. ECMA International 2009 57 1041 entering global code. The following steps are performed when control enters the execution context for global code. Initialize the execution context using the global code as described in 1041. 1. Perform declaration binding instantiation as described in 10.5 using the global code. 0, 4, 1. 1. Initial global execution context. The following steps are performed to initialize a global execution context for ECMAScript code C. Set the variable environment to the global environment. Set the lexical environment to the global environment. Set the this binding to the global object. 0, 4. 2. Entering eval code. The following steps are performed when control enters the execution context for eval code. If there is no calling context or if the eval code is not being evaluated by a direct call. 1 5 1 2 1 1 to the eval function, then A. Initialize the execution context as if it was a global execution context using the eval code as C as described in 1 0 4 1 1. Else, A. Set the this binding to the same value as the this binding of the calling execution context. B. Set the lexical environment to the same value as the lexical environment of the calling execution context. C. Set the variable environment to the same value as the variable environment of the calling execution context. If the eval code is strict code, then, a let strict var_env be the result of calling new declarative environment passing the lexical environment as the argument. B. Set the lexical environment to strict var_env. C. Set the variable environment to strict var_env. Perform declaration binding instantiation as described in 10.5 using the eval code. 0, 4, 2, 1. Strict mode restrictions. The eval code cannot instantiate variable or function bindings in the variable environment of the calling context that invoke the eval of either the code of the calling context or the eval code is strict code. Instead, such bindings are instantiated in a new variable environment that is only accessible to the eval code. 0, 4, 3. Entering function code th. Following steps are performed when control enters the execution context for function code contained in function object f. A caller provided this arg, and a caller provided arguments list. If the function code is strict code, set the this binding to this arg. Else if this arg is null or undefined, set the this binding to the global object. Else if type this arg is not object, set the this binding to object. This arg. Else set the this binding to this arg. Let local env be the result of calling new declarative environment passing the value of the internal property of f as the argument. Set the lexical environment to local env. Set the variable environment to local env. Let code be the value of f's internal property. Perform declaration binding instantiation using the function code and argument list as described in 0.5. 8. ECMA International 2009 10.5 Declaration Binding Instantiation. Every execution context has an associated variable environment. Variables and functions declared in ECMAScript code evaluated in an execution context are added as bindings in that variable environment's environment record. For function code, parameters are also added as bindings to that environment record. Which environment record is used to bind a declaration and its kind depends upon the type of ECMAScript code executed by the execution context, but the remainder of the behavior is generic. On entering an execution context, bindings are created in the variable environment as follows using the caller-provided code and, if it is function code, argument list args. Let env be the environment record component of the running execution context's variable environment. If code is eval code, then let configurable bindings be true, else let configurable bindings be false. If code is strict mode code, then let strict be true, else let strict be false. If code is function code, then let fun be the function whose internal method initiated execution of code. Let names be the value of func's internal property. B. Let arg count be the number of elements in args. C. Let n be the number 0. D. For each string arg name in names, in list order do I let n be the current value of n plus 1. 2. If n is greater than arg count, let v be undefined, otherwise let v be the value of the nth element of args. 3. Let arg already declared be the result of calling env's has binding concrete method passing arg name as the argument. If arg already declared is false, call env's create mutable binding concrete method passing arg name as the argument. V call env's set mutable binding concrete method passing arg name v and strict as the arguments for each function declaration f in code. In source text order do a let fn be the identifier in function declaration f, b let fo be the result of instantiating function declaration f as described in clause 13, c let func already declared be the result of calling env's has binding concrete method passing fn as the argument. D if func already declared is false, call env's create mutable binding concrete method passing fn and configurable bindings as the arguments. Call env's set mutable binding concrete method passing fn, fo, and strict as the arguments. Let arguments already declared be the result of calling env's has binding concrete method passing arguments as the argument. If code is function code and arguments already declared is false, then a let args obj be the result of calling the abstract operation create arguments object. 10.6. Passing func names args env and strict as arguments. B if strict is true, then I call env's create immutable binding concrete method passing the string arguments as the argument. 2. Call env's initialize immutable binding concrete method passing arguments and args obj as arguments. C else I call env's create mutable binding concrete method passing the string arguments as the argument. 2. Call env's set mutable binding concrete method passing arguments args obj and false as arguments for each variable declaration and variable declaration no in D in code. In source text order do a let dn be the identifier in D, b let var already declared be the result of calling env's has binding concrete method passing dn as the argument. C if var already declared is false, then I call env's create mutable binding concrete method passing dn and configurable bindings as the arguments. ECMA International 2009 59. 2. Call env's set mutable binding concrete method passing dn, undefined, and strict as the arguments. 0.6 Arguments object. When control enters an execution context for function code, an arguments object is created unless as specified in 10.5. The identifier arguments occurs as an identifier in the function's formal parameter list or occurs as the identifier of a variable declaration or function declaration contained in the function code. The arguments object is created by calling the abstract operation create arguments object with arguments func. The function object whose code is to be evaluated names a list containing the function's formal parameter names. Args the actual arguments passed to the internal method, env the variable environment for the function code, and strict a boolean that indicates whether or not the function code is strict code. When create arguments object is called, the following steps are performed. Let len be the number of elements in args. Let obj be the result of creating a new ECMAScript object. Set all the internal methods of obj as specified in 8.12. Set the internal property of obj to arguments. Let object be the standard built-in object constructor. 1.5. 2. 2. Set the internal property of obj to the standard built-in object prototype object. 1.5. 2. 4. Call the internal method on obj passing length, the property descriptor len, true, false, true, and false as arguments. Let map be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. Let mapped names be an empty list. 0. Let index equals len1, 1. Repeat while index equals 0. A let val be the element of args at 0 origin list position index. B call the internal method on obj passing to string index, the property descriptor val, true, 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 and false as arguments. C if index is less than the number of elements in names, then I let name be the element of names at 0 origin list position index. 2. If strict is false and name is not an element of map names, then add name as an element of the list map names. Let G be the result of calling the make arg getter abstract operation with arguments name and env. Let P be the result of calling the make arg setter abstract operation with arguments name and env. Call the internal method of map passing to string inx the property descriptor G true and falses arguments D. Let inx equals inx1 2. If map names is not empty, then A. Set the internal property of obj to map. B. Set the and internal methods of obj to the definitions provided below. 3. If strict is false, then A. Call the internal method on obj passing call E. The property descriptor func true, false, true, and false as arguments. 4. Else strict is true, so 0. ECMA International 2009 AB. Let thrower be the function object 1 3 2 3. Call the internal method of obj with arguments caller property descriptor thrower false, false, and false. C. Call the internal method of obj with arguments call E. Property descriptor thrower false, false, and false. 5. Return obj. The abstract operation make arg get called with string name and environment record env creates a function object that when executed returns the value bound for name and env. It performs the following steps. Let body be the result of concatenating the strings return name and return the result of creating a function object as described in 13.2 using no formal parameter list. Body for function body, env as scope, and true for strict. The abstract operation make arg set called with string name and environment record env creates a function object that when executed sets the value bound for name and env. It performs the following steps. Let param be the string ng name concatenated with the string arg. Let body be the string name equals param with name replaced by the value of name and param replaced by the value of param. Return the result of creating a function object as described in 13.2 using a list containing the single string param as formal parameter list, body for function body, env as scope, and true for strict. The called with a property name P performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing P as the argument. If the value of is mapped is undefined, then A, B, let V be the result of calling the default. If P is caller and V is a strict mode function object, throw a type error exception. Return V, C, else. Map contains a formal parameter mapping for P, so A return the result of calling the internal method of an arguments object for a non-strict mode function with formal parameters when called with a property name P performs the following steps. Let desk be the result of calling the default internal method 8 1 2 1 on the arguments object passing P as the argument. If desk is undefined then return desk. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing P as the argument. If the value of is mapped is not undefined, then A set desk to the result of calling the return desk. The internal method of an arguments object for a non-strict mode function with formal parameters when called with a property name P. Property descriptor desk and boolean flag throw performs the following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method of map passing P as the argument. Let allowed be the result of calling the default internal method 8 1 2 9 on the object.
The process of finding and replacing text is way too repetitive.
Is mapped is not undefined, then ECMA International
I can only take so much more. Maybe like
desk is true, then I call the internal
4,312 more. That's about my limit.
desk and throw as the arguments.
Then I have to call it quits for today.
Then call the internal method of map passing P and false as arguments. Return true. The internal method of an arguments.
Then tomorrow, I gotta go through again and find however many left.
The following steps. Let map be the value of the internal property of the arguments object. Let is mapped be the result of calling the internal method.
And then replace them with
of calling the default internal method 812.7 on the arguments object, passing p and throw as the arguments. If result is true and the value of is mapped is not undefined, then call the internal method of map passing p and false as the arguments 5. Return result. Note 1 for non-strict mode functions the array index.
because this keyword or whatever, that can be this, whatever.
Name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the functions. Execution context. This means that changing the property change.
I can define it as 32-bit whatever, or 64-bit.
Defined or if the
And I don't have to like Control F, replace across the whole program again ever.
the copy of the arguments path
I should have defined things like this in the first place.
use. Note 2 the parameter map user used as a device for specifying the arguments object correspondence to argument by
That I can just pick is that our int or 64-bit,
possible from east.
but so I gotta go through and replace all these
Actually create or use such objects to implement the
with this,
Note 3 arguments objects
so I can build the program like this, and it's 64-bit.
exception on access. The Corley
There's still the 64-bit arithmetic, but that's after all the typecasting is done.
patients. The strict
So I'm gonna like run it to make sure it builds, save it back up. I need to turn on the debug stuff,
syntax primary
so it's possible to know if it broke between replacing. But I'll deal with that later. I'm just gonna find and replace the rest of these
sign ECMA International
4,312 matches. Anything else is gonna get me off track. Just keep going.
fire is always a value of type reference 1.
So I'm gonna run it and then save it back up, then replace the rest. And I can't take any more of this.
Array initializer is an expression describing the initialization of an array object.
This is so mind-numbingly boring.
Each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. Array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list,
The year's 2025. The text editor should have a type. You can type once and then have it change across 4,000 or 5,000 places by changing one place instead of having to go through 4,500 something places, replace each one individually. And also, you can define something as a keyword to represent another thing, but if you ever want to replace that thing itself, you still got to go through 4,000 however many places to replace that keyword that it's defined as. I'm not talking about a keyword that can represent different things. I'm talking about different things in multiple places across multiple files being represented by one name that can be changed across all those locations in one place in any file at any time without having to go through every single motherfucking file and find and replace. It's 2025, for fuck's sake. Anyways, I'm gonna keep going. It looks like a build. I'm gonna save it back up after I click run. I'm gonna get through this, and this is so ridiculous.
1.
The year is 2025. Why the fuck do we use text editors in files and folders? There's 3D CAD programs because 3D video games and programming is still done in a motherfucking text editor like it's 1970.
Int x, the property descriptor, init value.
I rest my case.
Return array, the production element list. Eligible assignment expression is evaluated as follows. Let array be the result of evaluating element list. Let
I think it's all fine, so I'm just gonna keep going. Close the program, save it back up. Use 5,000, however many, or 4,000, however many, doesn't matter. Get this over with.
method of array with arguments to string, to 32, pad plus len, and the property descriptor, init value, true, and false. Return array, the production elision, is evaluated as follows. Return the numeric value 1. The production elision is evaluated as follows. Let preceding be the result of evaluating elision. Return preceding plus 1. Note is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 5 object initializer. An object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property names and associated values, enclosed in curly braces. The values need not be literals. They are evaluated each time the object initializer is evaluated. Syntax: object literal, property name and value list, property name and value list, property name and value list, property assignment, property name and value list, property assignment, property name, assignment expression, get property name, function body, set property name, property set parameter list, function body. 4. ECMA International 2009. Property name, identifier name, string literal numeric literal, property set parameter list, identifier. Semantics: the production object literal is evaluated as follows. Return a new object created as if by the expression new object, where object is the standard built-in constructor with that name. The production's object literal, property name and value list, and object literal, property name and value list, are evaluated as follows. Return the result of evaluating property name and value list. The production property name and value list, property assignment is evaluated as follows. Let obj be the result of creating a new object as if by the expression new object, where object is the standard built-in constructor with that name. Let prop_id be the result of evaluating property assignment. Call the internal method of obj with arguments prop_id name, prop_id descriptor, and false. Return obj, the production, property name and value list, property name and value list, property assignment is evaluated as follows. Let obj be the result of evaluating property name and value list. Let prop_id be the result of evaluating property assignment. Let previous be the result of calling the internal method of obj with argument prop_id name. If previous is not undefined, then throw a syntax error exception if any of the following conditions are true. A. This production is contained in strict code and is data descriptor. Previous is true and is data descriptor.
I forgot to put a space
Previous is true
in front of any matches like this, so I can't just look for all these. I'm gonna have to look again for things with the space after and things with the space before, so that's cool. Well, for now I already got these done. Space after, so now I gotta get ones with the space before. Oh my god, this is important.
Clause 16. That production property assignment, property name, assignment expressioni servaluaterdas follows. Let prop name be the result of evaluating property name. Let exp value be the result of evaluating assignment expression. Let prop value be get value, exp value. Let desk be the property descriptor, prop value, true, configurable, true. Return property identifier, prop name, desk. ECMA International 2009 65. The production property assignment, get property name, function body, is evaluated as follows. Let prop name be the result of evaluating property name. Let closure be the result of
Well, that's disappointing. I pasted into Control F for find.
Pass in the lexical environment of the running execution context as the scope. Pass in true as the strict flag if the property assignment is contained in strict code or if it's
I'll just zoom in.
desk be the property descriptor. True, true, return property identifier, prop name, desk, the
And I was like, oh my god, only 42 matches. I don't have to go through 4,000. And I'm like, oh, wait a second. And I realized that I pasted, there's a space after it. Not just before. So now I gotta get rid of that space after it. And then do find again. See how many come up.
action body is
It's kind of disappointing.
return property identifier, prop name.
So the real number is
Tax error if the identifier eval or the identifier arguments occurs as the identifier in
hooray. Only
A, capital P, R.
4,188. Only 91 files left to go.
S, I, G, N, M, E, N.
So it's less. Which is good. It's less. But yeah,
The production property name.
this is programming in 2025. Real-time programming. Not copy-paste, steal code. This is programming, like real programming.
Evaluated as follows. Let NBR be the
This is ridiculous.
NBR.
I never want to convert anything to 64-bit ever again.
Evaluated as follows. Return the result of evaluating expression. This may be of type reference. Note this algorithm does not apply get value to the result of evaluating expression.
So now I only have
And type off may be applied to parenthesized expressions. 1.2 left-hand side expressions. Syntax. Member expression. Primary expression. Function expression.
only 4,188 instead of 4,312. So 200 something must have had a space after it. It's probably those 42 plus 50 more something. Exciting. So I gotta go through 4,188 ints. Put the space before it. This is the difference between this.
The accesses. Properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation.
What's the difference between this?
Expression. The dot notation is explained by the following syntactic conversion. Member expression.
And this? The difference is a single space character before or after the three unique characters of I, N, T. Because it's 2025 programming, you program in a text file. And this is text editing. This is not programming. None of this has to do with logic or anything other than finding and replacing. This isn't programming. Why am I doing this? Because in 2025, the modern operating system, this is how you edit text, word by word, letter by letter, file by file. There's no such thing as a text shortcut. You can have a file shortcut.
Whose base value is base value and whose reference name is property name string, and whose strict mode flag.
You can right click here, you go like new shortcut. You can make a shortcut to files, to folders, but not to text. That'd be so useful if you have a shortcut to text, but you can't. So, some other freaking letter by letter, file by file, until it's done. The year is 2025. And this is text editing on the modern operating system. I'm tired of complaining, so I'm gonna get going and try to get not with the space after, the space before, the rest of these space before int 4188 hashes left. So I'm gonna do that. It's gonna take even longer than the ints with the space after because there's more of them. I'm gonna take a break and I'll be back. My complaining counts as progress, and because there's 200 less of these, I don't know. I can't take this. This is so boring. I can't take it.
C1124. If type func is not object, throw a type error exception. If is callable, func is false. Throw a type error.
I still gotta save it back up. Oh no, I just did that.
True. Then I let this.
I gotta keep going.
The base of ref is an environment record. I let this value be the result of calling the implicit this value concrete method of getBase ref7. Else type ref is not reference. I let this value be undefined. Return the result of calling the internal method on func, providing this value as the this value and providing the list arglist as the argument values. The production call expression arguments is evaluated in exactly the same manner, except that the contained call expression is evaluated in step 1. Note the returned result will never be of type reference if func is a native ECMAScript object. Whether calling a host object can return a value of type reference is implementation dependent. If a value of type reference is returned, it must be a non-strict property reference. 1, 2, 4 argument lists. The evaluation of an argument list produces a list of values, C 8.8. The production arguments is evaluated as follows. 8. Copyright sign, ECMA International 2009. 1. Return an empty list. The production arguments argument list is evaluated as follows. Return the result of evaluating argument list. The production argument list assignment expression is evaluated as follows. Let ref be the result of evaluating assignment expression. Let arg be get value. Ref. Return a list whose sole item is arg. The production argument list assignment expression is evaluated as follows. Let preceding args be the result of evaluating argument list. Let ref be the result of evaluating assignment expression. Let arg be get value. Ref. Return a list whose length is 1 greater than the length of preceding args and whose items are the items of preceding args, in order, followed at the end by arg which is the last item of the new list. 1, 2, 5 function expressions. The production member expression, function expression is evaluated as follows. 1. Return the result of evaluating function expression. 1.3 postfix expressions syntax. Postfix expression, left-hand side expression, no line terminator here, plus left-hand side expression, no line terminator here. 1, 3, 1 postfix increment operator. The production postfix expression, left-hand side expression, no line terminator here, plus is evaluated as follows. Let LHS be the result of evaluating left-hand side expression. Throw a syntax error exception if the following conditions are all true. Type LHS is references true. Is strict reference LHS is true. Type getBase LHS is environment record. Get reference name LHS is either eval or arguments. Let old value be to number. Get value LHS. Let new value be the result of adding the value 1 to old value. using the same rules as for the plus operator. C 1 6 3 call put value LHS new value return old value 1 3 2 postfix decrement operator. The production postfix expression, left-hand side expression, no line terminator here, is evaluated as follows. Let LHS be the result of evaluating left-hand side expression. Throw a syntax error exception if the following conditions are all true. Type LHS is reference as true. ECMA International 2009 69, comma is strict reference. LHS is true. Type get base LHS is environment record. Get reference name LHS is either eval or arguments. Let old value be to number. Get value LHS. Let new value be the result of subtracting the value 1 from old value, using the same rules as for the operator. 1 1 6 3 call put value LHS new value return old value. 1.4 Unary operators syntax. Unary expression postfix expression delete unary expression void unary expression type of unary expression plus unary expression plus unary expression unary expression unary expression unary expression 1 4 1 The delete operator. The production unary expression delete unary expression is evaluated as follows. Let ref be the result of evaluating unary expression. If type ref is not reference, return true. If is unresolvable reference, ref, then if is strict reference, ref is true. Throw a syntax error exception. Be else, return true. If is property reference, ref is true, then a return the result of calling the internal method onto object get base ref, providing get reference name ref and is strict reference ref as the arguments. Else, ref is a reference to an environment record binding. So, ABC. Note, unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, a type error exception is thrown. 1 4 2 Avoid operator. The production unary expression void unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Call get value expressway return undefined. Note get value must be called even though its value is not used because it may have observable side effects. If is strict reference ref is true, throw a syntax error exception. Let bindings be get base ref return the result of calling the delete binding concrete method of bindings, providing get reference name ref as the argument. When a delete operator occurs within strict mode code, a syntax error exception is thrown if it's 0. Copyright sign ECMA International 2009 1 4 3 The tipioff operator. The production unary expression type of unary expression is evaluated as follows. Let val be the result of evaluating unary expression. If type val is reference, then if is unresolvable reference, val is true, return undefined. B let val be get value val return a string determined by type val according to table 20. Table 20 type of operator results. Type of val undefined. Null boolean number string object native and does not implement object native or host and does implement object host and does not implement result undefined object boolean number string object function implementation defined except may not be undefined boolean number or string 1 4 prefix increment operator. The production unary expression plus unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Throw a syntax error exception if the following conditions are all true. Type expa is reference is true is strict reference expa is true. Type get base expa is environment record. Get reference name expa is either eval or arguments. Let old value be to number get value expa. Let new value be the result of adding the value 1 to old value, using the same rules as for the plus operator. C 1 6 3 call put value expressway new value return new value 1 4 5 prefix decrement operator. The production unary expression unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Throw a syntax error exception if the following condet I and are all true. Type expa is references true is strict reference. Expa is true. Type get base. Expa is environment record. Get reference name. Expa is either eval or arguments. Let old value be to number. Get value. Expa ECMA International 2009 71 4. Let new value be the result of subtracting the value 1 from old value, using the same rules as for the operator. C11 6 3. Call put value expressway. New value return new value 1 4 6. Unary plus operator. The unary plus operator converts its operand to number type. The production unary expression plus unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Return to number. Get value. Expa 1 4 7. Unary operator. The unary operator converts its operand to number type and then negates it. Note that negating plus 0 produces 0, and negating 0 produces plus 0. The production unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Let old value be to number. Get value. Expa. If old value is nan, return nan. Return the result of negating old value. That is, compute a number with the same magnitude but opposite sign. 1 4 8 bitwise not operator. The production unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Let old value be to int 32. Get value. Expa. Return the result of applying bitwise complement to old value. The result is a signed 32-bit integer. 1 4 9. Logical not operator. The production unary expression is evaluated as follows. Let expa be the result of evaluating unary expression. Let old value be to boolean. Get value. Expa. If old value is true, return false. Return true. 1.5 Multiplicative operators syntax. Multiplicative expression. Unary expression. Multiplicative expression. Unary expression. Multiplicative expression. Unary expression. Multiplicative expression. Percent. Unary expression. Semantics. The production multiplicative expression at unary expression, where at stands for one of the operators in the above definitions, is evaluated as follows. 2. Copyright sign. ECMA International 2009 1. Let left be the result of evaluating multiplicative expression. Let left value be get value. Left. Let right be the result of evaluating unary expression. Let right value be get value. Right. Let left num be to number. Left value. Let right num be to number. Right value. Return the result of applying the specified operation, comma or percent, to left num and right num. See the notes below. 1 1 5 1 1 1 5 2 1 1 5 3 1 5 1. Applying the operator performs multiplication, producing the product of its operands. Multiplication is commutative. Multiplication is not always associative in ECMAScript. Because of finite precision, the result of a floating point multiplication is governed by the rules of IEEE 754 binary double precisio n arithmetic. If either operand is nan, the result is nan. The sign of the result is positive if both operands have the same sign. Negative if the operands have different signs. Multiplication of an infinity by a 0 results in nan. Multiplication of an infinity by an infinity results in an infinity. The sign is determined by the rule already stated above. Multiplication of an infinity by a finite non-zero value results in a signed infinity. The sign is determined by the rule already stated above. In the remaining cases, where neither an infinity or none is involved, the product is computed and rounded to the nearest representable value using IEEE 754 round to nearest mode. If the magnitude is too large to represent, the result is then an infinity of appropriate sign. If the magnitude is too small to represent, the result is then a 0 of appropriate sign. The ECMAScript language requires support of gradual underflow as defined by IEEE 754 1 5. To applying the operator performs division, producing the quotient of its operands. The left operand is the dividend and the right operand is the divisor. ECMAScript does not perform integer division. The operands and result of all division operations are double precision floating point numbers. The result of division is determined by the specification of IEEE 754 arithmetic. If either operand is nan, the result is nan. The sign of the result is positive if both operands have the same sign. Negative if the operands have different signs. Division of an infinity by an infinity results in nan. Division of an infinity by a zero results in an infinity. The sign is determined by the rule already stated above. Division of an infinity by a non-zero finite value results in a signed infinity. The sign is determined by the rule already stated above. Division of a finite value by an infinity results in zero. The sign is determined by the rule already stated above. Division of a zero by a zero results in nan. Division of zero by any other finite value results in zero. With the sign determined by the rule already stated above. Division of a non-zero finite value by a zero results in a signed infinity. The sign is determined by the rule already stated above. In the remaining cases, where neither an infinity, nor zero, nor nan is involved, the quotient is computed and rounded to the nearest representable value using IEEE 754 round to nearest mode. If the magnitude is too large to represent, the operation overflows. The result is then an infinity of appropriate sign. If the magnitude is too small to represent, the ECMA International 2009-73 operation underflows and the result is a zero of the appropriate sign. The ECMAScript language requires support of gradual underflow as defined by IEEE 754 1.5. 3. Applying the percent operator. The percent operator yields the remainder of its operands from an implied division. The left operand is the dividend and the right operand is the divisor. Note in C and C++, the remainder operator accepts only integral operands. In ECMAScript, it also accepts floating point operands. The result of a floating point remainder operation as computed by the percent operator is not the same as the remainder operation defined by IEEE 754. The IEEE 754 remainder operation computes the remainder from a rounding division, not a truncating division, and so its behavior is not analogous to that of the usual integer remainder operator. Instead, the ECMAScript language defines percent on floating point operations to behave in a manner analogous to that of the Java integer remainder operator. This may be compared with the C library function fmod. The result of an ECMAScript floating point remainder operation is determined by the rules of IEEE arithmetic. If either operand is nan, the result is nan. The sign of the result equals the sign of the dividend. If the dividend is an infinity, or the divisor is a zero, or both, the result is nan. If the dividend is finite and the divisor is an infinity, the result equals the dividend. If the dividend is a zero and the divisor is finite, the result is the same as the dividend. In the remaining cases, where neither an infinity, nor zero, nor nan is involved, the floating point remainder r from a dividend n and a divisor d is defined by the mathematical relation r equals n dq, where q is an integer that is negative only if nd is negative and positive only if nd is positive, and whose magnitude is as large as possible without exceeding the magnitude of the true mathematical quotient of n and d. 1.6 Additive operators syntax. Additive expression, multiplicative expression, additive expression plus multiplicative expression, additive expression, multiplicative expression. 1. 6. 1. The addition operator plus the addition operator either performs string concatenation or numeric addition. The production additive expression plus multiplicative expression is evaluated as follows. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let ref be the result of evaluating multiplicative expression. Let val be get value. Ref. Let prim be to primitive. Val. Let reprim be to primitive. Reval. If type prim is string or type reprim is string, then return the string that is the result of concatenating to string prim followed by to string reprim. 8. Return the result of applying the addition operation to number prim and to number reprim. See the note below. 1.1.6.3. Note 1. No hint is provided in the calls to primitive in steps 5 and 6. All native ECMAScript objects except date objects handle the absence of a hint as if the hint number were given. Date objects handle the absence of a hint as if the hint string were given. Host objects may handle the absence of a hint in some other manner. 4. Copyright sign. ECMA International 2009. Note 2 Step 7 differs from Step 3 of the comparison algorithm. M for the relational operators. 1, 1, 8, 5. By using the logical or operation instead of the logical and operation. 1, 6. To the subtraction operator. The production additive expression. Multiplicative expression is evaluated as follows. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let ref be the result of evaluating multiplicative expression. Let val be get value. Ref. Let num be to number. Val. Let renum be to number. Reval. Return the result of applying the subtraction operation till num and renum. See the note below. 1, 1, 6, 3, 1, 6, 3. Applying the additive operators to numbers. The plus operator performs addition when applied to two operands of numeric type, producing the sum of the operands. The operator performs subtraction, producing the difference of two numeric operands. Addition is a commutative operation, but not always associative. The result of an addition is determined using the rules of IEEE 754 binary double precision arithmetic. If either operand is nan, the result is nan. The sum of two infinities of opposite sign is nan. The sum of two infinities of the same sign is the infinity of that sign. The sum of an infinity and a finite value is equal to the infinite operand. The sum of two negative zeros is 0. The sum of two positive zeros, or of two zeros of opposite sign, is plus 0. The sum of a 0 and an non-zero finite value is equal to the non-zero operand. The sum of two non-zero finite values of the same magnitude and opposite sign is plus 0. In the remaining cases, where neither an infinity, nor a 0, nor nan is involved, and the operands have the same sign or have different magnitudes, the sum is computed and rounded to the nearest representable value using IEEE 754 round to nearest mode. If the magnitude is too large to represent, the operation overflows and the result is then an infinity of appropriate sign. The ECMAScript language requires support of gradual underflow as defined by IEEE 754. The operator performs subtraction when applied to two operands of numeric type, producing the difference of its operands. The left operand is the minuend and the right operand is the subtrahend. Given numeric operands A and B, it is always the case that AB produces the same result as A plus B. 1.7 bitwise shift operators syntax. Shift expression, additive expression, shift expression, additive expression, shift expression, additive expression, shift expression, additive expression. 1, 7. 1. The left shift operator performs a bitwise left shift operation on the left operand by the amount specified by the right operand. ECMA International 2009 75. The production shift expression, additive expression is evaluated as follows. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let num be 32. Val. Let renum be 32. Val. Let shift count be the result of masking out all but the least significant 5 bits of renum. That is, compute renum 0 times 1f. Return the result of left shifting num by shift count bits. The result is a signed 32-bit integer 1, 7. To the signed right shift operator performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. The production shift expression, additive expression is evaluated as follows. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let num be 32. Val. Let renum be 32. Reval. Let shift count be the result of masking out all but the least significant 5 bits of renum. That is, compute renum 0 times 1f. Return the result of performing a sign extending right shift of num by shift count bits. The most significant bit is propagated. The result is a signed 32-bit integer 1, 7. 3. The unsigned right-shift operator performs a zero-filling bitwise right-shift operation on the left operand by the amount specified by the right operand. The production shift expression additive expression is evaluated as follows. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let ref be the result of evaluating additive expression. Let val be get value. Ref. Let num be 32. Val. Let renum be 32. Reval. Let shift count be the result of masking out all but the least significant 5 bits of renum. That is, compute renum 0 times 1f. Return the result of performing a zero filling right shift of num by shift count bits. Vacated bits are filled with 0. The result is an unsigned 32-bit integer. 6. ECMA International 2009. 11.8 Relational Operators Syntax. Relational expression. Shift expression. Relational expression. Shift expression. Relational expression. Shift expression. Relational expression. Equals shift expression. Relational expression. Equals shift expression. Relational expression instance of shift expression. Relational expression in shift expression. Relational expression known. 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 Equals shift expression. Relational expression known. Equals shift expression. Relational expression known instance of shift expression. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. The relational expression known productions are evaluated in the same manner as the relational expression productions, except that the contained relational expression known is evaluated instead of the contained relational expression. 1. 8. 1. The less than operator. The production relational expression, relational expression, shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let val be get value. Ref. Let r be the result of performing abstract relational comparison. Val. Reval. C11 8 5. If r is undefined, return false. Otherwise, return r1 8 to the greater than operator. The production relational expression, shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. Let r be the result of performing abstract relational comparison. Reval. Val with left first equal to false. C11 8 5. If r is undefined, return false. Otherwise, return r. The no invariants are needed to avoid confusing the in operator in a relational expression with the in semantics. Note: operator in a for statement. ECMA International 2009 77. 11 8 3. The less than or equal operator. Equals. The production relational expression, equals shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. Let rep the result of performing abstract relational comparison. Reval. Val with left first equal to false. C11 8 5. If r is true or undefined, return false. Otherwise, return true. 1 8 for the greater than or equal operator. Equals. The production relational expression, equals shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. Let r be the result of performing abstract relational comparison. Val. Reval. C11 8 5. If r is true or undefined, return false. Otherwise, return true. 1 8 5. The abstract relational comparison algorithm, the comparison x, y, where x and y values, produces true, false, or undefined, which indicates that at least one operand is none. In addition to x and y, the algorithm takes a Boolean flag named left first as a parameter. The flag is used to control the order in which operations with potentially visible side effects are performed upon X and Y. It is necessary because ECMAScript specifies left to right evaluation of expressions. The default value of left first is true and indicates that the X parameter corresponds to an expression that occurs to the left of the Y parameter's corresponding expression. If left first is false, the reverse is the case and operations must be performed upon Y before X. Such a comparison is performed as follows. If the left first flag is true, then A let px be the result of calling to primitive X, hint number. B let pi be the result of calling to primitive Y, hint number. Else the order of evaluation needs to be reversed to preserve left to right evaluation. A let pi be the result of calling to primitive Y, hint number. B let px be the result of calling to primitive X, hint number. Iphitis. A let nx be the result of calling to number px. Because px and pi are primitive values evaluation, not the case that both type px is string and type pi is string, then order is not important. B let ni be the result of calling to number pi. C if nx is nan, return undefined. D if ni is nan, return undefined. E if nx and ni are the same number value, return false. F if nx is plus 0 and ni is 0, return false. G if nx is 0 and ni is plus 0, return false. H if nx is plus, return false. I if ni is plus, return true. J if ni is, return false. K if nx is, return true. L if the mathematical value of nx is less than the mathematical value of ni. Note that these mathematical values are both finite and not both 0, return true. Otherwise, return false. Else, both px and pi are strings. If pi is a prefix of px, return false. A string value p is a prefix of string value q if q can be the result of concatenating p and some other string. R note that any string is a prefix of itself, because R may be the empty string. 8. ECMA International 2009. B if px is a prefix of pi, return true. C let k be the smallest non-negative integer such that the character at position k within px is different from the character at position k within pi. There must be such a k, for neither string is a prefix of the other. D let m be the integer that is the code unit value for the character at position k within px. E let n be the integer that is the code unit value for the character at position k within pi. F if m, n, return true. Otherwise, return false. Step 3 differs from step 7 in the algorithm for the addition operator plus 1 1, 6, 1. In using and instead of or. Note 2. Attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, string values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. Also, note that for strings containing supplementary characters, lexicographic ordering on sequences of UTF-16 code unit values differs from that on sequences of code point values. 1. 8. 6. The instantiaf operator, the production relational expression instantiaf shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. If type reval is not object, throw a type error exception. If reval does not have a instance internal method, throw a type error exception. Return the result of calling the internal method of reval with argument val. 1. 8. 7. The operator, the production relational expression in shift expression is evaluated as follows. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let ref be the result of evaluating shift expression. Let reval be get value. Ref. If type reval is not object, throw a type error exception. Return the result of calling the internal method of reval with argument to string val. 1.9 Equality operators syntax. Equality expression, relational expression. Equality expression equals 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 relational expression. Equality expression known, relational expression known. equality expression known equals relational expression known equality expression known equals relational expression known equality expression known equals relational expression known equality expression known equals relational expression known. Note 1. The comparison of strings uses a simple lexicographic ordering on sequences of code unit values. There is no ECMA International 2009-79 semantics. The result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. The equality expression known productions are evaluated in the same manner as the equality expression productions, except that the contained equality expression known and relational expression known are evaluated instead of the contained equality expression and relational expression, respectively. 1. 9. 1. The equals operator equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Return the result of performing abstract equality comparison. Reval equals laval. C11 9 3 1 9 to the does not equals operator equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let reval be get value. Ref. Let r be the result of performing abstract equality comparison. Reval equals laval. C11 9 3. If r is true, return false. Otherwise, return true. 1 9 3. The abstract equality comparison algorithm. The comparison x equals y, where x and y values, produces true or false. Comparison is performed as.
It says 4,007 matches left.
Is undefined.
I can't take it anymore. I'm done. I'm tapping out. I can't do this anymore. Tomorrow, I'll finish. Oh, the rest of these 4,000 to go.
Number value.
And I gotta go back through after again. Maybe 2 more times.
Plus.
There's probably like 2,000 total.
And false. Div type.
Oh my god. So, I'm done for now. I can't take it. I've reached my point. This is just so much. This is so boring.
X is Boolean.
It's so boring. I'm gonna like pass out from boredom.
X and Y refer.
So I'm gonna let the stream run on for 10 more minutes because this is the modern streaming software. It has this feature as being the modern streaming software that it is. It has this feature where it won't send the full stream. So if I wait like 10 more minutes after when the stream ended, maybe it'll send the whole stream because I waited longer. This is the only way that I found to bypass this feature where they like don't send the whole stream. There's no setting in the software to like turn off the don't send the whole stream feature. I guess it's just like built in to every install of the modern streaming software where they won't send the full stream. They kind of like last 10, 5, 8 minutes it might just go missing because it doesn't get sent. Or maybe it's on the receiver. Maybe it's YouTube. Maybe YouTube didn't receive it all, or YouTube stopped compressing it and storing it because they stopped receiving a signal. I don't know. Either way, I'm gonna let the stream run on until the timer hits 0. Hopefully, maybe the whole stream will send, maybe it won't. Who knows? I mean, it's brand spanking new. It's the modern technology software, the year 2025. Everything has these amazing features, such as not sending the whole stream. So I'm gonna, I don't know, tomorrow I'll finish replacing 4007 of these int space, prepending it, the int, across however many 91 files or something. For now, I've had it. I don't know. So, peace.
Order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 1, 9, for the strict equals operator, equals equals equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Return the result of performing the strict equality comparison. Reval equals val. C11 9 6 1 9 5. The strict does not equal operator equals. The production equality expression equals relational expression is evaluated as follows. Let ref be the result of evaluating equality expression. Let val be get value. Ref. Let ref be the result of evaluating relational expression. Let val be get value. Ref. Let r be the result of performing strict equality comparison. Reval equals val. C11 9 6. If r is true, return false. Otherwise, return true. 1 9 6. The strict equality comparison algorithm. The comparison x equals y, where x and y values, produces true or false. Such a comparison is performed as follows. If type x is different from type y, return false. If type x is undefined, return true. If type x is null, return true. If type x is number, then if x is nan, return false. B if y is nan, return false. C if x is the same number value as y, return true. D if x is plus 0 and I is 0, return true. E if x is 0 and I is plus 0, return true. F return false. ECMA International 2009-81. 5. If type x is string, then return true if x and y are exactly the same sequence of characters, same length and same characters in corresponding positions. Otherwise, return false. If type x is Boolean, return true if x and y are both true or both false. Otherwise, return false. Return true if x and y refer to the same object. Otherwise, return false. Note this algorithm differs from the same value algorithm 9.12 in its treatment of sign zeros and nans. 1.10 binary bitwise operators syntax. Bitwise and expression. Equality expression. Bitwise and expression and equality expression. Bitwise and expression known. Equality expression known. Bitwise and expression known and equality expression known. Bitwise or expression. Bitwise and expression. Bitwise or expression. Bitwise and expression. Bitwise or expression known. Bitwise and expression known. Bitwise or expression known. Bitwise and expression known. Bitwise or expression. Bitwise or expression. Bitwise or expression. Bitwise or expression. Bitwise or expression known. Bitwise or expression known. Bitwise or expression known. Bitwise or expression known. Semantics. The production A, at B, where at is one of the bitwise operators in the productions above, is evaluated as follows. Let return the result of applying the bitwise operator at num and renum. The result is a signed 32-bit integer. 1.11 binary logical operators syntax. Logical and expression. Bitwise or expression. Logical and expression and bitwise or expression. Logical and expression known. Bitwise or expression known. Logical and expression known and bitwise or expression known. 2. ECMA International 2009. Ref be the result of evaluating val be get value. Ref be the result of evaluating b reval be get value. Ref num be twint 32. Val renum be twint 32. Reval logical or expression. logical and expression, logical or expression, logical and expression, logical or expression known, logical and expression known, logical or expression known, logical and expression known. Semantics. The production logical and expression, logical, ND expression and bitwise or expression is evaluated as follows. Let ref be the result of evaluating logical and expression. Let val be get value. Ref. If to boolean val is false, return val. Let ref be the result of evaluating bitwise or expression. Return get value. Ref. The production logical or expression, logical or expression, logical and expression is evaluated as follows. Let ref be the result of evaluating logical or expression. Let val be get value. Ref. If to boolean val is true, return val. Let ref be the result of evaluating logical and expression. Return get value. Ref. The logical and expression known and logical or expression known productions are evaluated in the same manner as the logical and logical or expression productions, except that the contained logical and expression known, bitwise or expression known and logical or expression known are evaluated instead of the contained logical and expression, bitwise or expression and logical or expression, respectively. Note the value produced by a and or operator is not necessarily of type Boolean. The value produced will always be the value of one of the two operand expressions. 1.12 Conditional operator. Syntax. Conditional expression, logical or expression, logical or expression. Assignment expression, conditional expression known, logical or expression known, logical or expression known. Assignment expression known. Semantics. The production conditional expression, logical or expression. Assignment expression is evaluated as follows. Let ref be the result of evaluating logical or expression. If to boolean get value ref is true, then let true ref be the result of evaluating the first assignment expression. Be return get value true ref. Else let false ref be the result of evaluating the second assignment expression. Be return get value false ref. ECMA International 2009-83. The conditional expression known production is evaluated in the same manner as the conditional expression production, except that the contained logical or expression known, assignment expression and assignment expression known are evaluated instead of the contained logical or expression, first assignment expression and second assignment expression, respectively. Note the grammar for a conditional expression in ECMAScript is a little bit different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMAScript is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. 1.13 Assignment operators. Syntax. Assignment expression, conditional expression, left-hand side expression, assignment operator, assignment expression